Before you start, I really recommend you watch this intro, as this course will have 4 main components to it, and I'm going to walk you through the general process we'll be doing for this course and how everything is formatted. My name is Omar, I run the channel KwintenH, and I definitely encourage you to check out my channel at KwintenH. Link will be down below in the description. The 4 main components of this course are going to be the player, the AI skeleton monster, the GUI, which includes a profile and inventory system, and lastly, we'll be ending with some VFX to add to our game and beef it up a little bit. In the player, we'll be covering many different nodes and functionalities, including a 3D camera controller, 3D movement, then implementing our animation tree for our player using states. For the monster, we'll be covering very similar nodes to the player, and we will have some crossover with the player because we'll be needing to detect things like hitboxes, and we'll do this using an Area 3D. We'll also be covering 2 different ways to set up a state machine, what a state machine is, one with the player and one with the AI. After these 2 things are set up, we'll be going into the GUI, mainly the inventory system, which will cover several different topics, including custom resources, custom classes, and general UI interactions, allowing us to drag and drop our items. On top of the inventory system, we'll also move into creating a shop system, which allows us to buy items and finally randomized item drops when we kill monsters. So this will kind of complete our inventory system when we add all that. And the final section of this course will include VFX effects. Now, this is where I'll be introducing the basics of GPU particles. So I'll be kind of getting you started with this. We'll also kind of go over some small and little environmental things, settings that will make the game feel better. And then we'll have a surprise instructor who's much more specialized than me in VFX, and he's going to show you some much cooler effects to add to our game. And then I'll kind of end the course because he's going to kind of show you the VFX, how to make them. He'll go through the entire process using Photoshop and Blender and stuff like that. So of course, stay tuned for that, and I will see you all in the end of the course. Good luck. One last thing, if you guys don't love this format on YouTube, as this course is relatively long on YouTube, even with all the helpers with it and putting timestamps and stuff, it can be kind of daunting to do a very long course like this. So if you want, you can go on my website. I do have this course up for free. All you need to do is sign up, and you can go through the course step by step. It'll go through the actual processes of how we do things. I'll also add a few extra lectures explaining why and how we're doing something. And we'll just have a little bit of a nicer format, so that way you can kind of go step by step. And of course, you can always check out some of my other courses. I have one big course called Godot Genesis. It's a very big Godot course that will hopefully take you through many of the different genres. But of course, that's for another time. Good luck with this course, and I will see you all again at the end of this course. Bye-bye. Welcome everyone to the first section of our RPG 3D course. All right, let's get right into it. So, as you might be able to see, the first thing we're going to take a look at is everything we're going to need to download. There are quite a few things. We'll try to keep everything organized, and we'll download everything now so we don't have to kind of go in and out of engine and Google and everything throughout the course. So the first thing is, of course, the engine itself. Now, the installation for the engine is actually very easy. All we need to go is go to the Godot engine website. We'll click the download latest. And if you click this, it will prompt you to download it wherever you'd like. I just finished downloading it. You should get a zip file right here. I will show you what that will look like in just a second. Next, what we're going to be using is this GUI Golden UI. So this is a pretty neat UI. We're going to this one specifically. So you would probably want to import or export this into Godot. Download it whatever way you'd like, either here or just right click save image. Next, we're going to be looking at our 3D assets. So we're going to be using a lot of K's assets. K is a very good artist, and he has a lot of really cool assets. So this is one of the asset packs we'll be using for the adventure itself. As you can see here, we have a few free assets. So it tells you what is free and what is not. Of course, there are some extra things that are paid, but we're going to use the free for this entire course anyways, so don't worry too much about getting the pro version. Now, we'll also be using his Dungeon Remastered asset pack. This is going to be for our dungeon, and we're going to use this to design our level and have it actually use our game. Next, we're going to use the skeleton pack for our monsters. We're going to use specifically a ranged and melee one. So, we have a few options. We have a warrior, a mage, a ranger, I think, or one of those are a mage. And yeah, I think those are our options regardless, right? So we have a few options, and the pro version is pretty cool. There's a few extra pro versions, big golem guy, and some necromancers and stuff, which is pretty neat. So next, we're going to look at this RPG. It's a very simple RPG pack. It's an item pack that we're going to be using for our inventory system, right? Because we need the asset packs to represent our 3D items, of course. So this is what we're going to use for that. Very simple, nothing complicated. And lastly, our font. We're going to have customized font. Now, of course, you can download whatever font you like. I'm going to be using joystick monospace. This is free for commercial use. You can download whatever you'd like. Realistically, find a different font that you'd like, just download it and import it into the engine. So let's take a look at importing everything. So, okay, the first part is we should have this zip file for the engine. Now, this will allow us to open it, and if we open this up, we can find the stable version. We'll usually distinguish it by the size. The size is a little bigger. Now we can export it by dragging it out. Now you can see I already have it, so I'm just going to skip, and it'll tell me that I already have it. It's right there. So if we double click it, like so, we will now see the project manager that I had open a second ago. Now, what we'll do is we want to take a look at some of the asset packs. Okay, real quick, just remember we also have the UI big pieces to import. I forgot to do that, but that's my cut. So back to the video. Now, these are asset packs that I have, and these are what I'm going to import into Godot in just 1 second. All right, so now what I'm going to do is I'm going to hit the new button. We'll hit new on the top, and this will allow us to create a new project. Now I can browse where I want to put this. I will put this in my desktop, select current folder. Now I can rename this project to 3D, RPG, YouTube, tutorial, or whatever you'd like. Next, I'm going to take a look at the renders, because in this case, we're going to be doing a lot of 3D stuff and probably advanced 3D graphics. So we're going to select the Forward Plus. Now, mobile is kind of self-intuitive. It's for mobile. Compatibility is usually used for 2D. So Forward Plus is our best bet. Now what we can do is get rid of this error by creating a new folder. And now we can just hit create and edit. And now we have our project open with nothing in it yet. So what we'll do is we'll minimize the project just a tiny bit. And now what we can do is right click in our folder here, create new folder, and we'll create a new folder called assets. And we will drag all our assets into that. All we need to do is drag it in. And it might take a second, but that is all we need to import our projects or our files. Let's try one more time, maybe. Okay, there we go. Now we see the loading icon. All right, now it'll tell us blah, blah, blah. So we're going to disable FBX and restart. This is specifically for the KKits pack, because I believe there are some Blender thing files in there that we might not be able to use in Godot. So it's going to tell us that we can't use them, and we're just going to re-import everything. And we don't have to do anything. Have to wait for it to finish. All right, once everything has finished importing, we can open up our assets folder, and we can find all our new assets here. Now, you can see that we have our RPG packs, we have the KKit stuff, and we even have the SFX sound effects, right? All right, now, let's take a look before we go on to the next part. We can actually see some of these things. Now, feel free to delete the FBX folders. We won't use them. We will mostly be using the GLTF folders or things. And if we actually drag some of these in, maybe let's find one that is maybe a little cooler. Candlelit, I suppose. And you can drag it into the scene, drop it, and now see candle. It's quite cool. So we do have a candle, and we can kind of rotate around it by holding the middle button on your mouse. And that is it. So we have imported our assets successfully. Now, in the next part, we'll get started in actually, getting started with our scene, with our player. So we're just going to delete that for now, or if you didn't drag it in, that's okay. I'm just going to delete that, and so we don't have anything as a default scene. as we're going to do that in the next part. All right, so the next part that we're going to want to look at is actually setting up our scene. So the first thing we'll do is we'll create a scene as our base layer of everything. So we'll rename this to level 1, because we might actually end up creating several levels. So we'll create a new folder called scenes. We'll put everything in here for now. So if we save this, it should save into our scenes folder, but I'm going to create a new folder in here and call it levels. I want to make sure everything is still organized. So I'll move my level 1 scene into my levels scene, or my levels folder. Okay, now we're going to get started on our actual drawing of the map. So this is quite easy. What we can do is we want a grid map, and this will allow us to lay down the bricks of our world. Now there's a problem, which is that we don't have a mesh library to create one, but it's empty. So that's not exactly going to work. So what we can do is we can create a mesh library. Now the question is, how do we do that? Well, it's actually not too difficult, because Godot actually has a built-in system to do this. So what we can do is create a new scene, new 3D scene here. We'll save this as library reference, and we will save this in our level scene. And don't worry, if you don't understand what this means yet, you'll see in just a minute. So what we want to do is we want to go to the Dungeon Remastered, and we're going to find, actually find what it's called. There's a few things that we're going to use. The first one is going to be the floor. The first one is going to be a floor tile large. That's the one we're going to use. And we have 2, so we'll drag them out. It's quite big, so we'll zoom out a little bit. And we can drag both of these out. Now, for both of these, you can see that we have our scene here. Now, there's an issue, is that first, that the actual scene is a node 3D. Now, if I right-click both of these one at a time, I'm going to make them local, and we can now find the actual mesh. This is a mesh instance 3D. Now, I'm going to do this for both of them, and we're going to do this for everything that we import into here. And I'm going to drag them out. Now, I'm going to delete these other node 3Ds because we don't want those. And now what we'll do is we'll actually take the transform of all of these and reset it to 0. And what we're going to do to make this a little easier to actually work with is we're going to turn on grid snap, or snap. So use Y or this little button up here. And now if I take my large rocks and I just kind of drag it, you can see it snaps to each corner. And it's a little easier to work with. So we can just take these tiles and snap them to wherever we like. I'm going to snap it right here. Now, you don't have to space everything out the same way I am. Godot will actually automatically reference or take everything on its own. It's actually pretty smart. Now, for reference, whenever I move like this, all you need to do this on Godot, similar to Blender, just hold Shift and middle click. You'll be able to move around in your 3D scene a little nicer. All right, next up, we're going to have some walls. Now, these walls are going to be called wall arched. So this is the first one. This is our actual wall. And then we're going to have another one that is called our doorway. So it's going to be wall doorway. And we're going to take this guy. So this is going to be a doorway. And it will be open. It's kind of up to you if you would like to implement the doorway itself. I'm going to delete the door itself, and I'm going to take out the doorway. Now, I'm going to do the same thing for everything. I'm going to make everything local. Delete the node 3Ds. All right, there are 2 more things we're going to need. The first one is a stairway, which is called the stairs walled. Let me use this one. So this is just a regular stair walled, and it just has 2 sides, and it's just stairs. All right, next up, we're going to right click, make local, pop that in, delete that. And lastly, we're going to import our wall corner. Or not import, but just add our wall corner. It's just a corner for the walls. All right, make local. And here we go. All right, now what we can do is if we go to scene, we can export as mesh library, and we can create a library. So let's do that, create a library. And if we go to our level 1 and we search up in our search bar here, library, we can now find our new mesh library, and we can just drag it into this mesh library. And we can see that it's automatically given us these things. We can actually start drawing. Now, this works cool and stuff, but it doesn't actually work. The issue is that there's no collision in this. Now, we can add this, but there's no collision. So what we can actually do is we can add collision in the reference here. So in each of these, we're going to have to add a static body 3D and add a collision shape to each of these. So let's do that. We'll do one at a time, and we'll kind of do this together. The first one we'll do is we'll create a box thing here, and we'll just drag this out here, and I'll actually turn off the grid snap for this so I can make it accurate and just drag it out to be about the same size of the actual floor. And we'll just drag this down and drag these out to be the same size, like so. And I might want to just make the rocks invisible so I can actually see where the border is. There we go. And now we can see we have a floor. Now what I can do is I can just duplicate the static body, move this one into the large rocks, go into the static body here, and transform it to 0, and that will move the duplicated one on top of the rocks. All right, now let's make sure that we do this. I'm going to duplicate one more time for each of these. So I'm going to put them into each one. I'm going to put a new one into each mesh here. I'm going to make sure I duplicate one for each one. However, for each of these, I'm going to have to make them all unique for the collision shapes. Otherwise, when I edit one, it will actually edit the rest. So I need to make sure that I make them all unique. All right, next we're going to go to all the each one. So let's do the corner first. Now, if I reset the position, it'll go right there. Now, what I can do is I can take this guy and just adjust it to be the same size as the wall, like so. And I'll just make him a lot taller because it's a wall. And for this one, what I'll end up doing, I'm going to do this, and I'll duplicate the collision shape, and I'm just going to rotate it. I don't have to change the size of anything. Rotate it and move it to the other side of that wall there. Just duplicate it, or just rotate it slightly, and I think that's good. So now what we can do is do the same thing, and kind of go through one. And so this is for the stairs. So for the stairs, we're actually going to do something a little unique, where we're going to rotate the collision shape and just adjust it on top of the stairs. Right, so here, we're going to basically put that collision shape under the stairs as if I were to climb it, right? So that is going to be the collision for my stairs. Now for the top, I'm going to make it a little lower here. And there we go. Rotate it a little more and just adjust it like that. All right, now let's do the doorway here. We can reset the transform. And yeah, so we're just going to go through each one here. And for this one, we're going to take the collision shape, adjust it like so, get a wall, like that. And I'll duplicate this and just move this to the other side. And then lastly, the wall arched. We'll go to the static body, reset the transformation, take the collision shape, and this one is pretty easy. We just need a wall, a little shorter here, and make it a little taller. And there we go. We pretty much are done. That is it. We have finished our library. So now what we need to do is make sure that we export again. And what we're going to do is turn off the merge with existing, and we're going to overwrite it. Because sometimes it has an issue. Okay, so what we're going to do is we're going to delete the library that we currently have, because it does have problems sometimes merging with new collision shapes. So generally, it's a good idea to try and delete the old one before trying to export a new one with new collisions. So that's what I'm going to do. And now here, I'm going to reset the old mesh library and drag in our new one. And it looks the exact same, but trust me, it's not. It now has collision. Actually check this by going into the mesh library. And if you go into these, we should be able to find these shapes. And these are the collision shapes. You can see that it has a box shape as our collision. And you could adjust it in here. I'm not going to do that, so I'm going to control that because you can't see it, right? So that's generally not recommended to edit it through the numbers. It's kind of weird and hard to do that. All right, so at this point, we can now start drawing our level. What we'll do is first we'll just draw the floor of our level, and we'll kind of get into the player first, and then we'll go into level design in just a minute. But first, let's draw our floor. Now, to do this, what I just did, what you're going to do is hold Shift, left click, and just drag. Now, to fill this, we just say Control F, and this will fill everything for us. Now, if you're wondering where are all the things for this, well, if we actually go to the grid map on the top where it says right here, grid map, it will actually tell us a lot of the shortcuts for these sort of things. Now, I can't click it, but you can see it here. It says duplicate section, cut section, clear selection, fill selection. So that's the one that we just used, Control F, right? But if we wanted to clear something, I could select it and hit delete, and that deletes it for us, right? So we have a lot of these things that are pretty useful that you might want to use. The cursor rotate we'll end up using, specifically on the Y rotation. But yeah, so let's head into actually starting our player, because that is going to be a big part of our course, which is the player itself. A lot to it. So let's get right into it. All right, welcome back, everyone. We're going to continue our scene here. So we're going to jump right into the player. So what we're going to do is we can actually, instead of making a new scene, we'll kind of start it in here, and I'll show you a few tricks to kind of fix things along the way. So don't worry if you've seen things differently. We're going to get to things similar to what you might have seen eventually. So let's add a new scene, a character body 3D. Let's create this guy, and it will create it in the middle of our scene here. So we're going to drag him up just a little bit. Now, in that scene, we'll add a collision shape 3D. And in here, we can now pick our sprite or our image. Now, if we go to the Adventure tab, we can find our characters. We're going to go into the GLTF and delete the FBX. We're not going to use that. And of course, you may now make your pick. If you're going to use a mage, I would maybe suggest waiting. We will go over projectiles and stuff like that. But, you know, it's kind of up to you if you want to try it on your own right now, or if you want to try it later. So for now, I'm going to pick the knight. And what we'll do is we'll drag our knight into the character body 3D. Now, our knight is not centered at the actual character body. So we want to go to the transform of it and reset it. And now it is centered around the actual character body 3D. Now our collision shape is aired. So we're going to actually use a capsule for that. And you can see here that the capsule is not on the player. So we'll just move up just a tiny bit. The actual capsule, we'll just make him a little skinnier. The little knight here is a tiny bit skinny. He hasn't been eating properly. So we'll now right click the knight and make it local. And now we can see that we actually have our animation player, and it's already filled with a bunch of animations. You can play some of these by just hitting the play button. Now you might see it's not really a bug, but there's a lot of weird things going on, right? It doesn't look right. And that is because there's a lot of weapons and things that are here that we can just hide. So let's make sure we minimize all this. And what we'll do, we'll just hide everything except for the two-handed sword, or actually the one-handed sword. Let's do that. So let's hide everything above that. And we'll hide the two-handed sword. And now he's not holding anything in his left hand, and now he just has a one-handed sword. Or, of course, if you would like a two-handed sword, it's really up to you. But I will do a one-handed sword for now. And yeah, there we go. All right, so now what we can do is minimize this. We'll go to our actual character body 2D or 3D, rename him to player. We'll add a script, and we'll add this into our scripts folder we do not have. So we'll right click, create new folder, and create a scripts folder. And we'll right click one more time and make a player folder, because we're going to actually have quite a few scripts into our player. So we'll create it with the template. So we're going to use the basic movement as a template. All right, now we have a bunch of code. We'll go through what all this does, but it is actually very similar to 2D. It's kind of like a 2D platformer, but in 3D now. So at this point, though, if we were to hit play, we would actually see nothing. So let's select current, and we'll actually see nothing. Now the question is why? Well, the answer is actually quite simple. The answer is that we don't have a camera 3D. By default, most engines will, well, it depends on the engine, but by default, we won't be able to actually be in a 3D environment unless I add a 3D camera. So now I can add this camera and, well, I can move it around and maybe position it, rotate it to see our player. So let's move it back here like that. And now what we can do is hit play. But of course, our scene looks horrible, but there's our player, and we can even move around. And you can see that he does move. There's no animations and stuff. But if you hit the keyboard and stuff, it does move. All right, that is our player. That looks pretty neat. Now, it's not done, obviously, but we'll do a few things to add this. First, in our player, we're going to right-click our player, and we're going to save branch as scene. This will allow us to save the player as its own scene in a scenes folder. So we'll make a new player folder for that. We'll save it in here. And now you will see this little guy. This means that it's in its own scene. And here we can find the actual player. Now the problem is it's not centered at 0, 0. So we'll go to our player, the 3D character body 3D, go to transform and just reset it to 0, 0. But we should have everything right? So the collision shape should be relatively correct. If you want to change it up, it's up to you. And there we go. So that is our player. Now, before we head off into the next part, why don't we add a few nodes that we might need? So the first thing we're going to need to actually make sure everything works eventually is an animation tree. We're also going to add 3 nodes for a camera. We're going to add a node 3D. We're going to duplicate it, pop this in. And in here, we're going to add something called a spring arm 3D. This will allow us to essentially have an arm for our camera. Now, this is an automatic arm. We don't need to code anything for it. It's quite useful. Now, in that, we'll add a camera 3D. Okay, next, what we need to do is delete this camera 3D because we can only have one camera, whether it's 2D or 3D, current. Now, what does current mean? Well, if I look in my camera 3D here, see current is checked off. We want to check it on. Now, for the spring 3D, what we're going to do is we're going to actually set this to negative, let's say 9 for now, negative 10. We'll adjust this accordingly later, but for now, we'll leave it as negative 10. Now, let's rename this to V. We'll rename this to H. And one more thing I just remembered we're going to need to do is create another node, put this all in this. We should have 3 node 3Ds. The very base one will be called camRoot. This will allow us to essentially control the actual root of the camera. Now for the V, I just realized this will be called V, sorry. And this, here we go. Okay, so this should be our setup. camRoot as a node 3D, H as a node 3D, and then the V is the actual spring arm. And that will actually set up above the player, around the head. Okay, so you can of course make it higher or lower depending on what you'd like. We'll experiment with it a little later, but this is what we'll have for now. All right. First, for the animation player, to get rid of, or the animation tree, to get rid of the error, we're just going to assign the animation player. Double click that. And then for the tree root, we're going to use a state machine. We'll create that, but we're not going to do anything just yet. So in the next part, we'll take a look at the actual camera controls. So, we can actually start controlling our camera and looking around. And it might look a little nicer than what we currently have, right? Because if I were to play, I don't actually know if we'll even see anything properly. Okay, we might, but we don't even see the player. So this obviously is not what we want. Our mouse is still movable. We want to put it into the screen, just like we do in a regular game. All right, so we'll do all that in just a minute. All right, now for this part, we're going to be editing our camera itself to make it rotate around the player. So the first part we will look at is actually adding a script. Let's add a new script here and make sure that the built-in is off. And for the camera, for the script name, we can just call it camera roller under lowercase like so. And we will save this in our player script. Find our scripts player, save it in here, open and create. Now in here, we'll have a few things and we'll leave the ready functions. Now, just a little tip, by the way, if you're wondering why my functions might have this as the void and whatever, in your editor settings, you will find it somewhere in here. I don't actually remember exactly where. You might want to just look it up, but it is somewhere in your editor settings. I believe it just allows us to give these preferences. Okay, just in case you were wondering why yours might look a little different. So now in our ready function, what we'll say is input dot set mouse mode, for why it's not completing it for me, to input mouse mode captured. Now what will happen is it will capture our mouse. Now we're not just going to test this just yet because we're going to add a few more things here. All right, the first thing we will add a few variables. We're going to export two variables. The first one is a cam v max, and this is the max vertical that I want my camera to go. Now, I would recommend 75, and then we're going to copy paste this and basically do the same for the h. Now for this, we're going to do negative 55. Now we're going to create a few variables for sensitivity. So obviously these are just numbers, and at the end of the day, you don't even need this, but it kind of just helps us organize everything, see where things are. So we're going to say h sensitivity like that, and this will be equal. This is a float, and this will be equal to 0.01, and we'll do the same thing. We'll copy paste it a few times. This one will be v sensitivity, and we'll do the same thing for that. Now for this one, this will be acceleration, and this one will maybe just copy paste that there, and this would be the v. Now for the acceleration, I'm going to do 10, do 10.0, make sure it's a float, and then above, we're going to put cam root variable cam root h 0, and then variable cam root b equals 0. You'll see why we use this in just 1 second. All right, the next part is we're going to need a physics process. So we're going to change this to physics process. Delete all that. And now in the right above, we're going to use an input function. Now this is a function that will look for input. So it's different than physics process because this looks specifically for any sort of input. So now I can check to see if event is input event. You can even see up here, we can even check for joypad button and joypad motion. So of course, if you would want to use a joypad or implement a joypad into your game, this is something that you might use. Now we're going to use our mouse, so we're going to say input event motion. Because obviously when I move my mouse, I want my camera to move, right? Now when the input is motion, what do we want to do? What I want to do is I'm going to take the cam root h and the v in a second, but let's look at the h first. What we're going to do is we're going to add event dot relative dot x, and this is the equivalent of our horizontal. And we're going to just multiply this by the h sensitivity. So that way we have a little bit of control over what is happening over our sensitivity, and it's not just relying straight up on the event itself. And now we're just going to copy paste this and do the same thing for the vertical. Now, of course, if I run this, nothing will happen. So we're going to have to do something in the actual physics because I am changing these cam roots. And when I am moving my mouse, it is changing, right? It should, but nothing's happening because I'm not implementing anything in the camera, not implementing anything, the actual rotation of these, etc. Right? Now, one thing I will show in the scene, you don't actually have to rotate the camera here. Now, you would imagine what we're going to do is rotate this camera. That's not what we're going to do. What we're going to do is we're going to actually rotate the H and the V. Because when we rotate these, that is what happens, right? Above and down, right? So it actually is rotating the camera if these two rotate. Okay, in the physics process, what we're going to do is we're going to say cam root v, cam root v, like so, and we're going to clamp it to its current cam root, and then we're going to say degree to rad, and then whoops, cam e min. This one should actually be min. Just realized, and these should both be v. Sorry about that. So v min here. We're going to put the v min here to degree. Then we're going to copy paste this, and just whoops, we're going to go from the min to the max. Essentially, we're going to clamp the v of our camera between these two numbers, right? Now, if you're wondering what clamp does, it essentially stops whatever number this becomes into anything in between these, right? So that's what clamp kind of does. Now, I'm not going to explain too much of the math. That is the basic idea of what this will do, okay? So next, what we're going to do is we want to actually make things move. So now that we've clamped the actual v root, we're going to make things move. So what we want to do is get node and get access the h root. And we'll do that similarly, but for the v root right below. So here we're going to say at v. Now for the h, what we'll do is we're going to rotate it. So we're going to say rotation, rotation like that. No, that doesn't look right. Like this, rotation dot y is equal to lerp f of the current rotation. So we actually want to get it again. So we'll just copy paste this in here. We want to lerp its current rotation to the new rotation of the cam root, right? So the cam root h, and then we're going to pass through delta times the h acceleration. All right. Now we're going to do the same thing for the v. Let's just copy paste over here from the rotation. Let me just zoom in a little bit. And in fact, I'll actually hit this little guy over here, make the script editor floating. So it might make it a little easier for you guys to see the code. All right. So here we go. Here, we're going to rotate the x in this case. And then we're going to also rotate the x here. And here, we're going to get the node v. And then obviously here, we want to adjust this to v and this to v as well. All right, that is actually it. Okay, we have a problem here. I think cam root x does not exist. Might have spelt it wrong. Of course, cam root x doesn't exist. It's actually cam root v, and this is also v. That would make more sense, right? All right, that is our camera movement script. But if you test it, you'll notice that it doesn't actually work. So I would actually recommend you try testing it right now. Pause the video and try testing it. It won't actually work. The question is why? Well, what we need to do is that the camera, we want to rotate it backwards. Now, it does work. The problem is it's looking the opposite direction. So we're going to take our camera rotation and set it to -180. Now, the rotation of the x, I'm going to make it point down slightly towards the player. So I'm going to put -10. So that way it kind of glances at the player a little more. And now when I run the game, we will now see our player rotation here. And it's not perfect, but here we go. Have our rotation. And I believe we actually messed up one of the things. That is why it's a little weird. Here on the H rotation, we want to make this negative. That makes a little more sense to why it wasn't working. Let's replay that one more time. And now we have a little bit more smooth movement. All right, there we go. So that is our code. Now let me just double check everything is right, so that way we don't mess anything up. Okay, I realized right here for the vertical, we actually want to take the Y relative. That was why it felt a little weird. Now, should have a little smoother movement where I can go up and down properly. I can go left and right. And yeah, so it looks pretty neat. And if I go closer, it does go into the head. If you're wondering why that is, it's just going straight into the head. Now to fix that, realistically, all you would need to do is take the B here and just move it like above head. So this is where I would suggest you test things around and, try to see if you can find whatever you like. Realistically, though, it's again, like I said, it's up to you. It's your game. You want to kind of test things around and see what is good for you, whether this is too high or too low. Alternatively, you can put it behind the head. But again, that might actually depend on how you want to do rotation. Because now we'll go into the next part, the actual movement. Because now you can see here when I move around, it doesn't matter where my camera is rotated, it moves the same way. So if I'm pressing right, it will always go that way. Okay? And that's not where we want it to go. I want it to face the camera. And if I press forward, I want it to go forward. Right? So that's something we're going to look at in the next part. All right, let's get started in our player. Now, I'm going to take out the script so everything's a little bigger and a little easier to see. Okay, let's first read the code and try to understand what things are doing. Because we're going to change a lot and we're going to get rid of a lot of this stuff, but we're going to try to make it relatively similar and use these things. So, okay, first we have a few variables here that are just being set. Speed, jump velocity, and gravity. This is getting kind of pulled from the engine, which I believe the actual value of this is negative 980. You can check it for yourself, though. It might be positive, actually. Remember. And then, okay, we have a physics process, no ready function. In here, the first part is pretty easy. It's just checking if we're on the floor or not. If we're not, we're going to add gravity times delta. This will just take our velocity y and subtract to it, right? Now, whenever we subtract like minus equal, this is kind of like adding acceleration. Because when I set something equal to a velocity, this kind of puts us up and then keeps the velocity constant. Now, the reason why we can jump, of course, is because we jump by setting the velocity to a certain number, and then we're going to be subtracting to it over time. So, okay, so in this case, we're jumping, and we do that by checking to see if I press UI accept, which by default is our spacebar or enter, right? And I can only jump if I'm on the floor. Okay, now the rest of this. This is not too difficult because what's happening here is we're getting an input direction based on 4 different inputs, right? So A, S, W basically, and W or arrow key, left, right, and up and down. And then we're going to take the direction, multiply it by the transform, or make it equal to transform.basis times the vector of the input direction dot x, and then 0 for the z because it's always just going to be 0. And then the y input dot time dot y, sorry. And then we're going to normalize it, which will just make it like rounded basically. Okay, now if direction is valid, meaning something is happening, right? It's not 0, then we're going to actually add the velocity. And we do that by just, saying velocity.x is equal to direction.x times speed, right? And this will just allow us to move. Now, otherwise, this means I'm not moving. All this does is, well, it kind of moves towards 0. So it takes the current velocity, whatever it may be, and then moves it towards 0 at a rate of speed. Right? So here you could put 1 or whatever. It doesn't really matter. It's just more of how fast it's going to do that, right? In this case, it could honestly just do 0, and it might look the exact same, right? Okay. And then lastly, we have move and slide. This actually allows us to use velocity and, well, move and slide. Okay. Now, what we're going to do is we're going to remove everything, and we're going to make everything from scratch. Okay. The first thing we want to do is we want to create an onReady variable for our animation tree using eventually, right? So we'll say get node animation tree. Now, it does have to be onReady. OnReady essentially loads these scenes or these paths and stuff before the scene is ready. So that way I can use them at any point. Next, what we're going to do is we're going to actually also get the playback of the animation tree. And what that might look like is animation tree dot get get parameters slash playback. Now, don't worry about what this might be yet. We're going to look into and understand what these may be. Okay, animation tree is not valid. We have to make sure it's typed correctly. That should work. All right, that gets rid of our error. Next, we want to export. Or no, we don't want to export. We just want to say onReady variable player mesh. And we're going to load the player mesh. Now, okay, let's minimize this a little bit. We can go to our mesh here and see that this is our mesh. So what we want to do is load the knight. And that's it. That is our mesh. Now, it's not the actual mesh because as you can see, this is a node 3D, but it's essentially what we're going to use to rotate the actual player. Because what the problem is, I can't just rotate the actual character body 3D, right? Because if I do that, what happens is my camera also rotates. And so what'll happen is I'll have some really weird behavior happening if I try to do that. So what we're going to do is end up rotating actual mesh instead of just the camera or the entire player, right? Because that makes more sense to rotate just the mesh instead of the entire player. Right, next, we can export some variables. And of course, you don't have to export them. You can just create them as a variable. But these ones will create gravity, 9.8. We'll export jump force. This will be our actual jump. This will be 9. We'll export walk speed. We want to say variable walk speed. And this is 3. We'll also set it to 3. And then we'll create a run speed. And this should be greater than the walk speed. I'm going to do, let's say 10. And yeah, so all of these are integers, except for the gravity. That one's a float. So let's make sure we define all these. And lastly, the run speed. Okay, so these are all integers and gravity is a float. Okay, next, what we'll do is we'll kind of store all the animation nodes. So what we'll do is I'm going to create a comment here. Animation node names. So we're not going to actually store anything, but we're going to essentially put the names of our animations. So what we'll do, for example, is we can say idle node name is equal to idle, right? And here, this will be a string. And now what we can do is copy paste this a few times. And this one will be for walk. This one will be run. This one will be jump. This one will be attack 1, or just attack. And the last one will be death. Now, the name of these kind of depends on the actual name that we put. I'll name it what I kind of assume we'll get. But for example, this will be walk. This will be run. This will be jump. Capitalize it. This one will be attack 1. And then lastly, we'll have death A. Because there are several death animations in this guy. Okay, next we're going to have a lot of physics values. So physics values. We're going to create a direction, and this is a vector, vector 3 by default. Next, we're going to have a horizontal velocity, and this is also a vector 3. Next, we're going to have an aim turn, and this will essentially allow us to aim towards a certain direction. Now, this will be a float. Next, we're going to have a movement variable. This will be a vector 3. Next, we're going to have a vertical velocity, and again, this will be a vector 3. Next, we're going to have a movement speed, and again, this will be an integer. All right, next, we're going to have an angular acceleration, like so. and this will be an int. We're almost done. We just have 2 more, so acceleration, and this will be an int. And lastly, we'll have a variable called justHit, and this will be for much, much later, but this will be a Boolean, and I'm actually going to set this to false by default. Now, the rest of them, we don't need to set them because we'll kind of set them throughout the game as well. All right, now we can actually get started with some real stuff. Okay, so the first thing we'll do is we'll create a ready function. And then for now, we'll pass. And then we're going to create a physics process function. And for now, we'll pass. And then in here, right above the physics process, we're going to create the input variable or an input function. So we're going to say input event, and then we'll pass for now, as we'll get started on all these functions and implementing everything in the next part. All right, I'll see you all in the next part. All right, so before we move on and basically start adding a bunch of things, what we want to do first is actually add a lot of input mapping. Now what this means is, for example, ASW, right? At the moment, we can't move using ASW. So if we go to the project settings and find the input map, this is where we will find and add everything, right? So what we can do here is I'm going to add all the actions that we're going to need first, and we will actually make them work. So right, left, backwards, forward. This is just to move backwards and forwards. Of course, you can name it up and down. I find it weird to name it up and down because in this case, it's not 2D, right? It's forward and backwards. And then we're going to add attack, sprint, aim, and lastly, pause. All right. So for pause, I'm going to do escape because this is kind of common. Now for aim, I'm going to do control. For sprint, I'm also going to do shift. Now, if you're wondering, by the way, all you need to do when you click the plus button, all you need to do is click whatever key you need. However, not this one, because attack, what we're going to do is we're going to use the mouse button. But we can't just click. We need to actually find it in the mouse button and left mouse click for button. All right, now for the rest of these, we can do whatever. So jump, I'm going to do spacebar. Forward, I'm going to press W. Backwards, I'm going to press S. Left, A, and finally right, D. All right, there we go. We've added everything we need for the input mapping. Now just do keep in mind, you can actually add more than one. So for the right, you can add a right key. This is the physical arrow key, right? So of course you can add more than one. I'm just going to add ASW as I'm going to basically make this game kind of left-handed control on the left-hand side, right? So ASW, and then you holding your mouse to attack and maybe have special attacks, right? That's how I would make this game, similar to Elden Ring, for example, right? Or maybe those Soul games that if you any of those. All right, so that is it for the input mapping. All right, in the next part, we'll take a look at how to actually implement some more stuff, so movement and actually aiming and stuff like that. All right, I will see you all next part. All right, welcome back, everyone. Before we get started, I want to go over the idea of state machine. So we're going to kind of go over the concept of a state machine first, and then we're going to actually try to implement it inside of Godot. We're actually going to be implementing it 2 times and 2 different ways, because there are many different ways, of course, but I'm going to show you 2 different ways that I like to practice and do this myself. So the first thing we need to understand or grasp is this idea of state machines. So generally, it's diagrammed like so. So we'll have different circles, and in each of these, we'll have, say, idle, run, and attack. Those are pretty common states. And the general idea, of course, is we want to be able to go from one state to another. And we also want to go from that state back to the original state. So we can go from idle to run. We can also, or should be able to go from idle to attack, or we'll see how we actually do this, but we should also be able to go from run to attack. Also, we should be able to go from attack back to idle, or from attack back to running, let's say, right? Now, one thing that we can actually look at here, though, is there is a way to go from, if I don't have that arrow here, there is a way to go from attack to run. I'll give you a second to see it, but here it is. We go from attack to idle, and then from idle to run. It's a little longer, but it does work, and it does take us like a moment, and it doesn't even like show on the computer, right? Because it's so fast that we can't process it as humans, right? The computer processes it, and it's really quick. So there is always still a way to go from one state to another. So generally speaking, we do want at least one path. Of course, if there is one way to go from attack to run, that's also fine. But in our case, we're probably not actually going to have this. But now, okay, now the question is, what are these lines? How do I create these arrow keys here? Well, we can make these with conditions, usually an if condition, right? And usually we can create these paths, these kind of virtual paths, with an if condition. So for example, and we'll do this in just a moment inside of Godot, to go from idle to run, we can create this if statement that checks for input for a specific type, right? So we can say if press A, right, or left, because that is something that we just mapped into our keyboards, right? So that is something that we can do, all right? Now, each of these are conditions generally, right? There are sometimes things that can be automatic. So sometimes, for example, in fact, we might actually do something like this in the AI specifically, where when the attack is finished, we'll automatically just go back to idle, because I want to be able to go from attack to idle, and then maybe in the idle state, we can check to see if the monster or if the player is still in range. And if he is, then we'll go back to attack. And if he's not, then, well, we'll probably want to run towards the player, right? So these are different conditions that we'll kind of have to think about as we code our player and monster. So we'll kind of get into this in Godot. So I'll see you all in the next part. All right. So in this part, we're going to begin our state machines. Now, in order to do this, we're going to essentially use Booleans for this. Now, if you're wondering what Booleans are, they're essentially true or false statements or variables. And they just hold the information of whether or not something is true or false. So we can create state machine conditions. And essentially what we'll create is, for example, one can be is attacking. And this will indicate if we're attacking or not, right? Next, we can create an is walking. This is a Boolean. And next, we can create an is running. And lastly, we will create a is dying Boolean. And these are all the states that we'll have. Of course, there is an idle, but the idle is more so just if none of these are happening, right? We don't need a is idle state or is idle Boolean. So you'll kind of see how that works in just a minute. All right, so next up, what we want to take a look at is, let's actually do the input. So we'll take a look at the actual input. Now, in order to create or actually have our player move with the input that we give it based on the camera, we need to essentially say if event is input event mouse motion. Then what we'll do is we're going to take the aim turn, and we're actually going to do something similar to what we did in the camera controller, where we just say is equal to negative event this time. Let's make sure we do that right. Dot relative dot x, and then times 0.015. And now this will allow us to kind of animate the player with the mouse movement while aiming. Now, of course, aiming is going to be something we also check for. So we can say if event is action rest aim, then we'll actually aim and say direction is equal to get node cam root h dot global transform dot basis dot set. All right, and now what we also want to do though is in the ready function, before I forget, we want to tell the direction equal to vector 3 dot back dot rotated, and we're going to use the vector up. So just up right there. Then in here, we're going to say get node, camRoot. We're going to get the H. We're going to get the same thing, the global transformation. In fact, I can copy this right here. And now, instead of the Z, though, we're going to say get Euler.y. All right, hopefully this unerrors. Okay, cool. All right, next, what we want to do is actually rotate the player. Now, how do we do that? Well, the first thing we can do, or want to do, is we'll create an if condition and say if is not dying. So if we're not dying, then we'll do all this stuff. And everything that's going to go into here is going to be stuff that we do if we're not dying. Right? So the first thing we'll do is we'll get the H rotation of the current camera root. So here, honestly, at this point, since we're actually reusing this node quite a bit, quite a few times, what we can do is create an onReady variable, say H rote is equal to get node, whatever, right? And now what we can say is, probably want to name this actually something else. We'll say cam rotation H, like that. And then we can just replace all these with that. And then over here, we can say the H root dot global transform. I should just copy this one more time up here. Copy that right there. We want to get the global transform, the basis, the Euler, the Y of that, right? Next, what we'll do is we're going to check for input. Now, we only want to move or do something if input is given. So we can do that by saying if vector, if input dot is action pressed, and then we can get the forward first. Or, now this is just or, and we'll do the same thing. We'll copy paste this. Instead of forward, we'll say backward. And then we can also check for the left, so we'll just copy paste the or as well. And then over here, we will say left. And then one more time, or right. Right, so now we're checking for essentially every sort of input that we can give in terms of a movement, right? Now we should be able to go to the next line. Here we go. Do make sure that we have everything in the bracket, right? So or. Now we're checking for all four. Now, if we do that, what we want to do is get the direction and change it to be the direction we're going. Now, what direction are we going and how do we get that? Well, it's actually not that hard. What we can do is we can get the input, say get action strength. And this is a very useful function inside of Godot that you can actually use inside of the 2D environment as well. And this will allow us to get the strength between two things. Now, we're going to compare the strength of the left minus the input. I will just copy this. Oops. Minus the right. All right. And this essentially will take the left and subtract the right. Now, why do we do this? Because what happens is if I'm pressing A, for example, that means I'm going negative for 1, right? Now, if I'm going to the right and I'm pressing D, then I have 0 minus 1, meaning I have negative 1 on my x-axis, right? And now I can do this similarly, where I go over here, I'll put 0 for the y, and then for the z, we'll do something very similar. So we can copy paste this. I'll even tab these over so it's right next to each other. But this one will be forward, and the other one will be backwards. Because the same logic applies. If we are going backwards, we want negative 1. And if we want to go forward, we want positive 1, right? So 1 minus 0 gives us positive 1. Okay? So just keep in mind, maybe one more little explanation. If I'm not clicking anything, then the action strength will return 0. Okay? So that is why, in the end, when I click left and I don't click right, I will get 1. If I'm not clicking left and I am clicking right, I get negative 1. Hopefully that makes sense. And this will give us, of course, a 3D vector with a direction, right? So we are finding out which direction we're going. All right, now we want to adjust the direction based on the rotation. So we can say direction is equal to direction dot rotated, and we'll rotate it around the vector up, vector 3 dot up. We'll rotate it around the H rotation, which we previously got right here. We just need to pass that through. And then we'll normalize this. So we'll say dot normalized, and that's why we didn't do it over here, because we're going to normalize it on the next line. All right, now we need to actually use this. We need to actually use the direction because we have it, but it doesn't do anything. So we need to actually make it work. Okay, how do we make it work? Well, what we can do now is check for the aim as well. So if input is action pressed aim, then I will lerp my mesh to the direction, or not to the direction, sorry, to the current H rotation. Otherwise, then I will take it to the current direction. Okay, so we'll have an else statement as well. But in here, what we'll do is we're going to take our player mesh, say dot rotation dot y, and we will lerp the angle from, let me just double check that this is from, yeah, so from, we need to get its current rotation. So we just say player mesh dot rotation dot y, and then we're going to get the current root, which we got over here, cam h, or cam root h dot rotation dot y. Okay, and then we'll just do it at a rate of delta times acceleration. That way we have a smooth looking lerp, right? So it's not just really quick. All right, now in the else, this is where we'll actually use the direction. So we'll actually just copy paste this and adjust it. Might be a little quicker that way. So here, instead of rotating to the cam root, we're going to rotate it to the atan of the direction dot x and the direction dot z. Now we're going to subtract the current rotation of the y. All right? All right. Now, actually, let me just check. Did I create this? Yes, I did. We're going to use the angular acceleration. That number is a little different, which is something I didn't actually set yet, so we'll have to do that as well in a bit. All right. So let's set that right here in the process. We can set it, yeah, right here in the isDie. We'll say angular acceleration is equal to 10. We can say movement speed is equal to 0. And then we can say acceleration is equal to 15. Those are the numbers that I'm going to use. Of course, feel free to use whatever numbers that you would like as well, though. All right. Now, let's give it a test run. Let's see what happens if I play the game. See if it crashes or what happens, So, all right, let's minimize this. See if I can run. Now, it won't work because we haven't completed it, but we do see that the player does rotate, and I can now aim my player, which is very cool. I just don't move. I can't move, right? And that is the velocity. That is something that we need to do. My script here. All right, so now what we can do is do the velocity. Now at this point, I would encourage you to pause the video and try to do the velocity on your own. As we did see how to apply velocity before, I want you to try it yourself. All right, so hopefully you've paused and paused. But all we're going to do is say velocity.z is equal to horizontal velocity.z plus the vertical velocity.z. Now, we'll also move and slide on the bottom. And we're just going to copy paste this and do this for everything. So the x over here, the x, except for this one, we're going to just remove the horizontal. And for this, we're going to do the y. All right? Okay. Now, at this point, of course, we haven't done a lot of the other stuff, though, like the horizontal and the vertical. So for the vertical, we can do that maybe over here. For the vertical, first, what we'll say, if not is on floor, then what we want to do is add the gravity, if you remember. So what we can say is vertical velocity plus equals vector 3 dot down, and this just indicates that we're going down. And then we're going to multiply our own gravity times 2 times delta. That's the value that I decided to use. Right? Now, we'll say else vertical velocity is equal to vector 3 dot up, down again, times gravity times, divided by 10. All right, next we want to actually check for jumping, right? And this is also easy. If you recall, all we need to do is check for input. So we can say if input is action just pressed. We'll check for just press because I only want to jump once. I don't want to jump, several times at the same time, right? Now, in this case, I can, of course, just do this. We'll do that right now. So we can say vertical velocity right here. We'll copy this. But in this case, this will be up, and then this one will just be multiplied by the jump force that we created above. All right? Now, the problem is, what if I'm doing other things that I, don't want to be doing, right? One of those states, I'll say, that I don't want to be able to jump, is attacking. So I can say and not, these both in brackets, is attacking. Another thing we want is to make sure that we're is on floor, right? Because I shouldn't be able to jump if I'm already in the air or something. That doesn't make sense. Unless, of course, you implement a double jump. But in my case, I'm not going to have a double jump, so I'm not. Next up, what we can do is actually do the horizontal velocity. So to do that, what we can do is not too difficult. We'll just say horizontal velocity is equal to horizontal velocity dot lerp. We'll lerp the direction, direction dot normalized. Make sure that that number is normalized first, and then we'll multiply it by speed or movement speed. Movement speed. There we go. And then the acceleration times delta. All right. Now, in the case of if we're attacking, though, I actually want to change this. So what we can do is create an if condition on the attacking. So we can say if is attacking. I actually don't need these brackets. I'll just say if is attacking. Then we will do this, but slower. So we'll actually create an else statement for this one. But up here, I'm just going to copy paste these. But here in this one, all I'm going to do is instead of the movement speed, I'm going to multiply it by 0.1. All right. And now let's see if that is things. I believe that should be most of it. So now what we can do is try playing and see what we get. All right, so it doesn't seem to work. So let me debug this and I'll figure it out real quick. Okay, so what we were missing is actually the movement speed. And we have a few things missing, so you might as well just finish it as, we're almost done with this. So one thing that we need to kind of look for, wanted to implement, was the, not dashing, but kind of sprinting, right? And we do that usually when we sprint, we usually hold some sort of arrow key, and then we hold another button, usually shift. In my case, I did set it to shift. So in my case, I'm going to be pressing, right, which I'm already checking for. And then in that condition, I'm going to create another if condition. It says if input dot is action just pressed. Just pressed, because I can hold this shift. Right? I'm going to select sprint, and I'm going to check for is walking. Okay. Now, if I am just walking and I'm trying to sprint, what I'll do is I'll say movement speed is equal to run speed. Otherwise, I want to set the movement speed to walk speed, right? And that's why we created those two speeds. because now we can set it according to, well, different numbers based on if I'm sprinting or not. Now, another thing we'll do, though, of course, is say is running is true here. And then in here, I'll say, you probably guessed it, is walking is true. Right? Now, if you would like a bit more indication in some of these, sometimes I like to just say is equal to true, just because it might not seem obvious that that's what I mean. Now, in here, in this condition, now if I'm not clicking anything, I want to create another else condition. Say is walking is false, and is running is false. Right? Because if I'm not clicking anything, I'm probably not walking or running. Okay? So in this case, now we should be able to try this and see we do move around. But there is, of course, the issue of, well, we still have the animation, and then we also have the gravity. Gravity doesn't seem to be working just yet. So let me take a look at what's going on, and I'll be right back. All right, so the problem, maybe you even noticed this, was right here, the vertical velocity. I'm setting it Z, which is wrong. I need to set it to the Y. Now, hopefully, I play, I now fall, and I can even jump. And now we have nice movement. We go, we did it. We have achieved nice movement and decent camera control. We now have a decent looking RPG, and it's pretty cool. So at this point, most of what's left, right, is the animation. Now, yeah, so pretty much we'll now go into the animation of our actual player. It's not too difficult, but there is a bit of setup. And then we'll also actually add the code for it. The code for it isn't too much, as the way we'll set it up in the animation tree will allow us to do that. And the way we set up a lot of these state machines will really help us with that as well. So I will see you all in the next part for the animations. All right, so in this part, we're going to be setting up the animation tree. All right, so what we're going to do first is actually take a look at some of the animations that we have, because this does kind of matter in terms of actually putting them into the animation tree. So I do suggest, there's a lot, we're not going to go through all of them, but I do suggest you go through a few of them and maybe look at them, especially the attacks, well, specifically the melee attacks. I'm going to be using the two-handed melee attack, so he will. Okay, so let's turn off the animation tree. So, okay, let me say this for reference. When the animation tree is active, the animation player, I will not be able to play anything in the animation player. But now that it's inactive, I can play something. Another thing I want to look at is the idle animation. Now in here, I actually want to loop this animation. I also want to loop the whichever running animation you use. I'm going to use running A. So I'll loop that. I also want to loop the walking. Again, whichever walking you're going to use, I will loop walking A. All right, now let's add everything. So let's make sure that the animation tree is active. Now I can right click and add things. Now I'm going to show you something you can do and something that we will do. And so what we will do is simply add an animation. Now let's add the idle animation by default. We will take the connect nodes and connect the start to idle. Now we'll leave this the first connected, and we'll kind of move this to be aligned with things. And I'll try to align things, organize things together. And now let's take a look at blend space and take a look at what's in here. Oh, sorry, not blend space. Delete that. I believe it is blend tree. Yep, blend tree, here we go. So we have this weird little grid thing. Now this place is actually quite cool because here we can do a very similar thing where we can simply add the animation, select whatever we want, let's say walking. Now the cool thing about this is that I can just output it right away, and this would do the exact same thing. And so you might wonder, well, what's the point of a blend tree? Well, the point is that now we can add a lot of other cool things. For example, one that I use a lot is the time scale. This allows us to speed up or slow down the animation. Now, of course, if I do it as 2, this will speed up the animation. So let's do this. And you can see that it's pretty quick. But if I go back in here and I set it to 0.5, you'll see it's much slower now. Now, I'm not going to use a blend tree, but do feel free to use the blend trees if you'd like. Now let me just delete this. I'm simply just going to add the animations, but it should work relatively the same. All right, so don't worry too much about the code. It's literally just the actual animations. And you will see why the code itself won't actually matter that much. So let's add the walking right here. I will add the running right here. I will add the jump. Where's that jump? Whoops. Jump. We will do the full long, I believe. Let me just double check. Yeah, full long. All right, next we are going to put the death ant A over here. And realistically, you can put it anywhere you would like. I'm just gonna kind of organize it the way I like it, right? So now we will find the two-handed spin attack right here. And I'm actually gonna rename this to attack 1. And I'm gonna rename some of these. So the attack, the walk, I'm just gonna say walk. The running, I'm just gonna say run. And the jump full long, I'm gonna say jump. Now, what these names are, if you remember in the script at the top, here we have the names. Now, of course, the death, you can actually just say death here, and then again, change this to death. And these correlate to the exact same thing. But think of these as the nodes of the name. Okay? Now what we can do is actually start connecting these. Now, what do we connect these with? Well, we connect them with the nodes. Now, these might start to look somewhat similar or familiar in the sense of the state machine. Now, these are kind of similar and they do behave in a similar manner. And that is actually what we're gonna kind of use. Now, you'll see when we connect, for example, the walk and the idle. Now, what we can do is if we actually go into, let's say from the idle to the walk, we can actually click one of these. So I have to make sure I have the select thing open. Select this guy, and you can now see that I can go to the switch and the advance and see some things. Now, the switch mode is immediate, meaning it will immediately switch and automatically sync or automatically switch. And that is because here it's on auto. Now, of course, you can disable it, but I'm going to leave it on auto. Okay. Now, the cool part about this is that I can give it a condition. Now, this is kind of what I was talking about, a condition to move to the next animation. And our condition here will be is walking. So I'm going to say is walking like this. It's is walking. I'll just type it out. There we go. Is walking. All right, now for this one, we'll say is not walking. Now you can see that if I'm not walking, that's the condition to go back to idle. And that is the idea. So now what we can do is we can essentially do this for everything and set conditions. So let's do that. So this might take a while, but bear with me, we'll work with this together. For idle to jump, the condition for this is in air. Now for the condition from jump to walk or jump, we'll just actually leave from jump to walk, that condition is on floor. Is on floor. All right. Next, we'll want to go from walk to jump. And this is the same as the idle, which is in the air. So we can just actually copy this over here. And there we go. Now we also want to go from run to jump. So we'll also set a condition is in air. Next, we're going to also have from run to walk and walk to run. Now from walk to run, it's easy. It's just is running. Is running like so. Now here, I just say is not running. I have to make sure I select it. Is not running. All right, we're almost done. Now all we have is from attack to idle, what we can do, and idle to attack. We also want to go from, no, that's it. So now what we can do is select this guy. And what we'll do is we're going to have a condition, but we're also going to have the switch mode at end. Now the condition is going to be is on floor. Now the thing is, the is at end, that means it's going to animate, and then once this animation is finished, it will just go automatically to the idle. Now from idle to attack, the condition here is actually a little different, and I wouldn't say unique, but kind of easy in the way, in the sense that all I need to do is click something. So I don't actually need a condition, nor do I need it automatically to go, because we're going to set the condition to code. Now, from idle to death, this is easy. We'll say is dying, and that's quite easy as well. All right. And we also want to go from walking to death and from running to death. Now the same thing will apply. We'll just say is dying and copy paste this. There we go. Oh, not is in error. Looks like I had to mess that up. Let's copy that again. Sometimes it doesn't copy paste row. Oh, there we go. Is dying, and this one is dying. There we go. All right, we have now completed our animation tree. We have all the conditions to move around our animations. Now, do make sure that you have everything similarly set up. And I did try to go slow so that I don't mess anything up. And hopefully you can follow along and get all these things together. But now let's head into our script and actually code this, because obviously nothing will actually work unless I code this out. Let's go into our next part for that. All right, let's get into the coding and complete our animation. So the first thing we'll want to do is right before we check for input. I mean, technically we can do it anywhere, but what we'll do right here is we're going to write if attack 1 node name is in our playback dot get current node like so, then what we'll say is attacking is true. Otherwise, that probably means that is attacking is false. So this will help us actually find out when we're attacking or not. Okay, now there might be an issue though. Here, right here, we want to delete that. That's why. Okay, so now we have our code working. Okay, but again, the issue is right in the jump. Where's the jump? There it is. So now in the jump, we can actually use this, right? So now we can know if we're attacking or not. Okay. All right. So now what we can do is on the bottom of our move and slide, we'll do this outside of this function right here. And right before this function, we're going to create a new variable. And we probably should have done this before, but we'll just put it right here anyways. We'll say variable on floor is equal to is on floor. And now we have this variable that tells us if we're on the floor or not. And now what we can do is we can get the animation tree and the parameter conditions, and then we can edit each condition. So we can say, for example, is on floor is equal to, whoops, the outside of the thing, is equal to on floor. And now what we can do is say, we'll just copy paste this. I'll just copy paste it like this, and we'll copy it a few times. And the next one we'll do is in air, and this will be not on floor. The next one will be is walking, and this one will be, well, is walking. We have that one, right? And we'll continue this, and I'm gonna encourage you to kind of guess and fill this out yourself. This one will be is not walking. Next one will be is running. This one, well, you guessed it, is running. This one we'll say is not running. So the condition is the is not running that we wrote. Now things might start to be making sense now. Now the last one is the is dying. This one, of course, you got it, is dying, right? Which we have all of these right here. And that is kind of why we didn't need the idle, because we don't need an idle condition, because if all of these aren't happening or whatever, we automatically have the idle animation happening, right? And the actual idleness of the player is happening in here, right? It's saying that it's going to be equal to 0, specifically right here, when I'm not clicking anything. So when I'm not clicking anything, this will just end up being 0 anyways. So that is why we don't need a condition to go back to the idle state, because the default is the idle state. That might make a bit more sense. Okay, shall we test it? All right, so let's close the script, press play, and see what bugs we can find. All right, so far no bugs. All right, very cool. We can now do all that stuff, and we can run around and blah, blah, blah. Okay, that looks pretty neat. Now, the only thing we have left, of course, is the attack, right? Now, the attacking, this we'll do in the next part. So the actual attack we'll do in the next part. But for now, I'll see you guys in the next part. So, all right, welcome back. We're going to continue our attacking. Now, what we'll do for the attack is we're going to create a function. And realistically, I would actually encourage you to create functions for a lot of these. Now, we'll do the attack together, but I would encourage you to do the rest on your own. So the first thing what we can do here is call the attack1 function. Now, it's going to error because this function does not exist. So outside of the process function, let's create it. Let's create it by saying func attack with parameters and just colon. All right, now in here, it's actually not too hard, because in here, what we can do, we can get started with our input. Now for the input, we can just say, I'll kind of let you guess, to actually get input, we can just say it is action just pressed. Now, the reason, again, we're using just pressed is because I only want this to go off one time, not, continuously. So in here, we can say if I attacked, then what I'll do is I'm first going to check to see is attacking is false. Whoops. There we go. Is not attacking, basically. Then what I can do is I can say playback dot travel to attack node 1 name. And this is a little different than this because it's not exactly a condition, but more so just manually traveling to that next animation. Next, what we'll do, before we want to check for the attack, what we can do is to have another condition and say if idle is in the current playback dot, let's actually just copy this because I don't know why I'm always messing this up. In the physics process right here, we'll just say the get current callback, and we'll paste that right here. So if the idle is in there, then we can attack. Now, this is a cool condition, but the issue is not exactly an issue, but we also would want to attack, or it depends on how you might want it, but I might want to attack if I'm walking. So I'm going to copy paste it and change this to walking. Of course, remove that. Now, of course, so let's actually test this and see if it works first. All right, there we go. There's our attack. Now, of course, like I'm going to say, if I'm walking, I should be able to attack. Now, the issue is if I'm sprinting, I can't attack. If I'm running, I can't attack. Now, that's up to you if you would like to add that or not. I'm going to leave it out, but of course, you can kind of figure out how to add it, and that's not that hard. Add another or condition and say or running, right? So that is how we would do that for the attack conditions. All right, so that's it for the attacking. Let's head over to the next part, which will be in our actual level, I believe. See you all in the next part. All right, now what we're going to do is actually head back to level 1, and we're going to start editing the scene a little bit because, well, this looks kind of dead. It looks bland and not very good. So we're going to start editing the scene and adding things and making the environment look better. Now, we'll do this in 2 parts. First, the environment, and then second, the actual level. Of course, there's a lot of things that will go into the actual level, but we'll do a little bit at a time. Now, the environment, I won't say is easy, but it's easier in the sense that all we need to do is add something, a node called world environment. Now, this is a world environment or an environment that persists amongst most scenes. As long as it exists within the scene, it will essentially override the actual environment. Now, this is really cool because what we can do is give it an environment, and nothing looks like it's changed. But if we go into here, we can start changing things. Now, this kind of depends on what you're making and how you want it. Now, we're going to be doing kind of a dungeon crawler feel. So what we'll do is we'll go to the background, and I'm going to select custom color. Now, let me show you the sky just for an example, because the sky is cool, and usually you would use this if you're outside. So we'll go create a sky, etc., make a sky, and now we have a nice little sky. And if I were to play the game, it might look a little cleaner. Right? It looks a little nicer. It doesn't look as dead and horrid as before. But we're not going to use sky. We're going to use custom color. Now, this is cool, but it's a little too dark. So what we'll do is we're going to take the color, and this is up to you. I'm going to adjust these colors kind of just a little bit. So at this point, it's literally up to you on how dark you want it. I'm going to set the colors to 50, 50, 50. There we go. And this gives it kind of a grayish feeling. It doesn't give it completely black. And you'll notice more of a difference as we add more things like light and those kind of things. So, and we'll of course kind of come back in it and play more. All right, next what we'll do is we will go into the glow and enable that. Now the glow levels we'll play more with later, but for now we can copy what I have. So what I will do is I'll go to the light energy. Right, no. We'll go to the intensity and set that to 0.4, the strength to 1.25, and the blend mode to screen. Now for the fog and volumetric fog, I'm going to turn those on. You can notice immediately that we have a very different effect. Now this is too strong for me, so I'm going to go to the light energy, turn that to 0.1, and the density to 0.0143, so a little higher than what it was before. Now for the volumetric fog, let's turn that on. Now for the density of this one, I'm going to make it much lower at 0.02, which I mean, it doesn't seem that much lower, but it is a little bit lower and it makes it a little better. And that's it. So that is our scene, that is our environment. And now when I play, you can see it's much darker and it looks a little more like a dungeon crawler. Now the cool part about this is we can start adding light. Now we're not going to do this just yet, obviously, but I'll use an example. So we have a few different lights. We have directional light, omni light, etc. Now the spotlight is something we'll use for the player. Add later. Let me just show you what that might look like. Make it a little bigger here. And if I just hit play, we can now see a spotlight on the player like that. Now, that is something that we might add on the player, and it's up to you, but we will actually do that. So what we'll do is we'll delete the spotlight from here, head into our player, and we'll repeat that same process. So let's add our spotlight. We'll do that by going to the recent or search it up. Now here, what we'll do is make it much higher, not that much higher, but now we'll also rotate it to look down. Now we might want to go into the transform and make it actually -90. And for the position, you can kind of adjust it accordingly, but do keep in mind that this does not reach the player all the way down. So you might want to, make it lower or bigger or whatever you might want, right? So here we go. We can kind of make it a little skinnier, higher, whatever you may like. Now at this point, this is what it might look like. Take a look. There we go. We have our little spotlight on the player. Now I want mine a little wider, but also a little longer. I'll kind of leave it like that. Now if I hit play, there we go. We have a little bit of a bigger spotlight so I can actually kind of see around me. Now, you may want to adjust the values of the environment yourself and play around with the values. I really do encourage just playing around with some of these other things. I didn't play around with them too much, so I want you to actually play around with them, maybe go into the lights, stuff like that. Of course, some of these might not take effect until later, until we actually add some more things, like for example, the torches and such, right? So in the next part, we're gonna start editing the actual level, making it so that we actually have a level and actually have kind of a cool place to walk around, right? So let's head into the next part to do that. All right, welcome everyone to this part. In this part, we'll be kind of editing our level. Now, at this point, of course, you can kind of feel free to skip this if you want to just do your own thing, but I'll kind of just show you level editing and adding things on our tile map or grid map here. So I'm pretty much just going to add the walls and stuff and start editing the level. But feel free to, follow along or just skip this part. Yeah, so let's get started. The first thing I'll do is I'll start at one of the corners. And if you don't remember, all you need to do is hold shift and middle click to move along and zoom in at different parts. Now what we'll do is I'm going to just scale these walls here and click each one individually because unfortunately, if I try to layer them like that, it'll kind of just look weird. So I'll layer them all like that. And I'm going to scale the entire dungeon all along the wall here. And here I'll do this corner like that because now just add this corner. And of course, if you're wondering how do I rotate them like that, all you need to do is press S to rotate it along the Y coordinate like that. Now I'll just going along this line. All right, that is the bottom line. I might just extend that like this. Yeah, maybe let's extend that part by 1 tile. And maybe let's delete that. There we go. And we'll just put the tiles there. Well, that way we can extend the tiles the other side. All right, we'll do it like this. Of course, you could just fill it. That would probably be faster, but I'm just going to do each one individually. That way I make sure that everything looks nice. Of course, a better way to do this would actually be setting the cell to the proper size. But, I'm too lazy for that, so we're not going to do that. What we're going to do is do this manually one by one. And that, like that. And here, and we're missing a tile right there, so we'll add one in. And there we go. We'll continue along this wall. And of course, at some point, it might sometimes be helpful to also just add a Omni light. And what that might look like, not an Omni light, sorry, a directional light. This might help some people actually find out what is happening. If you rotate this, not that way, this way, you can get some light on the actual scene, and it might help you, see things a little better. Because unfortunately, we can't just hide the world environment. Of course, you can reset it like this, but I'm not going to do that. Another thing that I would encourage you doing is you can also left click here and save this as its own scene. That way we can save it as a scene. So, if we save as, here we go, it'll actually save as a resource file. But I'm going to leave it like it was before and go back to the grid map and keep drawing. So let's head over to one of these sides here and just start drawing a little corridor. And essentially, I'm going to make a corridor here. And at some point, I'll kind of erase one. What I'll do is I'll just go all the way to the end here. And there we go. I'll just have it go through the wall. Actually, no, that doesn't make any sense. I will put one of these there, even though it looks a little funny. I can now replace one of these. I'll remove it by left clicking and add a little door there. So that way we can actually enter into the main area. Then maybe I'll make another little room kind of right here like this. And this will allow us to kind of just create a different room and allow us to go from one room to another. And I'll, of course, remove one of these and add a door. Then I'll add one more door, maybe right there. Then add one of these and one of those like that. There we go. There we have a decent level. Feel free to continue the level. I might just leave it like this and just add one more maze part here like this. And okay, I'll leave it like this. I think this is good. I'll kind of block it off like that and then leave a door here. And the end level, I'll put it right there. So I'll put a staired wall right there. Right now at this point, what we'll do is we want to go to the next level. How do we do that? We do that by going to the floor number. We increase the floor number by 2. We can now edit the second floor. Now what we'll do is, add some tiles and make a little room here. And this will essentially be our next level room. So here, I'll just make a wall around it like this. And here, and here, and there. And now I'll just scale the entire room. Right there, next to that. Make sure it doesn't go into the stairs. There. And of course, feel free to actually, make this properly. But I think this is good enough for me. And we should be able to just, hop onto the next level here. So there we go. There's our level 1 floor and then our level 2 room where we'll actually go to the next level. But of course, the level 2 we'll do a little later. For now, this is a good start. Now our player, I'm going to move him all the way over here and the beginning. And this is where our level will begin. Now you can also, of course, have a spawn point as a node 2D. That's something I'll let you kind of figure out if you want to continue this as your own project. But for now, this is pretty good. And now if I hit play, we can now see our full level here. And yeah, so this is our level. And let me remove the directional light. Maybe hide it like this. And there we go. This is our level. It looks a lot darker. It looks like a real dungeon crawler. It's looking really nice. You can actually navigate the rooms, run around. Everything's animated. We go. We can go to over here, and we can jump up. And there we go. Now the collision for the stairs is not perfect. Now stairs themselves have quite a bit of logic sometimes. In fact, there's many different ways that people will actually code the stairs. So I do encourage you to look up stairs, and it's actually a really good video. I believe the tutorial is actually in Unity, but the logic itself is very good and can be applied to any engine. So do look for stair tutorials. The way I did it was just made a slant. Now that is a very simple way of doing it. And it's kind of more of a band-aid way of doing it, right? So do look up some tutorials or ways of making stairs properly, as sometimes stairs can actually make or break a game, right? So that's something that you can definitely look into after this series. So that is it for this part. In the next part, we will start looking at other things. So we might actually start looking into our enemy now, because we are, I think, are ready to go and actually start creating some AI monsters. So I will see you all in the next part. All right, let's get started with our AI. So we're going to have 2 things to this. Now, one of them we're going to kind of return to much later, but the first part is the melee monster. Now, okay, we'll kind of set everything up first, and then we'll get into the depths of it. So the first part we want to do is create a new folder for it, right? So we'll create a new folder, and we'll call it monsters. There we go. And we'll also create a new script folder called monsters. And in here, in our script folder, make sure I spell it right, monsters. In our script folder, we're going to separate it into 2 things. First, we're going to create an AI melee and an AI range. So we're going to have 2 different kinds of AIs or monsters. Now, the reason is, of course, well, I mean, I don't think I have to explain why. We're going to have 2 different ones because that's just a decision I made. But I'm going to show you how to do both of them. They are very similar, but they are slightly different in terms of, attacking specifically. So we'll look at how to change that. But we'll start with the melee first. Okay, so we'll make a new scene here, and you might guess that we're going to create a character body 3D as the base of this monster. Now, this monster, we'll name it Warrior Skelly. Of course, maybe let's actually find the skeleton first, and then you can decide what you might want to name it. Because if we go to characters here, GLTF, you'll find a few different ones. Now, I'm going to be using the mage for the ranged one, and then for the monster, the melee, I'm going to use the warrior. So here, we're going to right-click and make local, and we're going to go into the transform and reset it to the default position. And now you can see we have an exact kind of replica of the player, right? But same animations and everything, but it's just slightly different. Now, in our actual body here, what we're going to want to do is, well, we're going to want to give him a sword because he's not holding anything. How do we do that? Well, it's actually not that hard. We kind of learn this through Kay. He has his own tutorials, and it's kind of, I don't know if it's a video, but essentially all we need to do is create a skeleton or a bone. I don't need to create the skeleton, actually. The skeleton's already made for us. You can see the bones are connected. What we need to do is create an attachment to the bone. And now the bone attachment 3D, we can go to the bone name and find whatever we want it to attach to. Now what we'll do is the right hand slot, hand slot right. Okay, now there is also hand slot left. Of course, you can use that however you'd like. I'm going to rename this to hand slot right, and I'm going to put my sword in here. Now, where's the sword? Well, I'll find it in the assets, the GLTF, and I can find whatever I'd like. I'm going to use a skeleton blade, drag that out, pop that into the hand slot, and now if I actually reset this, it'll actually look as if he's wielding it. And what I'll do is I'll make local, and I'll just take out the mesh because we don't need the node. But now because this mesh is attached, we'll actually reset everything as well, scaling, the transform, and everything. And now, you could change the transform actually, or the rotation if you'd like. Maybe we'll keep it like this. Maybe we'll actually take a look at the actual attack. So let's take a look at what the attack might look like. Okay, so that's not what I want. I want it to actually look like that. Or, of course, if you want to rotate this 180, that's also fine. Have it slice on this side of the blade. That is what we'll do. But now we don't have to reanimate everything because you actually look at the animations. This might make a bit more sense now. The animations are using the skeleton 3D. This skeleton 3D is very adaptable. We don't have to go through all of this, obviously. It's very adaptable in the sense that now what I need to do is just connect whatever I want to a bone, and that thing connected to it will move with it. So the skeleton blade will move with whatever animation we put on it. So even the spinning one, it will spin with it. Now, we're not going to use the spinning one for the monster. We'll probably use the slice. Maybe. Well, I mean, it's up to you, of course, right? You can pick whichever one you'd like. But I'll probably use the slice for the attack. But of course, we'll need to set that up. Now in here, we need to create a collision body or collision shape. We'll give him a capsule, move it up, and make it a little skinnier. All right, there we go. Now we'll save this into our monster scene. Save, and there we go. Now what we'll do is we'll go to level 1. We'll take our warrior guy right here and pop him into the scene. All right, it lagged a little bit, but that's okay. And now we can pop this up and make sure it's in the right position. All right, there we go. Now if we play, we should be able to see our monster. Now he doesn't do anything, but he exists, he's there. And ideally, if he has gravity, he would fall to the ground, right? So let's start implementing this and actually making sure he works, because at the moment he doesn't do anything. He kind of just is in the air, and that's not very useful, right? So let's get into actually making it work. All right, the first thing we'll do first is actually connect an animation tree. Now this is going to be very similar to what we did. So we'll need to assign an animation player. And in fact, I would encourage you to pause the video, try adding everything yourself, because a lot of this is going to be very similar. Now, one thing I will say right now is that the conditions to move amongst the animations will be different. So don't worry, we'll kind of do that together as well, and it won't be as difficult. So why don't we'll do it together, but I do, again, encourage you to pause the video and try it yourself, all right? Okay, so hopefully you've paused and paused. Let's do this together. Let's go into here. Let's start adding our animations. First, we'll add our idle. Now the idle, actually, what I'm going to do to make this a little different, I'm going to add the sitting idle. So if we search up or press, there it is, sitting idle, sitting floor idle, and I'll rename this to idle. And that'll be our idle animation. Then I'm going to have the wake up, which is going to be skeleton awake standing, I believe, this one. So we can double check this by going to here, and let's connect these. All right, there we go. We now see that that is the correct one. So we'll rename this to awaken. Right? We'll create a new animation. Now this one will be running. And you can either do running or walking. I'm just going to do running because it's a little nicer and smoother. We'll rename this to run. We'll also have attack. And of course, at this point, you can choose whichever one you like. I'll do a two-handed slice. Yeah, I'll do a two-handed slice, and I'll rename this to attack. And lastly, all we need is the death animation. So I'm just going to press D, and it'll show us where it is. Rename this to death, and there we go. Now, for the transitions, this is quite simple. All we're going to do is create a transition between pretty much everything. So from idle, except from idle to run, because I only want to go from idle to awaken or from idle to death. Now, attack, we should be able to go back to idle. Attack, we should also go back to run, and back to from run to attack, and of course, attack to death. All right, now what we can do is turn off the auto for all of these transitions. Now, the reason we're doing this is because we're going to travel or transition between all of these animations through code ourselves. Don't worry about the actual conditions. We're not going to use that because the state machine we're going to use is going to be very different. Because if you recall from our state machine lecture or from our kind of explanation, I wanted to show you two different ways to create state machines. Now, again, I will note that there are many, many ways of creating state machines, but I wanted to show you two different ways just to highlight kind of Godot's features and cool things that Godot can do. All right, and lastly, of course, this one. So we'll turn that off. There we go. Okay, so now what we can do is minimize that, and we will go into our script, which we do not have, and we'll create this. So let's create a new script here and go to player or scripts, monsters, AI melee, and open it in here. And we will use the template for now, just to see it kind of fall. So now when I play, he should just fall to the ground. There we go. And he's doing the T-pose still, and that's okay. And you can see here that I can do that little spin attack on him, and it does absolutely nothing. But I do collide with him because he does have a collision shape. All right, that is it for this part. In the next part, we will continue the monster, and what we'll do is we'll actually start implementing or creating state machine. But first, we want to take a look at how do state machines work, how we'll implement the state machines for this monster specifically, because we're going to do it a little differently. All right, I'll see you all in the next part. All right, welcome back, everyone. In this little section here, I'm going to explain something called classes and nodes. So in Godot, we have these two things that are called nodes and classes. Now, in order to create an object, a node, we can actually just call, like, for example, label, and this is a node that we might be familiar with, and then just say new. This essentially creates a new object for us. Now, this is common amongst programming, and you might have seen this in general before. Now, this will allow us to actually create a new object, and we can add it into our scene and do whatever with it. Now, in Godot, we can also do something and create our own classes. Now, when we say class name and then give it a name, like let's say idle state, this will create our own new node. Now there is something else we can do, which is called extend. And you might have seen this already. This extends a current node that already exists. We can extend, for example, node 2D, node, or literally anything. For our example, we'll probably use node. Now, essentially what we can do with this is create a new node inside of Godot that will allow us to structure our nodes with a state machine. We'll have a state machine controller. So this will be kind of the main states, right? This will hold everything. And then we'll have the idle state, the run state, for example, and attack state, and a few others. But this will allow us to physically see the nodes that are happening. And inside of each of these, we will see the behavior of idle, right? So for example, velocity is equal to 0. For this one, velocity is whatever, right? 10, let's say. And then in here, play the actual attack animation, etc. And this node right here will allow us to change states, right? So we will utilize the classes and nodes and extensions of Godot to create these new nodes, these state machines. This will allow us to customize our nodes as much as we want and actually have it do whatever we want as well. So let's head over to Godot and see how that works. All right, so in Godot, we're going to head over to our scripts folder. That way we can actually get started and create the states and scripts that we'll need. So in here, in the AI melee, we're going to create a few new scripts. Now we do have to actually create the scripts in here because, well, there's no nodes that we're connecting it to, right? Because we're creating the node using this script. All right, so let's create some nodes called idle state. And in each of these, what we'll do by default is in the idle state, we will simply extend node. We'll delete everything so that way we only have these two. And we'll duplicate the idle state and we will say run state. We'll duplicate one more time. We'll say pack state once more, and we will have get state. And in case you're wondering, you can just hit Control D to duplicate, or of course, right click and be able to duplicate. Now, one last one that is not a node exactly, but that is a state machine. This is the state machine controller. Feel free to call it state machine controller instead. I'm just going to call it state machine. And what we'll do is we'll create a new node here. And there we go. This will be our state machine controller. If I can just type, there we go. And I'll put it right here at the top so we kind of know where it is. Now in the state machine, we will assign it to state machine. Now, there are a few ways to kind of create a new class, right? Or a new node. Now, I'll show you two ways. The first one is, like we said, class name idle state. Now, I will say there is an issue with this. Okay, so, if we do this, what we can now do is find this new state by searching up state, and you will see that the idle state is right there. And it even has a little node, and that is because we extended node. Now, if I did node 2D, let's save. It should now show under the node 2D, right? And I can even create it, and we can now see it here. It is a physical node that is there. Now, that is one option, but we're not gonna do that. Now, the problem is, you might maybe notice this, is that we will have actual nodes in here, right? And it can get very messy, right? As I create new nodes or new states, new things, it gets very messy, specifically for state machines. Because what if I have 10 different monsters with 10 different behaviors? Right? That's not something I want. So another way to kind of create these classes or nodes is to actually load the script, and then we will use that script to create a class. So what that will look like is we'll say state equals, and it will create a dictionary to hold all the states. So for example, we'll preload the idle state. There we go. And now we'll duplicate this for each one. So we'll say run, say attack, and lastly, death. All right, for each of these, we will go over here and just change these. One is death, and this one is run, I believe. Make sure that all these are correct. And now what we can do is we'll create a new function called change state. This will pass through the new state as a string. Okay. Now the reason it's a string is because here we're using string names, right, for our keys in our dictionary. Okay, in our function, what we can do is we'll do a few things, but let's take a look at the crux of actually creating a new class. So what we can do is say variable state temp dot or is equal to the state of the new state name, right? Because we need to get access to which script we're loading, right? Essentially, this will allow us to get access to idle state, for example, right? And now all I need is .new, and that's it. We've now created a new state. Of course, all we need to do now is just add child and state temp. Now, one thing I'll add in between, and this is just to actually make sure we can visualize this, is what we'll do is say state temp dot name. Now, dot name is the name of a node. We created a node, right? We created this new object by saying dot new. So now we can adjust its properties like name. And of course, I'll just say its name is the new state that we passed through originally. Now what we can do is, just to show what we did, I can change the state to idle, for example. And I do have to make sure it's typed properly. And if I hit play, we can now head over to the remote section and find in our warrior skelly that we now have an idle state. Now we do see that it's a node 2D, and that's because I did it over here. So let's actually remove that. We'll also remove the class name as well. I don't want it to have its own class. All right. Okay, that is it. So let's actually redo that one more time so you can see that it does work even without the state class name. All right, there we go. And we can even go into this idle and see it has properties. Right, so for example, if I put in our idle state here, and this is something we'll use, is our AI controller. We'll just say AI controller. This will essentially reference the actual person we're in, so the warrior skelly itself, but we're not going to put anything in here yet. So if I play again, I can go to remote, and again, I can see the property is null, right? But it shows that it has its own property, which is really cool. Okay, so there we go. We now have a decent state machine controller. Right? All we need to do is actually utilize this. Now, this function is not complete because there's a few other things we want to check for if we're changing states. The first thing we want to check for is if there's any other states that exist. And we can do that pretty easily by saying get the current child count and ask if it's 0 or not 0. If it's not 0, that means we have a current child. So we'll get child 0 and just .queue_free. This will get rid of our current state. Next, what we'll do is we'll first check to see if the state that we're trying to add even exists. So we can say if state has new state. And this state, right, is the dictionary. So we're checking the dictionary to see if this state even exists. And if it does, then we'll create the new state. All right, so this works pretty much the same as you might have seen. It just avoids a few errors and, of course, gets rid of the current state. All right, so now what we'll do is we'll actually kind of head into our states and start to add some controls. The first thing I'll do is, we're not going to do all of it just yet, but just to kind of show you what we can do, we can say AI controller is equal to get parent dot get parent. And now this will get access to the warrior skeleton. So if I hit play, and I go to my remote, I can go into, nothing's going to be in there. So what we'll do is we'll go into my warrior skeleton and add a function ready. And what we'll do is we'll get access to the state machine. In fact, actually, we'll create an onReady variable for this guy. We'll say state controller is equal to get node state machine. Now we can just say state controller dot change state to idle. And just make sure that we type this change state function properly, because sometimes it doesn't autocomplete for us. And now if we play one more time, we can go to remote and go to idle and see the property is referencing object ID. And this, if we click into it, it will tell us this is the warrior skeleton. Now it doesn't show the name, and that's okay, but we do see that it has the same properties, right? The jump velocity, speed. In fact, actually, sorry, it does tell us the path, right, which is root warrior skeleton. And there you go. So we now have access to our warrior skeleton from the state. Okay, so in the next part, we'll actually head into adding functionality into all our states. And yeah, so I'll see you all in the next part. All right, welcome everyone to this state machine part. In this part, we're going to be continuing our state machine. So let's continue from our idle state, because this is the one that we have open already. Now, what I'm going to do first is I'm going to close everything. And then I'm going to open every state. So that way I can just do this, pop everything out. And now I can edit it within this script here. So, okay, the first thing we'll do is the actual functionality of an idle script. So we'll create a physics process. Now you might be wondering, what do we do here? It's actually pretty easy. All we need to do is say AI controller velocity x equals 0. And then we'll also take the z and also make that 0. Now you can, of course, make your own math and maybe blurb the current velocity to 0, move towards those kind of things. I'm just going to set it to 0 for simplicity. And yeah, so that's what I'm going to do. I'm not going to overcomplicate anything as much as I can. But another thing we'll do is we'll also check to see if AI controller is valid. If we don't do this, sometimes the game will error because it needs to take a second to essentially get access to the AI controller. Not a second, but a millisecond, right? And it might not work properly if we don't check to see if it exists first. Okay, next, what we can do is we can check the AI controller. What we want to do is we want to check for something called, we'll say getting up. If the AI controller is currently in the animation of getting up, so we recall, why do I have 2 here? Let's just delete that one. The awaken animation here, right, where he's awakening, right? That's where we don't want to animate the idle yet. So what we'll say is we'll copy this. We'll say if AI controller awaken or awakening, then what we'll do is we will use something called await. Now this will allow us to await the animation. Now what we can do here is just say AI controller get node animation tree, and we'll wait for the signal called finished animation. Now this animation or this signal is actually a signal. It is in the signals node here. You can see that it is animation finished right here. Right? We won't pass through anything. We won't return anything because we don't care. Right? What we're trying to get here is just the signal, right? And we're going to wait for it to finish. Right? And then what we'll do is copy paste this, and instead of the animation finished, we'll say get parameters /playback, and then we will travel to idle. Okay, so essentially what will be happening is if we're currently playing the awakening animation, we'll wait for it to finish first, and then we'll travel to the idle. Because if I'm already animating awakening and I leave a range or whatever, and I want my monster to go back to idle, well, I can't just stop I don't want to just stop the animation in the middle and go back. I want him to finish the animation and go back to idle. Right? Otherwise, it looks choppy and weird. Okay, now at this point, we can copy paste this into each state because, I'll actually just copy everything. We're going to have somewhat similar logic in each one. Obviously, for this run state, for example, we're not going to do this, but we're going to have similar things, right? So in our run state, the run state next is relatively thick. Now for this, we're not going to check for awakening, we're going to check for attacking. Now if we're attacking, If we're currently attacking in the run state, or I want to go into the run state, I'll wait for the animation to finish. Now here, I'm going to add an else statement. Now, if I'm not playing the attack animation, then what I can do is I can just play the get up or the awaken animation. Because at this point, I want to play the awaken state first if I'm going to travel into attack right away. Okay, so if I'm not attacking, then I want to just go straight into awaken. Okay? Now what we can do is, remember here we have the awakening. Now the only time I play this is here. So here I can tell us that this is true. Now obviously we're going to have to add this into the AI controller, because if I run this right now, it'll error, but we'll do that in just a minute. All right, now what we can do is we'll have another await here, because we want to wait for this animation to finish as well. Because if I play this, and then right after, right here, so if I copy this and put a travel for attack, then what'll happen is that, or sorry, run, because we're in the run state, what'll happen is that it's just going to stop this, right? It's going to stop this and then travel straight to run. So we want to await for this to finish, and then we'll travel to the run. Okay? But in between that, we also want to say run is equal to true, which is going to error in a second. And we also want to say AI awakening is false. Now this, we will create a variable here, but we'll say it's false. This is a Boolean. And this will allow us to figure out if we're running or not, because the problem is even though we are in the run state, we don't always want to be running, right? Because if I'm playing the awakened state, where I'm waking up, I shouldn't be moving, I should be static, right? And so the velocity should be 0, right? But I don't need to set it to 0. What I'll do is I'll just say here, if AI controller and run, then what we can do is adjust velocity. Now what we'll do is I'm going to use a simple calculation here. It's pretty simple. All I'll do is I'll get the current velocity, not velocity here. I'm going to get the direction, which we'll have to get in the player as well for the AI controller. We will say times the AI controller speed, which we already have actually, because that's already by default in the AI controller. Now similarly, we'll do the same thing here, but for the Z. There we go. And then lastly, we're going to use something called look at. So what does this look like? We're going to get access to the AI controller, and we're going to say look at, and we have to pass through a position, right? Now this function essentially just does what it says. We're going to look at a position. Now what do we want to look at? Well, we want to look at the player, right? So what we'll do, we're going to say AI controller dot global transform dot origin plus AI controller dot direction, and then we'll pass through vector 3 at 0, 1, 0. Okay? And this will allow us to look in the direction. Now, the direction we need to actually get access to in the monster, and this is the player. This is essentially the direction of the player, right? And that's what this is as well. We're going towards the player in the X and Z axis, okay? All right. Now we'll do the attack state. So the attack state is a little easier because a little bit of what's happening is not actually in the attack state, but also in the main script as well. So in here, all we need to do is change a few things. So here, instead of traveling here, we're going to travel to attack, obviously. Now, for the awakening, we can actually leave this because sometimes there are cases where I might run into the monster and kind of skip a state, and I could be still playing that awakening animation, even though I go from idle to a run to attack, right? I can kind of run into range faster than the monster can play these animations. So there are cases where he might still be playing the awakening animation, even though we're in the attack state. So here we want to also wait for that. Right, next what we'll do is we'll get the AI controller attacking is equal to true. Because if you remember, we also use that here, and we need to say that attacking is true here. Because we're looking or we're attacking. Now, what we're going to do also is look at the player at the ready function, not in the physics process, mostly because that's how I want it to be. Because here in the ready, this will essentially look at the player once the first time it starts its actual attack. Because I don't want it to keep updating where it's looking whenever anytime in the attack animation, right? So if I start moving around the player or the monster as it's attacking and it starts looking at me while it's attacking, it's just kind of weird, right? It doesn't look or feel natural. All right, the next part is the physics process. Now this we don't actually have to change because it's already right. We don't want to move when I'm attacking, right? So this is it. This is our attack state. All right, lastly is our death state. Now our death state is really easy. Go into here and we'll just play death. And we will not wait for this to finish because that's silly. We'll just travel straight to death. We'll stop whatever animation is currently playing and we'll travel straight to death. That's it, right? Because if I kill something, even if it's like moving at me, it should just die, right? So that is what we'll do. We'll just straight up travel to death. All right, now let's close this and head into our warrior skelly, as there's quite a few things we'll need to change into here. So in here, what we'll do is we're going to add a few new variables, the ones that we tried using that don't technically exist yet, right? So the first thing we'll do is we'll create a variable called direction, and this is a vector3. We'll create a awakening. Let me actually make sure I type this right. Awakening. There we go. Whoops, awakening. And this is a Boolean, and by default we'll set this to false. We'll create a attacking Boolean, and also this is false by default. We'll create a health. This is for later because we haven't implemented this yet. But we'll set this guy to, let's say, 4. We'll create another variable called damage, because this is how much damage he'll do. We'll set this to 2. Create another variable called dying is equal to Boolean, and it's equal to false by default. And lastly, we'll create something called just hit, and this is something we'll implement a little later, but this is essentially to find out if I just got hit or not. Because what we'll do and what we'll implement is a way to kind of add an invincibility where my monster doesn't get hit if it just got hit like 2 seconds, like 1 second ago or half a second ago. So I can't just constantly hit the monster. I have to kind of play it nicely. And we'll also add this to the player, so don't worry too much. If you don't want to implement it on the monster, that's totally okay. We'll implement this later in the player as well, once we actually add the damage. Okay, now in the ready function, we need to change states to controller to idle, and that's it. So in the ready state for now, that's all we're going to do. Next, we're going to make sure that we have gravity. Now, we don't want this, and we don't want this. We don't want any of this here. So now all we have is the gravity, move and slide, and we're going to add something else. And what we're going to add is if player, then what we'll say is direction is equal to player dot global transform, dot origin. And then we're going to subtract the self, same thing. So dot global blah, blah, blah. And here we go. Now we have a problem is the player. What is the player? Well, over here, we'll export variable player, and we'll say that this is a character body 3D. Now this is very cool. Now let me show you why this is cool. Like, it's cool and I can say it's cool, but why is it cool? Well, okay, let's close this for now. Let's head over to our level 1. Now in our warrior skeleton, if we go to the inspector tab, we can now see a new variable here that I've exported. This is the export from the variable I just made, the player. Now the cool part about this and defining the type of the character body 3D is that now I assign this, it will show me only the character body 3Ds, and I can select the player. And now, here we go. We have a way to get access to our player. Now, this won't work yet, but what we can do is say print direction, and we should be able to just play and get the direction of the player, and it will print the direction of the player. You can see that we can always move, and it will change the direction of the player. Now, the monster doesn't do anything yet, obviously, Well, it is in the idle state, so that's cool. And I don't think it's looping actually, so let's do that. Let's make sure that our warrior skeleton here in the animation player, in the sitting pose, sit floor idle is looped. So that way, when he plays this, he's looking around a little bit better. And then none of these need to be looped except for the run. So let's also do that. Forgot to loop all of them. So go to the running A, loop that. And then I believe that's it. Yeah, just run and idle. Those are the only ones that need to be looped. Whereas obviously the attack should only happen once, and the death should only happen once. And then same thing for the awaken, it should only happen once, and then go straight to running or straight back to idle, depending on what happens. Okay? All right. We'll continue the monster in the next part, because now what we need to do is add conditions or a way to change states. Because we have all the states, it works, but we don't have a way to test it. We don't have a way to switch from one state to another. So in the next part, we'll add something called an area 3D that will help us control whether or not we can go within a certain state or not. Okay, so I will see you all in the next part. All right, to continue our monster, what we want to do is create some new nodes. Now those nodes, we're going to add an area 2D. We're going to duplicate it because we're going to need two. One is going to be essentially to start chasing the player. This is to go from idle into running, right? So we'll call this chase player detection. Okay. Now for the next one, this one will be the attack player detection. Okay, so this one is to go from running to attack. So if we're close enough to attack, then we can attack. Okay. Now we'll need two more things. We'll need a timer, and I lied, that's just one. So we're just going to need a timer. Now this one will be the just hit timer. This is essentially the thing that I showed you where if we just got hit, then I don't want to get hit again. So here, we'll do this one first. We'll connect this timeout here. Now here, what we'll do is all we need to do is just say just hit is equal to false. Or sorry, yeah, false. Okay. Now the next two, we'll do the actual thing in a second, but we'll just connect the signals that we need. So we'll connect the body entered and the body exited. We'll also do the same thing for here. And body exited. Now there's a problem, or not a problem per se, but something that is a little difficult here. The problem is the body. The body itself, how do we check to see if it's a player? Because a body could also include the static body, the floor, the walls, right? Itself. It actually will detect itself because itself is a body, right? This is a character body 3D. So we don't want to check for all these things, right? We only want to check for a player. Now there's many ways to do this. For now, we'll do it this way. We will say if player is in the body.name. Then we'll pass for now, and we'll do the logic that we need. Okay? All right, now what is the logic we need? Well, in the player, chase detecting, this is quite easy. What we'll do is we'll copy this state right here, and we will say, okay, so on chase entered, we want to go into the run state, right? We'll say run. Now, what we can do is copy paste this into everything and change these depending on what we're doing. So this one is exited, so that means we're going back to idle. This one means we're going into attack, and this one goes back to run. Of course, let's just delete all this, comments and stuff. And that is essentially it. That is how we create the transitions for the state machine, right? Now, there are a few more things that we need to add, but for now, this is going to be decent enough. Now, one more thing we'll add real quick is an and not dying statement, because I don't want to be animating these things or running, changing if I'm dying, right? So we'll copy that in all of these. All right, the last thing we'll do is connect a signal from the animation finished in the monster. Now, why are we doing this? Well, this is a good way to also detect many other things and figure out what is happening. So what we can do is we can check to see which animation is happening or which animation just finished. And say if the anim name is equal to awaken, for example, then what we can do is set awaken, awakening equal to false, right? This is another way to essentially kind of double check that we are finished awakening. Okay, so we'll copy paste that. Now for this one, we'll say if we just finished the attack, then we can say attacking is false, right? Now another thing we can do here is we could add a change state to run. And this is actually good because what we want to do sometimes is the attack will go back into run state, and then we'll go back to attack state again, just because that means we can now play the attack animation. Because this attack animation is only happening in the attack state. So what I want to do is I want to change back to the run and then change back to attack. Okay. Now we'll copy paste this one more time. And what we can say here is say if the animation is death, then what we'll do is for now we will queue free. So queue free. But this will allow us to detect if we just finished the death animation, right? So there are other things we might add, which we will add later. For example, a death function maybe where we randomize some items and create some items, right? For the monster, for the player, maybe give the player some XP, etc., right? These are things that we can do in there. Okay, now let's see if we can test this. Let's hit play, see if things are going to work. No, nothing's going to work because in the player, we need to actually add the collision shape. So let's add a collision shape to both of these areas and make sure we adjust these accordingly. Now for the chase state, what we'll do is we'll make this a little unique and give it a box. Now the reason we're going to give it a box is because I'm going to give him eyes in front of him. So essentially, he will see what is in front of him to a certain extent. So any sort of body that's in front of him in a certain range, we will be able to attack, right? And see, this is essentially his eyes, right? And you can give it a range depending on how long you want him to see. Now for the attack, we will give this guy a cylinder. Now the cylinder, we'll move it up a little bit, and we'll extend it to his attack range, which will be probably right around there. Okay? We might want to actually adjust this one accordingly, depending on the behavior of the attack. So now we can try this out. All right, let's take a look. Let's see if I can enter his range. Okay, we got an error already. Very cool. All right, so it says invalid get index. What are we invalidating? Finished animation, animation tree, weight controller. Okay, so maybe what we can do is to debug this, we'll find out if the state machine, the current state, what is this? The run state has access to the AI controller. Okay, it does, which makes sense because this didn't error. This one did. So it's saying that the animation tree is invalid, get index animation finished. Maybe I misspelled this. Yes, I did. It is animation finish, not finished animation. Not sure why I made that mistake, but let's make sure we do that in all of these now, because now I need to go back and do all of these finished states. And in fact, what we can do to double check that we don't have any of this, it's a cool trick. You hold Control-Shift-F, you can find in your files anything that says this. And of course, it'll tell us that this is the finished animation because I haven't saved it yet. Okay, let's copy paste that. Make sure everything's fixed. Run play. And now let's try it. Let's walk in front of him. Okay, he's going to awaken. And okay, we have an issue. Okay, the issue is probably the actual rotation. So the rotation of our monster, we need to actually change the skeleton to -180 here. And then what we'll do is we'll take the eyes and we'll actually move it in front of him now. Okay, so that's the way I set up the code. Otherwise, we would have to actually switch the look at state as well, or the look at function, the way that we made this, which you can do, of course, but I'm just going to rotate it to make my life easier. And now, if we walk in front of him, okay, the running is really fast, but it does work. So he wakes up. Okay. See if it works one more time. It looks like I can actually go through the wall. Oh, no, I can't. just a little collision shape. Okay, let's take our skeleton here and adjust the speed because 5 seems to be very fast. All right, so we'll change this to, let's say 1. And then jump velocity, we actually don't need that anymore, so we'll just delete that. Okay, let's try one more time. And what I'll do is in my level, I'm going to rotate my skeleton right here to look towards us by default. And then I'm also going to go to the debug and visible collision shapes so I can actually see the collision shapes. Now we'll hit play, try one more time, and see if we can enter his range. Okay, he runs at us, good attack. And if I walk away, doesn't chase. Okay. All right, so I will, so we have some bugs. I'm going to try to see if I can figure out what's going on. I'll be right back. All right, bear with me. There is a little bit I changed, and I did figure it out. The basic problem was that we were changing states in places, and we weren't properly controlling and checking for the attack. So the way we're going to, I kind of printed it right here, but you can see that attack animation was not equal to attack. But what we can do instead is say if attack is in the animation. And similarly, we can also do the same here and say in animation. Make sure that this goes off. And of course, we'll have to do the same here. We'll say if death is in the anim name. Okay. Now here, I've also added a new thing where this will essentially loop the attack. So if the player is in the attack player detection, the attack player area, in the get overlapping bodies, this will essentially check to see if the player is still in our range of attack. If it is, I will change states to attack again. Even though I'm already technically in the attack state, I will change back there. Now, another thing I've added, and this is kind of important, a new animation here. Now, this is idle combat, and this essentially just looks like this. Now, it will look a little choppy, so what we can do is take the fade time, set it to 0.2, and same here for 0.2, 0.2. And now, one more last thing is in the run state, we want to make sure that everything looks the same as me. I don't think I changed anything, but just do make sure that everything is the same. Let me just pop out the code here so you can see everything. Everything looks right. And then back here, everything looks right. And let's test this. Let's see what we get. All right, so now I should be able to enter his range. Jumps at me, attacks, should be able to loop. And if I run away, he'll face me and attack again. And if I leave the range, eventually he should go back to idle. And then same thing. All right. Now, obviously, there are still some issues, but we will fix that a little later as we also attack the attack. Now, what else? One other thing. So I believe that is it. We will, of course, implement the hit later and all those things a little later. But for now, this is pretty good. And actually, yeah, one last thing I wanted to add is in the transitions, if you have or feel that some of these animations are choppy, like for example, from going back to idle, just take the fade time and set it to 0.2, for example, or from run to idle, set these to 0.2, and this kind of just fades the animation and makes it look a little smoother. So it doesn't just cut off the animation instantly. Okay, so I'm going to do that for all the transitions, and that way it just looks nicer. And I think especially for the death, that will make it look much nicer. Okay, that is it for now. I'll see you guys in the next part where we implement the attacks and everything and fix a few bugs. So yeah. Okay, so the bug, real quick before we actually go on to the next part, right here, we need to set run equal to false before we start this animation. Otherwise, it'll just go straight into running, and that's why it was running while we were doing that, while we were actually trying to animate, you know? So, okay. Yeah, and now, here we go. We awaken, we run, and we start attacking, or he starts attacking us. Right? So it looks pretty nice. We can attack him, he attacks us, even though it doesn't do anything yet. All right, next part, we will actually implement the attacking. All right, welcome back to this part. In this next part, we're going to start implementing our actual hit and make sure we can actually play death and stuff like that. So what we'll do first is we'll go from the player to the skeleton. So we'll be able to hit the skeleton and kill the skeleton first, and then we'll do the player. Not just yet. We'll kind of implement a little bit, but part of the issue, not really an issue, but one thing we want to eventually do is globalize some of the things like health, and we'll also have items, so item defenses, stuff like that, and we're also going to have an HP bar that we're going to need to implement, and we're going to use signals and stuff for that to implement that, and so that will require a bit of setup and work. Now, one thing I wanted to do is I'm going to shorten the range of the attack range just slightly, just so he can get closer before actually attacking. All right, and that will mostly affect the warrior hitting the player, which we'll again do later. All right, now in order to create a hit for the monster or for the player to the monster, we'll go to the player first. And now what we want to do is we want to go into the skeleton. Now in the skeleton, let's just minimize all these assets here. And we have a bunch of things. Now, if we go into these bones, you can actually see the bone name, right? And there's a lot of bone names, which I believe we went over once. Now, what we are going to do is we're going to add our own bone. Let's add a new node called Bone Adjust Attachment 3D. Now, what we can do is attach whatever we'd like. So we can attach a right hand or right slot or hand slot right. Now, this will automatically go to the left hand. And if you notice it, it's actually animating with the player. Now, the cool part is I can rename this to hand, right hand slot, whatever you'd like. Now, the cool part is that we can start putting things into here. For example, in Area 3D, and we'll put a collision shape. And now, if I give it a capsule, you can see that this capsule will actually animate with the sword. So let's adjust it to make it the same size as the sword. I'm going to make it slightly longer than the sword and make sure it lines up nicely here. And there we go. That is it. That is how we create the damage detector for the player. Now what we'll do is we'll rename this to damage detector. And what we want to do now is connect this signal to the player. So let's connect the body entered and pop it in. All right, now there's a few problems. Again, the problem that we had before is the body. Now, how do we check the body? Okay, in order to do bodies, what we're going to do, or kind of organize bodies, I'll say, is we're going to use something called grouping. So in Godot, there's something called grouping, and this, think of it as literally just a way of putting a bunch of bodies within a certain group type. So for example, we'll have one type of grouping with the player. Now, the reason we do this, of course, is to have access to the player in a certain group. Now, this is maybe more useful in a multiplayer game because now you'll have, all the players inside of this group called player. And you can always check to see if the body type is a player. Okay, what we'll do is head back to the 3D scene. And what we'll do is go to Manage Groups in the Node Inspector tab. Now here we have signals and groups. Let's go to Manage Groups. We'll pop this guy up. Now there's nothing here, so what we can do is add a new group. We'll add a player group, and do keep in mind, if you capitalize it, you do need to reference it as capitalized or not capitalized, okay? So I'm going to keep mine on non-capitalized. Now what we'll do is select the player, the base node, right, of this scene, and just add it into the group. And that's it. We've now added our player into the group, and you can even see it right here. Now, if I save this and head back to my level 1, you should now see this little guy right here. Now, what we can do is in the warrior skeleton, we'll do the same thing, and we'll just manage groups. And here, this is a monster type. And the cool part about this is that I can add it, we'll do the same thing. And the cool part about this is that in the future, whenever I make a new type of monster, I don't need to make a new type of group. I just need it to be in the monster group, right? Now, of course, you can have more than one group, of course, right? So maybe you might want monster and then type, right? So if it's a monster and a specific type, maybe you'll do more damage or less damage, whatever, right? Maybe you're making a Pokemon type game, something like that. So you can kind of get creative on the grouping and stuff like that. Okay, but now the question is, how do we check for a monster in a group? So let's head back to our player and go into our script. And I'm going to pop this out. And in here, instead of checking for the name of the body, what we can do now is say, if body is in group monster. Monster. So let's make sure I type that right. So in our skeleton here, yeah, so it looks right. Head back to our script. So make sure that you always, let's go back to the player here, always type it correctly, okay? All right, now what we can do is say body dot hit, and we'll pass through a number for now. Let's say 3. Now, we'll change this a little later because we do want player damage, which we don't have here, right? And this is something that we'll add a little later. But for now, we'll pass through a number, okay? Now, another thing that we can do, though, is in the damage detector, we can also first check for and is attacking. Because I don't want my player, to hit my monster when I'm not attacking, right? Because one of the issues that you might face is if you're walking, right, and this area 2D or 3D hits the monster, right, just as you're walking, then it's going to damage it. And that doesn't make sense, right? I mean, maybe in real life, if you accidentally swing your sword at something, it take damage. But in a game, we don't want that to happen unless I'm actually attacking. So that's a way we can, kind of mitigate that and make sure I'm actually attacking before I damage anything. Okay, now the actual issue is in the monster, we don't have that hit function that we just called, right? So if I were to actually play this, let's try it. And I go to my monster and I hit him, we will get an error. It says invalid call, non-existent function hit in base character 3D. Now, understanding errors is also a skill, so let's try to understand what this is telling us. It's saying invalid call. Invalid call means generally, I mean, it even follows up that there's a non-existent function or non-existent thing, right? Now, this can also happen to non-existent variables, but it's telling us here that it's a non-existent function hit in the base character body 3D, and it's even telling us where I'm trying to call it into and why, and it doesn't exist. It's telling us it doesn't exist there. So what we can do is go into the warrior skeleton and let's add it at the bottom. So create this hit function and call through a variable called damage. And this is an integer, or should be an integer. So here we can now say health minus equal damage. Now another thing we'll do is say if damage, or sorry, not damage, if health is less than or equal to 0, then what do we want to do? Well, maybe you guessed it, we want to play the death animation at this point, right? We want to now die. So what we can do here is we will travel to the death state, right? So if you recall, in the monster, we were making states, right? So here we can just copy this and just change this to death. All right. Now, if we play, we can go over here and I should be able to kill him eventually. And you saw that he plays the death animation and dies. Now there is some other things we want to add. So here, so we're not done actually. If you remember, we added this variable called just hit. And in here, what we'll do is say just hit is equal to true. Now, the reason we added this is so that way we can mitigate the amount of damage I take within a certain amount of time. So I don't want to just keep hitting my monster, my skeleton. I want to give it a bit of breathing time to actually do something back to us, right? Otherwise, it's kind of not fair and I can just keep hitting the monster and it's not fair, right? So what I'll do is I'll say if not just hit, then we'll do all this, okay? Now, another thing, of course, we need to do is start this timer. So we'll say get node, just hit, and start. All right, so now when I play, go into my game here, go up to the monster, we'll kill it, and eventually it'll die. All right, there we go. Now, one other thing we can do to make this a little cooler is add knockback. Now we're going to add knockback using a tween. So we're going to create a new variable called tween, and we'll say create tween. Now this allows us to create this new node or this new thing called a tween. Now tween actually used to be a real node inside of Godot. It used to be just like a timer, but they actually removed it, but you still can use it. So they changed its functionality a little bit, but it's still very usable and it's very powerful. So we'll call tween and say tween property, and we can now tween a specific property of anything, right? So now what we can do is we want to tween ourselves, the monster, and say global position. And then we're going to take the current global position and we're going to subtract the direction divided by, let's say, 1.5. And what this does is essentially add knockback. Now we'll also go at a speed of 0.2. Now, this literally will just take our global position, and the reason we're subtracting is because I want to go in the opposite direction of our player, right? And the player is in the direction, right? So we're going to go in the opposite direction of wherever our player is, and this essentially will emulate a knockback. Let's take a look at what this might look like. All right, there we go. There's our knockback. So it actually looks like he's being knocked back a little bit. Now, of course, if you want to increase this, you can adjust this accordingly, divide by a smaller number, do whatever you'd like. Of course, you can also change the timing. Be creative. Try the different numbers. Do whatever you'd like. Definitely try just different numbers in general. And that is it for this part. We have now created a hit effect from the player to the monster. So next time, we'll create a hit effect from the monster to the player, and we'll slowly go into some other things like global variables and stuff like that. So I'll see you all in the next part. All right, for this next part, we're going to start implementing the opposite, right? For the monster to hit the player. So we're going to essentially duplicate what we just did, but for this time for the monster. In fact, I would actually encourage you to pause this part and just do the rest on your own. So essentially what we're going to do is the exact same thing, but this time on the skeleton. So we're going to create an area 3D, a bone, a hit function inside of the player, etc. So I really encourage you to try this on your own first before continuing, as this will, help you learn and practice a little bit on your own in Godot without my help. So hopefully you try it on your own, and let's continue. So let's create an area 3D inside of our already existing hand slot. We'll create a collision shape 3D. And now we just need to give it a cylinder or capsule thing, and we'll make it a little smaller for obvious reasons. And now let's try, what we'll do is we'll actually go to our animation tree and play the idle. So that way, or in fact, actually, the start will be better for the T-pose. That way it'll be easier to just move this along the axis and figure out how long the sword should be. Okay, I'm gonna make it around this long and make it a little longer than the tip because this sword is kind of short. So I'm gonna make it slightly longer than it should be for the collision shape. All right, for the area 3D, we'll rename it to damage detector. Or I can't type today. I don't know. Good enough. All right. Let's now connect a signal for our body entered into our skeleton here. Now, what we can do is similar to this guy. We're going to copy paste this, and we can now realize that we can now do the opposite, where instead of the monster, we can check to see if it's in the player. And now what we can say is body.hit damage. And we do have a damage inside of the monster, so it's 2. And we can always change that now or later. And now, this is it. This should work. Well, obviously it shouldn't work because we don't have a hit function inside of our player. So let's head over to our player. Let's pop this out. And what we'll do actually is we'll copy paste this entire function here into our player. Now, this is the same. It depends on if you want a just hit for the player. I would actually encourage you to set it up on your own first. So let's head into Godot and do it ourselves. So hopefully you tried pausing and set up the just hit thing as well, similarly to the monster. So all we need in our player is to add a timer. And now what we need to do is rename it to just hit, and we'll connect a timeout signal. Now in our function here, let's go to our script. Let me open it up. Here we go. We will say just hit is equal to false. Okay. Now, no, this, yes, true equal to false. That's right. Okay. Now the health, we don't have that here, right? We don't have anything inside of our player. Now let's close our script real quick. And what we're going to do is we're going to create a global script. Now in our scripts folder, we'll right click, create folder, and global. We'll create a global script folder, and then we'll create a global script. So in here, I'll call it game. It's just kind of a habit of mine that I like to do. Now in here, I'll just create a variable called player help. This is an integer, and we'll set it to 10 by default. And now we'll head over to the project settings, go to auto load, click this little folder icon, and we will find our script, open it up, add, and there we go. That is it. That is our player script is now, or this script is now globalized. So now in our player script, we can head down to the hit function and just say game.player health. And there we go. That's it. Now, of course, here we'll have to do the same thing for the health. And for the change state, we don't have that. So what we'll do instead is say is dying is equal to true. And we will simply play back dot travel to the death node name. All right, and that's it. Of course, we can add knockback for a player as well. We don't need to change anything unless you would like to, but that is it. So we can test it, and let's test it out. Hit play. And now we should be able to go to the monster, allow it to chase us, hit us, and there we go. It can now hit us. And eventually, we should die. There we go. And that's it. Cool. We now have a fully functioning game. Like, things are working pretty nicely. Of course, there are some little tweaks here and there that you can add. So one suggestion, we're probably not going to do this in this series because it's more of a drag to do than anything. In the animation player, and this is something that is much easier in the 2D world, mostly because of this. So in here, let's say we were doing the two-handed attack chop. Is that the one we were doing? Let's see. Let's go to our attack. The slice. Okay. So let's disable this. Actually, I lied. We might as well do it because if I'm going to explain how to do it, we might as well just do it. Okay. So this is our animation, right? Now, what we can do is if I only want that Area 3D to detect or hit during a certain time, right? What I can do is I can enable it and disable it at a certain point. So here at the very bottom, well, we don't really need to go to the bottom actually. What we can do is go to the collision shape in our animation player. Now make sure animation player is still open. Now in here, in the animation tab, if this is not open, you can just click the animation tab and it'll pop up. And now we can see these keys. Now this will disable the area 3D in this case. And here we can now key this or unkey it to enable or disable it. So let's say at the very end, we want to disable it. And we can create a reset track. And let's say we want to enable it right around that frame. So right here, we'll enable it. And at the very bottom, if we scroll all the way down, we can now see that right there. Now, if we head to our reset right here, this is going to automatically disable the Area 3D by default. And now if I hit play, we can now see, maybe it's hard to see, but the monster's Area 3D should be disabled until it attacks. And now we're going to need to enable the animation tree. So let's enable that again. Let's hit play. All right, so now if we walk up to our monster, you can't see the area 3D until he attacks, and there we go. It's working much better where he's actually hitting us in the frame of that animation hit, right? And of course, you can do the same thing with the player. So I do encourage you to do that. Well, in our case, of course, we're doing a spin attack, so I kind of cheated a little bit in that sense. So he should always be hitting. But yeah, so that's pretty much it for this part. In the next part, I'm actually not 100% sure what we'll do yet, but you'll find out in just a second. All right, welcome everyone to this part. So in this next few parts, we're going to be starting to go into the whole GUI stuff, some game overlay, stuff like that. So before we start doing all that, I want to introduce you to custom themes. So we're going to be looking at a theme inside of Godot and how we can change all this stuff, the themes. Now, okay, so let's take a look inside of our assets. I'm going to create this theme inside of our assets. And what this will look like is if I create a new resource and I search up theme, we will find this little drop of paint and we can create this theme. Now I'll rename this to default, as this will essentially be our default theme. Now what do I mean by theme? Well, okay, let's take a look at, let me close all these scenes as I'm not going to need them right now. And let's open a new tab. We'll go to our 2D scene here. And I'm going to create something called a canvas layer. Now a canvas layer, for reference, is think of like when you're painting something. Kind of like a canvas, but there's multiple layers. So if we go to the layering, we can add something and we can add, let's say, a panel. And this will essentially show on top of everything. If I put the layer at, let's say, 2, it'll show up on top of anything that is layer 1, right? And by default, most things inside of Godot are layer 1, okay? Actually, no, I lied, it's layer 0. So layer 1 would be on top of that as well. So we can save this, and this will be our GUI. Or actually, we will save this and make this our game overlay, because we're going to do that first, as it's not too difficult and it's a good introduction to what we want to do. So we'll call this game overlay, and we can save this inside of a new folder called GUI, and we can hit OK, save, and here we go. Now, when I take my GUI and I drag this new scene in, and I hit play, we now see the panel. A little hard to see because it's kind of transparent, but the panel is there. All right. So now what we can do is back to our canvas layer. We'll rename this to game overlay. I'll just copy that into our main scene as well. This canvas layer is kind of a weird name. And now what we want to do is in our default .truss that we created, we want to start editing things in here. Now, if you remember, we also imported this amazing GUI stuff, right? Now what we can do is start using that. Now, on the right-hand side, we also see default font. And we should be able to just drag our font into that. And now we can see that our font has changed inside of this thing, this theme thing. Now this is kind of our default theme. Now, none of this works yet because we need to actually set the default to be the default, this theme. So in our project settings, we will go to filter settings, search up theme. We'll go to theme, custom, and of course you can see a custom font as well. This will override this font, but we can just load our theme because we already have a font in there, and we can save and restart. All right, once your system has restarted, we can now actually add a label to our scene here. I'm going to extend this big. I'm going to type in game over, maybe try again, and we can center it by clicking center on the vertical and horizontal right here. And there we go. That is our font. You can see that the font is now different than the default. And what's cooler about this is I can go to the theme override in this label specifically, go to font size, and make sure that the font size is a little bigger. So we can say, maybe I'll put in 40 for this. And there we go. That is my font size. Now you can see that it's a little blurry. So in our project settings, we're going to go to filter. We're going to go to texture. And here we're going to set this to nearest. All right. And now we can see it's properly pixelated. Okay, next in our default theme here, we're going to want to start adding some themes from my GUI, right? This guy. Now, okay, what do I want to add? Well, one of the things I want to add first is the panel. So in our manage items, we're going to manage the items and the things that I want to kind of set. So we're going to go to import items. I'm going to filter panel and find the panel. So here we go. I'm going to select these with data and import. I'm going to import selected. I'm going to also want to edit a button because I want my default button to look a little nicer. And here we go. It's on the top right here. We'll import selected. And lastly, we're going to create a progress bar. Here we go. Import selected. And there we go. Now, if we close this, we can now see these 3 new default themes on our right-hand side, and we can start editing them. So let's do the panel first. So in the panel, I'm going to reselect this and select a new style box texture. Now you can see that my texture is gone on my game overlay, but if I go into here, I can drag this in, and here we go. Now, obviously, this is not what I want for a panel, but what I can do is I can go into the sub-region, edit region, and I can select a specific panel, and I'm going to select this one. Here we go. I'll just select this and try to make it nice and equal. Now I'm going to move the dotted lines away from these lines right here. I want this essentially will take whatever is in the middle of it and use that as the middle of our panel itself. Now if we close, you can see we have this nice panel that is now our default panel. So any panel that I add in the future will always use this texture. Okay, so let's do our button now. Actually, we'll do our progress bar first, as that one's a little easier. Because for the progress bar, what we're going to do is we're actually not going to set a background. We're going to set this to empty. And the fill, we're going to set this to a texture. The texture, I'm going to drag in this new texture. Go to sub-region, edit region. I'm going to zoom out, and I'm going to select this guy right here. Try to do my best here to select it properly. Move that down, move that up. Oops, move that. I want to move the dotted line upwards. Whoops. A little hard sometimes, but do our best. And move the dotted line. Okay. There we go. There's the dotted line up. Move this back here. And move this dotted line over here like so. And there we go. All right. That is our progress bar. Now you can see here, this is our progress bar, and that is pretty decent. That's a fill that we'll want to use. Now the background, don't worry too much about that. We will figure that out together once we get to that point. All right, lastly, we'll take a look at the buttons for the styles. Now for the styles, we want to set each of these to a body texture or a texture box, but we'll start with one of them. So we'll do the normal first. We'll go into here, set the texture for this, go to sub-region, edit region, we'll zoom out, and these are going to be our buttons. Now this is the normal, this is the pressed, and this is, this is the pressed, and this is the highlighted. So for the normal, we'll select the normal one. All right, so here we go. We will now just drag this down a little bit. I'm going to put this right there, and I might actually just leave these. I think that might look better. So we can always take a look at the bottom left. That is where our button will be, right? So right here, that is where our button, or what our button will look like eventually. So you may want to just kind of edit these and take a look at that while editing them. All right, so I think this looks decent. So I'll leave the dotted line on the top and these two things kind of in the middle like that. And yeah, so let's close. Now, for the rest of these, what we can do is we can actually take this and drag it into the pressed, drag it into the hover, and we can click the dotted line or downwards line and make it unique. Why are we making it unique? Because if I start editing one of these without making it unique, it will change the rest of them. So it does inherit it. So we have to make sure we make it unique. All right, so this one is the pressed. So we're going to change it to the pressed right here. All right, this looks good. Try to make sure we get everything inside the box. There we go. That looks good. We'll close, and that is our pressed right there. Now our hover. And lastly, we can just select the hover. Here we go. Like so. And we will try to make it in the line as much as possible. There we go. And lastly, the focus and the disabled. Now for both of these, we can actually just drag in the hover, as that's kind of what happens when I focus something. When I focus something, that means I just clicked it or something. So we'll kind of focus it. Now for the disabled, we can actually maybe leave that empty. And that will look like this. It's up to you, really. There is no disabled texture in this one, so it's kind of up to you which one you want to use. There's only these three. You can either use this one where it's pressed, this one, or whatever you'd like. Of course, alternatively, you can use some sort of software to create your own disabled one. In fact, I would actually encourage that. What I would encourage is copy paste this one right here, the top button, and maybe gray it out a little bit. So just put like some sort of filter on top where it's a little gray. Right? Let's hit close, and there we go. We are done our custom themes. Now, what we can do is finish our game overlay here. So we can add a button, and now we can see that the button is using the default theme. So I'll make it a little smaller and say retry. And now we can see here that this button does not use the same font. That is why, realistically, we should, in our theme, set this font to the font that we just added. So this guy right here. And we'll save and restart one more time. All right. So that has set the default theme, but the theme of the button itself still has its own theme. So in the button, we can go to the fonts and set our font to that. And there we go. All right. That is it for this part. In the next part, we will actually make our game overlay work. So see you all in the next part. All right, welcome everyone to this part. In this part, we'll be continuing our game overlay. So let's get started right away. Now, the first thing I'll do is I'm going to rename this button here. And I'm going to start adding a script. I'm going to add a script to our game overlay. I'm going to make sure that I put it in our scripts folder. We'll head over to our scripts folder, and I'll create a new folder called GUI. Open and create. I'm going to delete all this code. However, I'm going to actually rewrite the ready function, and I'm going to say self.hide, as I want to hide this game overlay by default when the game starts, because, well, it's not game over yet, right? Okay, now we want to connect the retry button. So in our retry button, I'm going to go to the node section and connect a pressed button. Connect, and now we can do what we would do in a game over scenario. And what is that? Well, there's two things we want to do. The first thing I want to do is I want to get tree, say .pause is equal to false. So I'm going to unpause the scene, and then I'm going to say get tree dot reload current scene. And that's it. That actually restarts our game for us. And that's it. It's that simple. But there's one other thing we need in here that will allow us to use this overlay a little better, right? Which is a game over function that we're going to create. Going to return void. And what we're going to do in here is say input dot mouse mode is equal to input dot visible. Because now I want to be able to actually press the button, and I can't do that, obviously, if my mouse mode is captured, right? Next, I'll say self.show to be able to show this overlay as it's hidden by default, remember? All right, and lastly, we want to say get tree dot paused is equal to true. All right? Okay, so this will allow us to pause the game and etc. Right? So now what we can do in our level 1 is I can call this from anywhere. Specifically, I can call it from the player. So here, when the player is dead, right here, I want to eventually say that it's a game over, right? So what we can do is let's pop this out so it's a little easier to see. When I end the death animation, right? Which should be somewhere around here. Ooh, let's just find it. Okay, right here is where we die. And of course, here is where we could end the game. So why don't we do that? So in our script, let's drag and drop this game overlay and say game over. All right, and I'll change that to say get node. And I'll say get node, game overlay here, and game over. And now if I hit play, now if I die, eventually, I'll let him kill me. Eventually I should die. All right, there we go. There's our screen. All right, now, of course, we will implement this to actually be able to first play the death animation and then pop this up. But there's another issue, which is that I can't click anything, right? Nothing's working. And the reason is because we paused the scene. So in our process, in our game overlay, we want to go to the inspector tab and go to the process. In here, the mode is inherited. We want to change that to always. Okay? And that will allow this overlay or this canvas layer to process even when the game is paused. All right? So in the next part, we will implement the game over after the animation finishes from our player. All right, so in this part, we're going to create it or edit our code a little bit so that our player first plays the death animation and then the game overlay will pop up. And this is a pretty easy thing to do, as we can just head over to the node section in our animation tree and we can connect the animation finished to our player. This will allow us to figure out what animation we just played. And the cool part about this is that I can just play this in here. But obviously I don't want to play this if I'm playing the idle, right? That doesn't make sense. So I can check for a specific animation by asking it. I can say if anim name, or I can say if death in anim name, then we will play this overlay. So this will check to see if the death animation is inside, or the word death is inside the animation that we just played. So now that's it. Now let me actually change the health of my player to something a little lower. Where is that? Where is my health? I forget. Game. Okay, here it is. We'll set this to 2. All right, let's play. And let's see if we can die. All right, he's going to hit me. I die. And then the overlay comes up. Now, of course, if this is too fast for you, you're more than welcome to add a timer. So what we can do is in our code, we can say await, create, get free first, create timer, and we'll say 1 second, and then we will wait for the timeout signal, and then we will play the game over screen. So now, if I play it one more time, we can test this out, and we should be able to just die, and we'll wait 1 second, and then the overlay will come up. All right, and we can hit retry, and there we go. Everything works as it should. I can now restart my game and everything. Okay, now, in the next part, we're going to start looking into our inventory system finally, as that's a big portion of our course, and it's going to take a good amount of time, but it'll be fun, and we're going to try to implement our inventory system together. So I'll see you all in the next few parts. All right, welcome everyone to this next few parts. In these few parts, we're going to start our inventory and hopefully complete it. This might take a while, and it might take a bit of explanation and examples, but we'll get through it as much as we can, with hopefully as many explanations as we can. So let's get started. I'm going to close my player for now. I'm going to close the game overlay, and I'm going to create a new scene here called, it's going to be a canvas layer base, and we're going to call this our GUI. Any sort of GUI that goes in here or will go in here, for example, our HP bar, stuff like that. So let's put this in our scenes, in our GUI, of course, and save. And I will find my GUI and just pop it in here to the main scene. There it is. All right, next, what we want to do is we want to actually create our inventory, as the inventory is not going to be in the GUI, it's going to be its own scene. So we're going to create a new node called control node as the base. And we're going to call this inventory, like so. And now we'll minimize this inventory like that. And in this inventory, we're going to have a few things, but it's not that much. Now, the reason why we're not going to have that much partly is because this scene is going to be custom made. So let's save this first. Let's save it in here, but we'll make a new inventory folder for it. So we'll call this inventory. Yeah, we'll just call it inventory. And we're going to need a few things. Now, okay, the setup for this might actually take a bit. So in our scripts, we're going to create a new folder called inventory. And in the inventory here, we'll call this inventory main, as this is kind of where the main inventory will go. It kind of sets it up, and we'll have another function or helper function kind of later that adds an item to our scene. So let's create this and add this into our scripts folder. Here we go. Okay, so now we have our first folder, and or our first script here. I'm gonna close all my other scripts so I can organize a little better. And I'm gonna create a few new scripts. So the first script we're gonna create is called item data. Now this one is going to be for our resource, which we'll explain in just a second. We're gonna have a new script called inventory item. This will be the actual item that goes inside of a slot. Now, of course, you may have realized at this point is we'll need an actual slot. Okay, so these are the three scripts that we'll have. Now, let's kind of try to explain each one, just a general gist of it. Now, the inventory, the item data, this will represent the resource or the actual data or the information of an item. And we're going to use resources to do this. Okay, now let's open each of these scripts to make sure we have them all here. And I'm going to pop actually, I'm not going to pop them out just yet because there's one more thing we need to do still, is create the resources. So in our inventory, we're going to create a new folder called item resources. And we're going to create a new resource here. And it'll be a base resource. And we'll call this default sword. I'll put it default sword like that. And this will be our default item that we'll equip. But for now, let's actually double click this. And if we go to the inspector tab, you can see that there's nothing here, except the name. The name here, default sword.tr. Yes is there, but there's nothing else. Now, the cool part about this is that we can attach a script to it. And eventually we can actually create our own, not node, but our own resource. What do I mean by this? Well, what I mean by this is if we head into our script here, we can pop this out, and we're going to delete everything, including the extend node. Now, the reason is because we're going to create a new class name called item data, and this is going to extend resource. All right. Now what we can do is export something. We can export, for example, the item name as a string. So let's save this and take a look at what we have. Now, if I go to my resources and double click it, we can now see the item name allows us to put in something. Now I can rename this to default sword, or not rename it, but add that name, default sword. So that's pretty cool. Now we're going to add a bunch of new things in here, stats and types and stuff like that. But let's take a look at what else we have. So we also have the inventory slot. This will represent the actual slot that goes into our inventory. We also have the inventory item, and this will represent the visual of the actual item that goes into our inventory. All right, now inventory main, of course, is going to control everything. Now I want to show you kind of how we're going to do this first with an example, and then we'll go into each of these to actually code them all. Okay, so feel free to just watch along. You don't have to code any of this. All of this is just an example. So, okay, we're going to essentially create a new node through code. That is what we're going to do. We're going to create a new node through code instead of adding it manually. So far throughout this entire course, we have added a node by going to our scene, adding a child, and let's say we want to add a label, right? And I can type it in, I can type some stuff, move it around. This is a way we add a node. But what if I want to add a node through code? Well, it's not impossible. In fact, it's relatively easy. What we can do is create a new variable called label. We'll say it's equal to capital L label. And we can see here is adding me or asking me to put the label. And I can say dot new. This will create a new object called label. Now to add it to our scene, all I need to do is say add child label. And I will add that label I just added. Now, what we can do is we can edit the label in between. So we can say label.text is equal to hi. This is a custom label. We can also edit the position. So we can say dot position is equal to vector2. Let's say 100 by 100. And now if I hit play, we can now see my new label, even though in this inventory there is no label. But if I go to my remote, I will find this new label that I just created. And it even has this text. And of course, if I wanted to, actually, let's find the position. You can now see the position is exactly 100 and 100. That is because I changed it through code. So we're going to use a similar concept inside of each of these scripts. So the slot and the item. Now, we're going to use a similar concept, but instead of creating it as that, what we'll do is it's going to extend its own thing. So it's going to extend something, and we're going to kind of create a new class using it. So, okay, now let's take a look at classes, because classes kind of extend this idea of creating a custom-made node. So we just created a node, but this is not a custom node. This is a node that already exists inside of Godot. So what if I want to create a new node that does not exist? Well, it's not actually that hard, right? And this might sound weird. It's like, oh, I'm making a new node. That's crazy. That's like some complex thing. But no, what we're going to do is let's take a look at the inventory slot first. So in the inventory slot, what we can do is let's delete everything. And I'm going to say class name. Now, we already did this in the item data, but we're going to do it again here to kind of prove my point here. And I'm going to call this inventory slot. And this is going to extend the panel container. Okay. Now, this has created our new node called inventory slot. It's a new node, but it extends the properties of a panel container. Now, what I can do is if I go to my 2D scene, and I take a look at the new nodes that I can add, you can actually search up inventory slot, and you can see it's a child of the panel container. We have just created our own custom node. And the cool part about this is that if I add this, it has all the things of a panel container. So if I add a panel container, it has the exact same properties. It doesn't even look any different, right? The only difference is the name and, of course, the script, right? So that is very cool. We have created our own custom node. Now, similarly, again, we can create a function, a ready function, and we can say variable slot equal to inventory slot dot new, and this just created our new item or our new node. And you can see here it's highlighted in a light green. And now I can say add child slot. And if I hit play on the current scene, you can now see in my remote this new panel container. So that is the basic crux of what we're going to be doing. I'm going to stop the recording here as we're going to now go back into the item data. So let's go into the item data for the next part. All right, so let's continue this part for the item data. Now, for the resources, what we want to do is we want to add some things and stats, basically, that allow us to create an item with this, right? So, okay, the first few things that we'll need, and of course, you may add or not add some of these, but there are some that we'll need that will work with our functionality of these slots and stuff. The first one is going to be the type. So I'm going to call this type, and I'm going to make it a dictionary, kind of. Not a dictionary, but in the brackets, we'll put weapon, and I'll put misc and main. This will have essentially 3 main types of things in our inventory. Now, I would encourage you to create more, obviously, like if you have armor or head, those kind of things, that's what would go in here. Now, what we're going to do here is we're going to export the type and say type, because this refers to this, and we're going to export the type. So here we want to say variable type, that's why. And lastly, what we'll do is we're going to, actually going to pop this out so it's a little easier to see. Let's copy paste this a few times. So let's copy paste it. And this one, I'm going to change to item damage. It's going to be an int. This one is going to be an int as well. And this one's also going to be an int, but this is going to be defense. And this one is going to be item.health. This one will be specifically for the potions. So when we give potions or heal, basically, so you can kind of rename this to heal if you want, or item heal, I don't know. It's kind of up to you. I'm just going to say item health, so meaning how much health does it give us, right? Okay, now the next two are going to be, it's going to be a Boolean, whether it's stackable or not, right? So potions are going to be stackable for us. Now, if it is stackable, we're going to need something called a count. So this is going to be an int, and this is going to be called count. This will keep track of how many items we have, right? How many of these things we have. Next, we're going to export a multi-line. So export multi-line, and this, you'll kind of see what it is in a second, but it's going to be the description, and this is going to be a string. Now, lastly, the kind of important part is the variable item texture. And this is going to be a texture 2D. So let's save this, and we can close the script, and we can head over to our resources. Now we see a bunch of new things. Now what we can do is start putting in some of the items, right? So for example, the texture, I'm going to put in just a regular sword. Now what I can also do is I can take my default sword, duplicate it, and say, let's say, what other kind of sword do we want? Long sword, let's say. I can create one more. I'll duplicate this. And I'm going to create a potion. We can say small potion. Potion. There we go. Small potion. And for this guy, I'm going to double click it. We can see here the name of the resource. So I'll rename it to small potion. And the type, I'm going to change this to a miscellaneous item. This is a stackable item, and we'll start the count at 1. Now for the rest of these, I'm going to keep them at 0, except for the health, I'll put 5. And for the item texture, of course, we're going to need to find a small potion. So here we go. And lastly, we can change the longsword to long sword. This is a weapon. The item damage we can change to 5. The default sword, I'll change it to 2, as that's the default amount of damage I'll do. And okay, for the long sword, we'll put a description and say this is a long sword. Copy this. We'll go to the default sword and just say this is a default sword. Now the default sword actually won't show in our inventory, but we do need this, and you'll kind of see why later. Okay, so one last thing we can do is we can create. Actually, no, that's it for me. Those are all the items I'm gonna create. You may, pause the video or continue the video and create your own weapons and stuff. So if you would like, I do actually encourage you to make a different type at the same time. So maybe add I would say head item. I don't know if this asset pack has that. It does have a shield, so maybe you can add a shield type, right? So there are heads, so you can add heads, boots. There's also the armor plate, whatever that's called, etc. There's even miscellaneous items like these that are a little different. But yeah, so okay, we will continue, but I do encourage you to be creative and add some of your own things. This is a really good way to learn, is just kind of branching off of what I'm doing into your own thing as well. Okay, so the next part we'll go into the slots, and then eventually we'll go into the item. And hopefully with both of these, the game will start to work. So we'll actually have an inventory system. All right, so I'll see you all in the next part. All right, in this part, we're going to continue our inventory slot. So in our inventory slot, we're going to need a few things. I'll try to explain it the best I can. But and I'll try to go as slow as I can. So the first thing we're going to do is we're going to export the type item data dot type. There we go. Now the reason we're exporting this, even though we're actually going to set the type when we create the slot, is specifically for creating this dynamically in the sense of equipping it. Because we want to be able to have some sort of equipment system where I can drag it into from one slot in my main inventory into my equipment system, right? And this will allow it to be somewhat dynamic, and that is what this will be. So let's continue on here. We need an initialize function. So in it, this will initialize this node. So whenever we create it, this function or this stuff that's in here will be called. So here I'm going to say T is item data dot type. So T is the type, and then we're going to have CMS, which is going to be the size. I always make that mistake. I always put this instead of the colon. So make sure that we put a colon here, and this is going to be the vector2 of just vector2 like this of the size of the panel container. And I'll show you why we need this in just a second. So first, we'll just actually finish this. So we're going to set this function to be void, and then we're going to set the type equal to T. So as you recall, like I just said, even though we're going to actually set the type equal to T in the initialize function, we're going to actually still export it, and you'll see why later. Now, we're going to get the custom minimum size equal to CMS. Now, what is this? Why are we doing this? Well, let's close this and go into Godot here. I'm going to add a grid container here, and this will actually be my container for my slots. So I'll actually keep this, and I'm going to rename this to grid. And I want you to add, or you can just watch me do it. I'm going to add a panel or a panel container in this case, because that's what I'm using. And the panel container is gone. Now, if I drag this out, you can see here I can go to layout, transform, and give it a size, say 50 by 50, or by 50, and it's there. But if I drag this into my grid, it's gone. Why? Because in Godot, the control nodes, if it's in some sort of panel or thing is inside of a container, now grid is a container, then it's going to only go down to the custom minimum size. So if I set the custom minimum size to 50 by 50, then we will have an actual panel. Now I can take my panel container and duplicate it, and you can now see I have several inventory slots essentially. So that is what we're going to do in code in our inventory slot. So let's pop this back out, and that's what we're going to do here. Whenever we initialize this panel, that's what we're going to do. Okay, next up, we're going to need a function called canDropData. Now for now, I'm going to pass, but this is essentially a return Boolean. You can see here that's going to return some sort of Boolean, and it's going to tell us whether or not we can drop something on a certain position with a specific type of data. You can kind of imagine what that data will be, but I'll tell you it's going to be this data, right? The item data. So let's take a look at what other functions we'll need though. One other function we'll need is kind of a follow-up. If I can drop something, then well, I should probably drop it. So this is a function that is going to return void, but it's going to kind of follow up on this one to see if, hey, if I can drop something, then I should probably drop it, right? So there's going to be some functionality in there that we need to add to see if we can add something. Now, the last thing we'll do that we're actually not going to finish in this part, but we will need it, is a GUI input. Now, this, I'll explain in just a second as well, I'll give an example, is essentially going to be for equipment. So this will detect if I click on something, if I'm moving something, if I'm trying to equip a specific item, or if I'm trying to use an item like a potion, those kind of things. So that's what we're going to put in here. But for now, I want to explain what this does inside of control node specifically. So inside of Godot, let's create a new node here, container, or controller, and a control node. And I want to show you this control node, any control node inside of Godot, anything that is a child of a control node inherits the control nodes, right? It inherits everything, the properties, the signals, etc. Now in the control node, I want you to make sure, take a look at my screen here. The control node, I'm going to cover half the screen. Okay. Now what we're going to do is in my node section, I'm going to go to GUI input and connect this to my inventory. And this is a signal that will look for a GUI input. Now what I'll do is I'm going to print event if there is GUI input. Now I'd rather show you than explain it. So let me show you first. I'm going to hit play. And if I move my mouse around here on the left side, nothing's printing. You can see nothing's there. But if I move my mouse over here, things are starting to print. Now why? The basic idea is that the control nodes, or any sort of node that has this area that you see, will pick up input. It will pick up GUI input specifically. So any node, any control node specifically, will inherit this functionality, including the panel controller or the panel container that we created as the slot. So I'm going to disconnect this, and I'm actually going to just delete this node and, of course, delete this code here because I don't need that. All right, back to my inventory slot. So now we understand what this is for. This will essentially check for input in my specific container, the specific slot. All right. Okay, now let's take a look at the can drop data because we want to be able to figure out if I can drop things or not. So the first thing we can do is check to see if the data that I'm dropping, which is right here, if the data is inventory slot, or sorry, inventory item, which we don't have yet, then that means we can drop it. Now, this inventory item is going to be a class in the inventory item here. So let's just do that real quick right here. So we'll say class name, inventory item, and this will extend texture, 2D. All right, so this will represent our actual visual, or sorry, this is actually going to be rectangle. This will, but it's still going to represent our actual visual of the item, okay? So if it is an item, right, if the data that we're dropping is an item, then we can also check to see if the type is equal to item data dot type dot main. Now the reason we're doing this is to essentially check to see if we're dropping it inside, or if we're trying to drop it inside of the main inventory, right? Now, if we are, then another case that we need to check for is if the child count is equal to 0. Now, if it is equal to 0, that means I can drop it. I want you to guess why. Well, I can drop it if the child is 0. Well, actually, you might not be able to guess why because we haven't really gotten to this part yet. But what we'll be doing is we're going to be adding children, specifically the item inventory, as a child of the item slot. So if the child count is 0, that means there is no item in the slot. If there is an item, or if there is a child count, if the child count is greater than 0, essentially, we'll say else. And what we want to do is we want to technically return the getChild 0 dot data dot type is equal to the data dot type, data dot data dot type, because this data is going to be referencing the actual data in here. Okay, so here we go. Now this is a condition, right? So this will actually return true or false based on if the type that I'm trying to drop is the same type as my slot data, okay? Because that's what we're trying to do, right? We're trying to find out if I'm trying to drop something in the main slot, or if I'm trying to return it or drop something in a equipment slot. So this will create it as a more dynamic inventory slot, right? Because it's not just an inventory slot, it's also an equipment slot. Now, one other thing we want to check for is if the type is equal to data dot get parent dot type. Now, if it is, then we can return true. And lastly, you can see the error here. Not all code paths return a value, so we need to make sure that all these if statements return something. So in this one, we have an else return here. In this one, we need an else statement. So here we can say else return data dot type is equal to type. So if the type of this slot is the same as the type that I'm trying to put in, then I can still return that, right? So if it's the same, then I can return true. If it's not, then I'll return false, right? So if I'm trying to drop a item type that is let's say a misc into a type that is a head, right? I don't want to be able to drop a potion into my head. That doesn't make sense, right? So, okay, so that's that. Now the last else statement, if the data is not inventory item, then we can just return false. Okay. All right, so that's it for that. Now, of course, for this one, do keep in mind you can also just do this, but it's really up to you. So here we can just say else and return false. All right, now if I actually do drop data, this one's a little easier because now I can just check to see if the child count is greater than 0. Now, if you remember, if the child count is greater than 0, that means there is an item in it. Now, let's take a look at what we do if there is no item, because that's a little easier. Because if there is no item, all I have to do is say data.reparent self. This will essentially take the item that I have in my hand and reparent it to whatever item I'm trying, or whatever slot I'm trying to drop it in. So it will take the, let me see if I can get a visual here. If this is my inventory slot, and I have this inventory slot with a potion in it, this is my amazing potion, and I'm trying to drag it in here, and this is empty, I'm taking this potion and essentially reparenting it to this slot. All right. So next, what we can do, though, if the child count is greater than 0, well, you can imagine we need to take the slot or the item in here and put it into here. Right? And we're going to use a reparent function as well for that, but we need to get access to that item first. So we can say variable item is equal to get child 0. So that gets access to the item that is in the position, right? In the actual slot, in this slot that I'm trying to drop it in. Okay. Next, we'll say if the item is equal to data, then we'll just return. Because this essentially tells us that the data is the same. So if the item and the data I'm dropping are the same, then I don't need to do anything. Because if this is a potion and this is a potion, then I don't need to do anything. It kind of looks as if I've reparented it, but I just return, right? I don't have to do anything. But otherwise, if they are different, then what we can say is item.reparent data.getParent. .getParent, there we go. And that's it. That is our drop data. All right. Now, one other thing we'll need also that I forgot is a physics process function. But for now, we'll also pass. This will be for checking equipment. This will tell us, it kind of allow us to check the equipment in our slot a little later. So we'll actually implement this a little later in the video. All right, so that's it for the item slot. In the next part, we'll continue our item or inventory item and see if we can get this working as well. All right, I'll see you all in the next part. All right, so in this part, we'll continue the inventory item. So in here, we're going to need a few things. The first thing is exporting the variable data. Now things hopefully make a bit more sense as we've been using and referencing data all over here, but we haven't actually had a variable called data until now. So here we go. All right, now what else do we need? We will need a ready function. For now, we'll pass. And then we'll also need a initialize function as well. So this makes sure actually the init function is not these underscore here. Now, if it's underscore, this kind of, I'll write it out, but what happens is when you create a function, or when you create a label, let's say we created the inventory item in here, right? And say .new, I would need to pass something through the new whenever I do that here, right? Whereas the way we're going to do it is we're going to say init, and then item data, and then, this is going to return void, and then we're just going to say data equal to d, so it's very easy. But now what we're going to do is instead of saying this, we're going to say, we would say variable item, and then we can say item dot init, and then put the data inside of it like that, right? So this is just the way we're going to do it. Feel free if you want to do it this way with the underscore there. You're more than welcome to, but this is just the way I'm used to it. It kind of feels more organized to me as I can see what's happening line by line. You can find out the initialize function is being called, right? Whereas here, if I initialize something like this, we just don't really know that that's what's being initialized, right? It's kind of hard to see. Okay, so that's the difference if you were wondering. So now let's continue. Now there's another function a few more functions we're going to need that are actually built in again. So the first one is going to be get drag data. We can help that finish that. And we're going to return self for now. But there is one other thing we're going to do in there. Next, we're going to say make drag preview. This is going to be our own custom function. That's going to be at position vector2, and it's going to return control. Now this is going to be a function where we basically make the image of me dragging the image, right? So when I'm dragging something, I want an image to show on top of my mouse. So that's what we're going to do in here, right? Now inside of the get drag data, this is where I want to call this function. So I'm actually going to call this function and just say at position. But we don't want to just say at position, make drag data. We also want to set the drag preview, which is another built-in function, to the data I put. So we're going to make the data inside of here and then set the drag preview. Because this doesn't do everything for us, we need to actually, give it something to preview. Okay, in here, for now, what we'll do is we can actually say, because we're trying to return a control, we're going to say C for control is equal to control.new. And then we're going to say C.add child T. And we don't know what T is yet, but we'll get to that. And we'll return C. Okay, now in the preview data, we also want a texture rectangle to represent the image. Okay, so the control node will be the parent almost, and we're going to have a child inside the control, which is going to be the actual texture. So this is what we're going to see when I'm dragging my mouse. So inside of this example, when I'm dragging my mouse this way, we'll have an image that is on top of my mouse, right? So you'll kind of see what we mean when I put it out. So let's create the T, right? The texture, and we'll say variable T is equal to texture rect.new. And now we want to edit a bunch of things. The first thing we want to change is the texture of it. Right? This is probably the most important one because I want to set it equal to the self.texture. So texture or self.texture, this is the texture or the data inside of here. Now we're going to have to set the texture of the self in the ready, which we'll do in a minute. But let's just complete this since we've already started it. Next, we can say t.expandMode is equal to texture rectangle, not expand fit. We're going to say expand ignore size. There we go. Next, we're going to say t.stretchMode is equal to texture rectangle, and we're going to keep the aspect centered. This will keep the texture centered on our mouse. All right, next, we're going to probably give it a custom minimum size, because as you remember, things can get very weird if I don't give them customized minimum size. And we will say it's equal to self.size. All right, next, what we can do is a cool little effect. We're going to modulate the .a to 0.5. Now I'll show you what this is in just 1 second. But lastly, we also want to say t.position is equal to vector2 minus at position. All right, so we're passing through that function right there, and we're just going to subtract it. Okay, so that's this function. Now, what is this modulate? Well, inside of Godot, let's go to GUI here. Actually, we'll have to actually add something. Let's add a button for now. And here you can see this button is colored, right? Now, when I go to the visibility, I go to modulate, and I take my A and I bring it down, it's becoming invisible. So that's what we're going to do. We're going to set it to about in the middle and make it slightly invisible. And this will give it a cool effect that shows that I'm kind of dragging something essentially. All right. All right, so next up in our ready function, we need to actually set, the things like the texture and stuff. But first, before we do that, we want to check to see if data is valid. Because if data is not valid, or if data doesn't exist, we don't want to do anything, right? So what we can say is expand mode. In fact, actually, we're just going to copy these 2 lines right here because we're actually doing the same thing, except we're going to remove the T, and we're just going to say stretch mode is equal to this. Next, we will say texture is equal to data.item texture. Because if you remember from our item data, this is where we put the item texture. Okay? Now, what we can say is tooltip.text or tooltip text is equal to string. We're going to say %s, new line, percent, where's percent? Here we go, %s. I'm just going to copy this so it's a little easier for me to find. And then new line. And then stats is equal to %s damage, %s defense, and we can also say %s health. So now we're going to fill in all the numbers here to show that I have a bunch of these things. How do I do this? Right next to it, we will say %, and then an array filled with the stats or the actual numbers of these things. So we can fill it in by saying item.item name. The first one we'll put is the item name, and we'll put the item description. Where's that? Ooh, item, oh no, just description, I believe. There we go. And then data, item damage, and then data, item defense, and then finally data, item health. So it's all in the same order as these, right? So we show the damage, we show the defense, the health, and the first two, I'll show the name and the description. Okay? So here, of course, you could just put name if you'd like as well. And then I don't know if I'd put a description like this, but because usually you put the actual description instead of just showing the description. So that's what we're going to do. All right. Next, we're going to go to the next line here, and we're going to check to see if this item is stackable. Now, if it is stackable, then we're going to need to put numbers on this item, right? Because if it's not stackable, usually you don't have a number 1 right next to it. Usually you would have it only if the item is stackable. So if it is stackable, I will say variable label is equal to label.new, new. And if you remember from our example, we're going to essentially just create a label, and we're going to add a child label. Now, this label we want to adjust though, right? So we want to say label.text, and we want to fill this text with what? Well, we want to fill it with the data.count. And I'm going to convert it to a string because the count is a number, and I can't just fill in a string with a number. So I need to make sure I convert it to a string. Now, lastly, I'm going to change the position of the label because otherwise it will kind of show in a weird position. And the position I found to work, which I'll say is equal to vector2, is 24 by 16. But this is assuming that our slot inventory, our slot is 32 by 32. So this you might want to adjust depending on the size that you make your slots. So, kind of adjust that accordingly. Okay, this is our inventory item done. It's nothing too complicated. It's essentially just showing data and moving around information to make sure that we have access to everything. Okay, so in the next part, we will continue our inventory main to actually make things work, because right now, if I just hit play, nothing shows, nothing's happening because I haven't created any items, I haven't created any slots. So I want to start doing that, which we'll do in the next part. All right, let's continue our inventory system here and create the actual slots. So creating slots, as you might have realized, is not too difficult because all we need to do is create a ready function. Let's actually pop this code out so it's a little easy. Keep forgetting, it's really hard to do this going in and out, but I'll do my best. So the first thing we want to do is for I in range, let's say 24 for now. And then we can say variable slot is equal to inventory slot.new. And I want you to actually pause the video and see if you can figure this part out on your own, because this is something we kind of already showed you, right? Or I showed you, but I want you to try it on your own. So, okay, let's continue, and hopefully you pause and unpause. We're going to get node grid and add child to the grid, right? But we're not done, because if you remember, in the slot, we have an initialize function. So we need to pass through the type and the size. So let's do that. Let's say slot.init, and the type we can say is item data dot type oh my gosh, dot main. Main is going to represent the main inventory slots. Now the size is going to be 32 by 32, And that's it. So we are now able to load our slots. Let's take a look. All right, there we go. Now the last thing we're going to do is we're going to go to the columns, and I'm going to put in 6. So it's going to be a 6x4 inventory. All right, there we go. There's our inventory slots. All right, so in the next part, we're going to actually fill in our slots with items now. This part is going to get a little more fun, and we might even run into a few bugs. All right, in this part, we're going to continue our slot making. So the first thing we need to do is we need to load our inventory, right? So we need to load the items. So let's create a variable called items to load. And we'll make this an array full of the resources that we made. So we can just search up, let's see, long. Okay, let's try again. Okay, we might have to just drag it in. No problem. We'll close this, open our script, and we'll find our resources. So we can just find this, drop it in, comma, go next, and we'll put the potion as well. All right, there we go. All right, so here are 2 items. Now what we can do is we can create a for loop and create these items. Now, to do that, we'll say for I in items to load dot size. Then we can say variable item is equal to inventory item dot new. Okay, so we want to create the item, and then we need to initialize it. So we say item dot init, and the item we want to initialize with the data, right? So the data is going to be the item to load at position I. Next, we'll just add it. So now that we've initialized it, we just want to add file item. But that's not where we want to add it. We want to add it to the grid. But I want to get node. So instead of just getting node and copy pasting, I'm going to create another unready variable called grid and just make it equal to get node grid. And now I can just change this to grid and then add child here. All right. But this doesn't exactly work because that's not exactly what I want to do, right? I don't want to just add the child to the grid. I need to add the child I. So I will need to get child I and then add the child there. Because what I want to do is I want to get the first slot and add the child there, the second slot and then add the child there. But yeah, now let's just give it a try. And all right, so we got our first problem already. Okay, so the problem is that here we didn't load them. So we have 2 options. Either in here, we can preload the item, or in here, I can load the item like so. And now I should be able to hit play. All right, here we go. There's our items. We even have the label and the items. Now let's see if we can drag and drop. Okay, cool. We can drag and drop. And we can even replace items. And that's good. All right, so we have a good, decent working inventory system. You can see that it is centered on the thing, remember? We actually centered it throughout the inventory code. And yeah, here we go. So this is some cool stuff. We have an inventory system that's working. Now, one thing that we want to do is in our inventory here, we will add a new inventory slot. And this slot, the default is weapon, which is good. So I'll keep the default as the slot, and I will move this to be our slot. Now, what we'll do is I want to basically create a equipment system, right? So this will be our right hand, and I can now duplicate this. I'll turn on the grid, put the right hand here. This will be the left hand. And now I can just duplicate these and just put them kind of where a inventory slot would look like, right? So this one would be the right hand. This would be the left hand. So this is right hand. This would be the body. This would be the head. And this would be the legs. And finally, the feet. All right, so now if I hit play, technically all of these are weapon types. But if I hit play, I should now be able to drag it in to this. And I should technically actually be able to drag in all of these, but not this, because this is a misc item. Right? If I hover it, we can even see the name and the description, which this one doesn't have, but this one has a description called "This is a longsword." And of course, if we go into the item here, and make sure that the new line doesn't start with a space there. And so now we try again. It doesn't look all weird. Now, of course, the small potion, we can add a description. Let's say this is a small potion that gives health. Now, if we hit play one more time, we can hover it, and now we see we have a description. Okay, cool. This is a pretty good system. This is a pretty cool inventory system. We're not completely done. What we'll do is now we can add, or what were we going to do? We want to add functionality to our things, right? We want to be able to equip a weapon, right? And we also want to be able to use this potion, right? I want to be able to click it and use it, right? Whether it's left click or right click, whatever we want. Okay, now what we can do is head over to the, we'll actually pop this out, and we'll do that in the next part. So what we'll do though is we'll be doing it in here in the inventory slot. All right, so I'll see you all in the next part to do this. All right, so first what we're going to do is we're going to take a look at the physics process to check if something is equipped or not. This is not too difficult because you can actually guess already. All we need to do is check to see if the child count is greater than 0. Now, if the child count is greater than 0, that means there is an item inside of this slot. Now, what we can do is first, we want to actually check to see the type. If the type of our self, right, if the type that we're looking at, right, is so equal item data dot type dot weapon, then we're looking at an equipment item, right? This is a slot, right? One of these. That means we're looking at one of these, right? Now, here's something important to note is that this will only work if I only have one of these as a specific type. So it has to be unique, essentially, is what I'm saying. So in our case, this won't work. So what we're going to do is we're going to head over to the item data, and we're going to add a few new things here. We will add a weapon. We have a head. We have a body. We have feet, or we have legs first, and then we have feet. All right. Now what we'll do is we'll head over to our left hand, and we're going to delete this. And let's head over back to our script. Let's see what is happening here. Okay, this needs a thing here. There we go. Okay, now what we can do is save, and in each of these, we will make sure that it is selected properly, and we might actually have to restart the engine. So let's do that real quick and restart the engine. All right, so we restarted the engine, and we have a quick little problem here. So the problem is actually right here, so we'll pass. But if we head over to our types now, we should now be able to see all our new things. So let's make sure that we set each of these to its own respective thing. So this head, these are the legs, and finally feet. All right, so now everything is unique. So now let's head back to our script and complete this part. So now if this type is an item weapon, or honestly, you might want to change this to right hand. That might make more sense because now you can't have another left-handed weapon. So you might want to change it to right hand, just as we did in our game. If you recall, we're going to have, let's actually head over to our game and see if I actually made this. No, we didn't. So we're going to want to make a variable called right hand equipped. And this is going to be an item data. Not equal to item data, it's going to be item data, right? So it's going to be a resource that we equip. Now, inside of our slot here, we will say right-handed equipped is equal to the item.data, just data. Otherwise, we'll say else. Now, let's just do the else first, actually. Now, otherwise, we will say right hand is equal to load default sword. Right? So this is where it comes into play, where I have my default sword being set into the right hand. All right, now the question is, what is this item? Well, we need to actually create the item, so we need to say variable item. But we don't create it, we just get access to it by saying get child 0. Okay? So now we can get access to the child as an item here, and there we go. All right, so this is our equipment. Now if I close this and test it out, this should actually work. If I put this in, and I go to my remote, and go to my game, you now see I have the longsword equipped. But if I unequip this, it should return to the default sword. But I shouldn't be able to put this into any of these slots anymore because these are different types now. All right? All right, very cool. Now what we can do is head into our script here, and I do encourage you to create elif statements for the other types, right? Because you're going to want to create other types of equipments and load them into the perspective data, right? So you might want to use a match function that might actually work a little better, but of course, I'll kind of allow you to do whatever you'd like. Yeah, so now let's work on the GUI and put together though. So the first thing we want to check for is if the event is an input event mouse button. There we go. Now, if it's a mouse button, then when I'm clicking, then I want to check for what kind of click it is, because there's a lot of types of clicks, right? I can left click, right click, middle click, I can press down, press up. There's all these different things, and we're going to check for that. So we're going to say if event dot button index is equal to 1. Now this will refer to the left or right, right? So which am I clicking, left or right? This is going to be left click. So we're going to also check for press down or press up. So we're going to say if event dot button mask is 1, is equal to 1, then that means I am pressing down. Now if all this happens, then I am essentially left clicking and I'm pressing down, right? Now I can now check for if getChildCount is greater than 0, then that means there is an item in this slot. If there is an item for this in this slot, what else do I need to check? I need to check if it's a misc item. If it's a misc item, I want to use said item. In our case, we only have one type of misc, which is a potion or a health potion. So what we'll do first is check to see if it's a misc, and we can do that by saying if getChild 0 dot data 0 dot data dot type is equal to item data dot type dot misc. There we go. Now, if it is, what we'll do is we'll use it. Now, how do we use it? Well, the actual using is not that hard, right? The healing a player and stuff like that is not that difficult. But what we want to do is I want to actually go into my game function here, and we're going to create a new function called heal player. Now, you'll kind of see why a little way later, why we'll do this, but we're going to create a function here called heal player, and we'll pass through an amount, and we're going to just say player health plus equals amount, and that's it. So this is a function that will just say player health plus equal amount. So in our slot, it is the equivalent of doing this. Well, in our amount, we would actually want to pass through the data of the health, right? So in this case, we will say getChild 0 dot data dot item health, right? But in our case, what we want to do is we actually want to call the function instead. So we'll say game dot heal player. We'll say dot heal player and pass through the amount, which is the health of the item. Okay, now what we want to do is we want to check if the health is greater than or equal to max. So I don't want to overheal. Now I could do that here. I could say if game dot player health is greater than the player max, which we don't actually have. So we'll say player health max. Then I can set the player health to 0 or to the max. Right? So I would do this realistically. But this is why we have a function. We can now just put this in here. So we can just say if the health is greater than the max health, which I don't have, so I'll create that right here, and I'll say it's equal to 2 in this case. Then I will just set the player health equal to max health. This avoids overhealing. Okay. Now back to our slot here. What else do we want to do? Well, I want to use up an item because our potion is stackable, right? Now, of course, you can check to see if the item is stackable first, which I would actually recommend. But in our case, where all our misc items are going to be stackable and have a count, I know this because I've done it this way. So I'm just going to say get child 0 dot data dot count minus equals 1. But now there's another problem. There's two problems, actually. The first problem is we need to update the label, because this would actually work. In fact, we can try this right now and it should work, but we can't update the label. So we need to update the label. So we can say get child 0 and then get child one more time, because the label is a child of the item. So this is the item and then this is the label. So now that we have access to the label, we can say dot text is equal to the string of the get child, we'll just copy paste this part right here, of the count itself of the item. Okay, so this is the updated count, right? Because we subtracted 1 and we're now updating it to the new count. All right, but now what we want to do is we want to check to see if the count is less than or greater to 0. Right? If it's less than or equal to 0, well, I just want to get the child and queue free. I want to destroy the item that is in my inventory because I've used up all these items, all the potions, right? If I drink them all, I want to destroy the item. All right, so this should be it. So now if I close the script and I hit play, I should be able to use this potion, which is not working. So let's check out what's going on. All right, so let's go into our script and try to see if we can debug this a little bit. Okay, so what we'll do is we will do something that you shouldn't do, is anything, which is a print function to debug. So we shouldn't be printing, but we'll use that to debug. Okay, we can click. Now let's head back to our script and see if we can move that as well. So we'll put this, let's see if we can put this right here, see if we can hit play. If that will print. Okay, so it looks like the clicking is working. So clicking is working. Now if the get child count isn't 0, let's print if it's misc, so we can see if it's a misc item. Right, so it doesn't seem like it's printing a misc item. So it doesn't think that that item, the potion, is a misc. So let's take a look at the resource small potion. Okay, so it says that the type is head, so that's probably why. So we'll want to change that to misc. Let's go to our longsword and make sure that's weapon. And of course, this should be weapon as well. All right, there we go. We can now use a potion. Okay, so that is our misc items completed. Okay, so I'm going to delete this print. So that's something that we technically shouldn't do. It's not good practice to print the debug, but just wanted to do it quickly on recording. So that way you can learn how to debug with me as well. All right, so that is it for our usage of an item. Now in the next part, because we're technically almost done, we want to add a function, should get rid of there, in here to add a new item. Because this technically adds an item and we could use this as a function, but this doesn't really work. I'll tell you why right now, is because what if I want to add an item and that item is already in my inventory? What if I want to add an item and my inventory is full? What if I want to add an item and there is a stackable item? There's many cases that we want to check for to see if I can add an item or not. All right, so we'll do that in the next part. All right, welcome everyone to this part. In this part, we'll be creating our add item function. Okay, so in order to actually begin this, what we need to do is we need to globalize our items. So what we're going to do first is we're going to delete this, and we're going to delete this. Now, one other thing we're going to do is we're going to create something, an export variable called inventory size. And I'll say this is equal to 24. And now I can replace this 24 over here, as I'm going to end up needing to use this later anyways. In our game variable, we will create a new variable called variable items. And this will hold all our items that exist in the game. The first one will be default. And this will be our default item. And we're going to preload this. So we're going to search up default. Next, we're going to need to have our longsword. So we can say longsword. And now we can say preload longsword. There we go. And lastly, we have a small potion. And now we can preload this potion. Small, or we can just say potion. There we go. And there we go. There's all our items. We have globalized our items. Okay, so now what we want to do is we want to make this work inside of our inventory main here. So let's create a new function called function add item, and we're going to pass through the item name. And this will be a string, and we're going to return void. Okay, now what we'll do is we'll create a variable item, and this is just going to be an inventory item, right? The class that we created, right? So we're going to say .new, and we're going to say item initialize, just like we did before, and we're going to pass through the item name, and we can do item name like so. So we'll get access to the items and pass through the item's name to initialize it. Okay, but now returning to our previous questions, now what do we do? What if the item is stackable? What if the item is already in our inventory? Those kind of things. The first question we'll ask is, what if the item is data is stackable? If it is stackable, then what we need to do is for I in inventory size. And what we'll say is, fine, if grid dot get child 0 dot get child count is greater than 0, that means there is an item in this slot. So we're going to essentially for loop through our inventories, basically inventory, so through our grid, and we're going to find the first slot. We're going to go through each slot and check to see if there is an item or not. If there is an item, then what we'll do is we want to check to see if that item is equal to the item I'm currently trying to add. So if that item that exists currently is the same as my current item, and the item that I'm adding is stackable, then I'm going to add it there. So first we'll check to see if the grid dot get child I. Also need to make sure that this is I, not 0, because obviously that would make more sense. So get child I dot get child 0, right? Because here we already checked to see that the child count is more than 0. So this is going to get the item. And now I want to get access to the data and see if it's the same, so equal to item.data. Now, if it is the same as the data, right? If it's the same item, then what I can do is I can add it. I can say get grid dot get child I, and then get child 0. And we can say dot count plus equals 1. Because I'm currently trying to add something to an item that already exists and it's stackable. So I'll just add to the count. I don't need to add a item. I just need to add a count, right? So now, so let's now say and update the counter, right? So we want to update the counter, and we can say get child. Let's actually copy all this here. It's a little quicker. So we can get the data, but instead of the data, we're going to get child one more time. Because if you remember, the label is a child of the item itself. And then we can say .text is now equal to the data, which is, we'll copy paste it right here. So this is the data count. So right here, we can say it's equal to the string of this data count. Okay? So it's a long line, but that's essentially all we're doing is we're updating the counter. So we're update the label counter. And then here, update the counter. All right. Now, below that, what we'll do is we'll break. The reason we can break and we want to break is because we're currently looping through the inventory. And if I find the inventory or I find the item and I stack it, then I don't need to continue looping, right? Now, okay, if the child count is not greater than 0 and I find an empty slot, I will now add it into my inventory instead. We couldn't find the item in the inventory, so we'll create it. We can say grid.getChild I.add child item, and then we can break. All right, now what we can do is check to see, or not check, but if the item is not stackable by default, well, we can just add it. We don't need to check for any of this stuff. We can just add it, right? So if I already have a sword in my inventory and the swords are not stackable, I'll just add another sword to my inventory. No problem. So I can for loop I in the inventory size, right? And here I'm actually going to just copy this. as well. Now, instead of greater than 0, I'm just going to check to see if it is 0, because that means the slot that I'm looking at is empty. And if it is, then I can say grid.getChild I, and now we add child. We add the item that I created, right? Now, of course, you might assume we can just break because we're for looping, and I can just break, and there's no need to continue, right? Okay, this is our add item function. So let's test it and add item small potion. We can add item long sword. And let's copy paste the small sword or small potion a few times and hit play. All right, there we go. There's 4 potions and 1 sword. We can use them up, and we can see that they're getting used. Now, of course, if you might want to actually change it, because dragging it, we left click, and to use it, we also left click. So you might actually want to change it. Actually, I might as well change it. So the index, I'm going to change it to 0 to be right click instead. Now, if I left click and move it, it won't work. But if I right click, it's still not working. So let's take a look at the button index and see what is the button index for right click. So we can print the button index here and click. Okay, so it's actually 2, not 0. So we'll check for 2. All right, so now if I right click, it's still not working. Let's add button mask. Okay, well, let's not check the button mask. Let's try one more time. See if this works. All right, there we go. Now I can right click and it works, but we should check for the button mask because here, let's print the button mask as well. We can see what the button mask is in this case. Okay, so the button mask is 0. So here we'll check for 0. There we go. So now this should only happen once, where if I right click, it only uses 1 item. All right, there we go. And now I can drag and drop it without using it. Okay, so there you go. There is our inventory system. It's relatively dynamic. It works pretty decently. And of course, you can always add new items. So let's actually head into a part where we do that to show you how you would add a new item. Okay, so to add new items, what we'll do is we'll duplicate the longsword, and we can say body armor, I guess. I don't know. Body armor. And we'll go to the body armor, and we'll rename this to armor. I don't know. I'm not very creative. So the defense, we can say 5, and the damage is 0. The type, we'll leave it as body. And the texture, we want to change it to, well, some sort of body armor. So let's find something. We can find this. Oh, there it is. We'll find this one, pop it in. And now what we should be able to do, and what we want to do is in here, we want to, let's pop this out. We want to add a new item. So comma, and we'll copy paste this and change this to body armor. And we'll now load the body armor. So we'll say body armor. Okay, that should be it. So now we should be able to add our body armor in here like so. Now let's close, play. And now I should be able to drag this into only the body type. There we go. So that's how we add an item. Now do keep in mind in the slot itself, so in here, we will now have to check for our item body, right? So we now might want to check to see if the item or the type is body, right? Now if it is, of course, we'll need to create a new game item here. We'll say body equipped. And here, we can now go in here and say body equipped. But of course, the default thing that we'll need is we can say the default is a sword because the stats of the sword is all we need. We don't need to show anything. So the stats of the sword is all I need. And yeah, so let's close this and give it a try. Hit play. Let's head to my remote, the game again, or let's go to game. And now you can see here the default sword for both of these. And now if I drag in the body armor changes. And if I drag this in, it should change the default sword. It doesn't, so try one more time. All right, so that's a little bug that we can take a look at. And yeah, let's take a look at that real quick. All right, so as I suspected, I've changed the code a little bit, and I kind of hinted at this before, but a match function would work much better, and it makes a bit more sense. So in this case, we're just going to match the type to see the type of the item itself, or of the current equipment, or the current slot. And if it is a weapon, we'll just change the weapon to the item data. If it's a body, we'll change the body. And of course, if this is an else statement almost, so if it's neither of these, meaning there's nothing in the type, then we'll change it back to the default, right? The default sword. So now if we test this, let's open the remote, go to game, and we should be able to see these work. Now if I drop this in, body armor, and now this works as well, it gives me longsword. I should be able to drag this out, and it goes back to default. And there we go. Okay, so that is our inventory system relatively done. Now, in the next part, we will go into actually implementing this into our game. So I'll see you all in the next part for that. All right, welcome everyone to this part. In this next part, we are going to now create our objects. So because we have a way to add an item through code, but obviously that's not exactly what we generally do. Well, we could, of course, in our skeleton when we die, which is somewhere here, if the right here, then of course we could just add the items to our inventory. But generally, that's not the best way we could do it. We're going to do a better way. So the way we're going to do it is we're going to create a new node. So let's actually close all this. And in our inventory, though, let's add our inventory in here. Here we go. And we'll make sure that this resets at position 0, like so. And in here, we'll create a new node in area 3D. And now, this area 3D, we want a few things. Now, what we want are the items that we would create. So the first item we'll create is a mug. This will be our potion. As we don't actually have a 3D potion, of course, feel free to find one or make one on your own. I'm just going to use this mug as our potion. I'm going to make this local and pop this out. Next, I'm going to use a sword, one-handed, and I will pop this in as our sword to show or represent the sword that we have. I'll delete this and reset this. Reset the position to 0, 0, 0, like so. And there we go. All right, next, we want to create a script for this guy and call it item object. And I will place this in, I'll just place it right here. Actually, I'll place it in the GUI inventory, as this is kind of an inventory item. And I'll remove all this code, as we're not going to need any of it for now. Next, we're going to add a collision shape. And this collision shape is going to represent the actual area that I pick up the item. So I'm going to give it a sphere and make it a little bigger and a little higher, like so. Now I'll save this scene as item object, go to my scenes, go to GUI, inventory, and I can save it in here. Save. And now in our name, I'll rename this to item object. I will now go into this nodes and connect the body entered. I want to be able to find out if this was the player that picked it up, right? Okay, so when we pick this up, it's not too difficult. What we'll say is if body is in group, right? Player, that means the player picked it up. Now what we can do is self.hide, self, we'll do free in a second. But now what we want to do is match RNG to whatever item we're currently using. So we will add the inventory item. So here is the add item. This item we'll add is going to be the sword. So we'll say long sword. And the next one will be the potion. But for the RNG, this is going to be a number between 0 and 1. We can actually do 0 to 3. So let's do that. So let's create our variable RNG as an integer. And we'll set this in the function ready. We'll now say RNG is equal to Randy range from 0 to 2. And now we have our RNG, but we need to set the swords and stuff to this. Actually, one other thing we'll do, because we're doing a third one, is armor. So let's find armor as well. Let's see if we can find it. Let's find our warrior. And what we can do is, okay, maybe not the skeleton. We'll put in the, not this guy. Okay, let's find our assets. Let's go to our assets and find the adventures. We'll find the assets here. And there might be a thing that we'll need. Okay, there isn't. So we'll go to the knight, bring the knight out, we'll make this local. And I'm going to find his armor, his body, and drag that out. There we go. And so now I've stolen the armor of our monster here, or our warrior, and I'll reset that as well. So there we go. I might actually move that a little down there, like that. All right, there we go. And yeah, so we'll rename this to body, and rename this to sword. We can rename this to potion. All right, back to the script. We will now match the RNG to the collisions here, or the meshes. So we want to show and hide depending on what's happening. So we can match RNG and say match the RNG to 0, 1, and of course 2. Okay, so if it's 0, we'll say that this is the longsword. So long sword. If it's 1, we'll say this is the potion. If it's 2, we'll say this is the body armor. Okay? Put this up here. And now what we can do is we can just say get node sword dot show. And then we can duplicate this for each of these, and we'll replace them with the potion and of course the armor. What was the other one? It was body. All right, but now we want to hide all of these, right? We'll do that right before the RNG. So what we can do is just say, we'll copy these, each of these to this. And now we'll just hide them all instead of showing them. So we'll hide all of them, and then we'll match the RNG and see which one we're showing. Okay, and now similarly, I can actually just copy this. Or actually, I'm not going to copy it, but I'm just going to go over here and complete the add item. So here we'll add the items, but this one will be a small potion. And this one, of course, will be the body armor, right? Now we need to actually get the inventory from the item object. The question is, how do we do that? Well, in our level, what we're going to do is we're going to create a new node called items. So we'll create a node 3D as a base for all our items. So our item object, let's find our item object node that I just created. We'll go into this. So whenever our monster dies, I will create it in this node. So from our script, I can actually drag in the GUI, and this will give us the path to the GUI. I'll paste that in here. But of course, we also need the inventory, because in our GUI, we also have the inventory, and that is where the function add item is. So now what we can do is copy this get node path to each of these. And there we go. So now this should work. So if we close this and test it out by going into our level, we should be able to see the object right there. So if I hit play, I should be able to now pick up this item that is right next to me. And we can't pick it up. So let's figure out why. Actually, I think we did pick it up, but we didn't queue free. So let's say self.queueFree. So now, if I try one more time, okay, it's picking up the potion. Yeah, so it did work, but it picked up the potion that time. So yeah, let's try one more time, see if the RNG works. All right, so this time it's a potion again. So if I pick it up, it should have given me a potion. Okay, let's try one more time to see if we can get a different item. Okay, so it's a potion. No, it's an armory this time. So now you can see I picked up armor. So it's a little hard to see, of course, but it was an armor, right? So if we turn off the visible collision, it might be a little easier to see. All right, so this time it's a potion, as you can see, and there we go. All right, so that is it for this part, this item. Now in the next part, we're going to complete the GUI, as you saw, because the inventory is kind of just in front of us, and I can't really hit escape. I can't really interact with anything. And of course, this doesn't really work perfectly. So we'll implement the rest of our GUI as we're going to also create some profiling. We're going to create a profile to hold our stats, and we're also going to be implementing a pause section, stuff like that. So we'll get into that into the next part. All right, welcome back everyone to this part. So we're going to continue now our GUI. Now, in our GUI, we have quite a few things to do and add. So the first thing we're going to do is we're going to now add our HP bar. So to do that, we're going to add a progress bar. Now, if you recall, the value of this, let's say we've set this to 50, is already the HP bar. Now, there's a problem, of course, which is that we don't have the background, the pretty little background. Now, to do this, what we can do is find our GUI here, this guy. I'm going to just drag it in. I'm going to select the Sprite 2D. I'm going to go to Region, Enable, and now I can use this just like I did before and edit the region. And now we can select whichever one we want. I'm going to select this one. I believe another option would be this one, but I think that one is unique to these. Because I used the flat line, I'm going to use this one. And now I can just select it like so and close. And now we have this nice little sprite. Now I'm going to maybe double the size. So I'm going to go to Transform, say 2, and maybe extend it a little bit. And now I can take my progress bar, make it right next to the UI. And of course, I'm going to drag it next into the slot. So I need to make sure that the thing kind of fits in perfectly, like so. And here we go. So 100% would look like this. And that's perfect. Now for the percent, I'm going to turn that off by showing percent off. And now I can zoom out, and there's my HP. Okay, now I'm going to rename this to HP bar, and we will work on the functionality of it in a little bit. But the first thing I want to do is actually make the interface work with our mouse and stuff. So we want to be able to press pause or escape and actually pop up our GUI and stuff like that. So let's add our GUI script, and I will put this in my scripts folder. Here we go. Okay, now in here, I'm going to remove both of these for now, and I'm going to create our physics process function. And before we start this, what I'm going to do is I'm going to create a control node as my container for anything I want to show or hide. So this is going to essentially show the inventory or, well, the profile. Now inside of this, I'm also going to add a panel as the background of this menu essentially. So let's put this right here, and I'll put it kind of like that, maybe like so. And I'll pop this as the background, so I can say EG, and I can lock it. Okay, so now I have this container. I'll just rename to container that holds all the things I want to show and hide. All right, so now back into my script, I'll pop this out. And now what we can do is say if input.isAction just pressed pause, which is something we added from way before, if you remember. Then what we can do is we can say getTree.paused is equal to not getTree.paused. Now what we can do is say getNode container is visibility basically is equal to the getTree.paused, because the getTree.paused is actually a Boolean. And so I'm going to set that paused equal to whatever it's currently not. And then I'm going to set the visibility equal to that paused. So that way it's a little more dynamic. Okay, now what we want to do though is we want to match the getTree.paused with a true or false. All right, so if it's true, what we'll say is input.mouseMode is equal to input.mouseMode visible. Now we'll copy this into the false, and this will be captured instead. All right, so that is that for that. So now this should actually work. Okay, but one other thing we need to add is a ready function. And in here, we're going to say getNode container dot visible I'll actually just copy this right here. Here we go. So by default, I'm going to set it to whatever the pause tree is, which would by default be paused. And now I'm going to close my script. I'm going to hit play. And by default, the inventory should be hidden. But if I hit escape, I can now use my mouse and play around in my inventory. Now, if I hit escape, you will notice that I can't do anything. Now, I want you to figure this out as why I can't click escape again. I also can't. Oh, interesting. I can move, but I can't click escape. Now, why? Okay, so why can't we click escape? Well, it's because the process mode is paused. So in our GUI, we need to set this to always. Okay, now let's click play one more time. And now I can pause or unpause the game. I can move things around, and I can pick up an item, and we get an error already. Okay, so it's saying that this path is no longer valid, which is true because I changed the path to GUI container / inventory. So let's make sure we fix that. All right, there we go. So now this should work once more. Now we can pick this up, and now we see our new armor. Okay, so that is our pausing and unpausing. Now in the next part, we're going to continue this, and we're going to start implementing or creating our profile. And we're going to be able to switch between our profile and our inventory. All right, so in this part, we're going to kind of begin our profile and not exactly complete it, but we're going to put it in and be able to show it using a button and stuff. So you'll see what I mean in just a second. So what we'll do is I'm going to close the item object and create a new scene called profile. Now I'm going to set this to nothing, and I'm going to set this to profile like so, and just save it. And I'm going to save this in my GUI scene. I'm going to get my profile and just pop this in. Now the reason I do this is because I want this to just be a node as I create the buttons for it as well. So in the container, I'm going to create a VBox container, and this is going to hold my buttons for the inventory and the profile. So in that, we're going to create 2 new buttons. Now you may see that the button doesn't exist. Now I want you to guess why that is. Try to figure out why this is not showing. And we did actually do this. We did show this. We did go over why this is happening. And the answer is, well, because this is a control node, it is inheriting the control nodes. In the layout, we have a custom minimum size that we need to give it. Now that size can vary, so we can say 50 and 50. Now the the horizontal, right, the Y, technically doesn't actually care about this. It cares about the VBox, because here I can actually subtract it or increase it all the way, but the decrease, it will only go down to 50 now. So it doesn't actually matter on the Y, but for the X, we got to make sure that it's at least not 50, but whatever number I want. So in this case, or actually, I think I reversed it. So yeah, the Y has to be a big number, whereas the X doesn't really matter. I might as well just keep it as 0. For the Y, I'm going to do 50. Now for the button, I'm going to call this the inventory button, or I'll say button like so. I'll duplicate this and rename this one to profile button. Next, I'm going to connect these buttons to the GUI. So let's connect it in here like so. And now we have these 2 signals. Now, let's pop up our code here, because what we want to do now is we want to basically show the inventory in this one and hide the rest, and show the profile and hide the rest. Okay, so let's do that. It's not too difficult. So what we'll say is get node inventory dot show. And then we can say get node profile dot hide. And now if we copy paste this into this part and just reverse them, we want to show the profile and hide the inventory. But that's not all I want to do. I want to do something else that I think will help you guys, and it'll be kind of cool. In fact, we might actually have to edit a theme to be able to do this properly. But what we're going to do is we're going to say get node inventory button dot disabled is equal to true. And we're going to duplicate this. And here we're going to say profile button is false. So let's duplicate this as well in the profile. And we'll reverse these as well. So this one will be true, and this one will be false. So why am I doing this? Well, when I disable the profile button, that kind of indicates that I'm in the profile. So in our theme, in our default theme here, if you recall, the disabled button, we actually set it to nothing. Now what we're going to do is in the inspector tab is we're going to actually set it to the pressed. So let's go to the button and take the pressed texture and pop that into the disabled. Now it'll look as if that is my pressed button. So now if I hit play and I go into my thing here, I'll click this. And all right, we have a little bit of a bug. So let's see what's going on. We can go to the focus. And I believe that is why. The focus, we need to turn this to, I think, invisible. Let me just double check. Okay, so what I'm going to do, or what I ended up doing, is for the disabled, I'm going to set that to the normal. So the normal, I'm going to put that in the disabled, and the focus will also be the normal one. Okay, so now if I hit play, this is what we get. We can hover it and just click, and it is now disabled. You can see it kind of becomes grayed out. All right. Okay, and now it works because we can see that the inventory disappears. Now, for the profile buttons, I'm going to actually type in for the text, profile, and inventory for the text. You can say inventory for both of them, or just in. That will shorten it a little bit, so that way we have space. Okay, and now we have a decently working system here. We have our profile, we have our inventory. I can drag and drop stuff. Here we go. And yeah, there we go. This is our profile, but in there, of course, we're going to have to actually show things. So yeah, and then that's what we'll do in the next part. So in the next part, we'll actually show some stuff in the profile because obviously we want some stats, right? All right, so I'll see you all in the next part. All right, welcome back to this part. In this part, we'll be continuing our profile, or completing our profile, hopefully. So let's head into our profile, and we're going to start adding things into this because, well, we want to show things. And those things are going to be the stats. So you can maybe imagine that we're going to use a label as our node to do this. Now, another node I'm going to kind of suggest that you look into is something called the, rich text label. This label is kind of for pretty text. And there's something called BB code that allows you to kind of customize the text and make it just look better and prettier. And you can color certain words. It's really cool, and I definitely suggest you look into it. I have some videos on my channel that you can definitely check out, so definitely check it out. And yeah, so let's head into our profile. So let's rename this to stats label, and we'll create a script for our profile, create a new folder, we'll open this up, go to scripts, go into GUI, and open and create. All right, now in here, what we can do is we're going to do something that we should not do, which is update the label inside of our process function. But let's do this, and I will show you a better way to do this in a bit. So first, what we want to do is we want to get access to the node, the label, obviously, and we want to edit the text. Now to do this, what we can do is say string here and press enter. Okay, let me pop this out so it's a little easier to see. Okay, here we go. Now, this is kind of a something I want to show first is when I do this, let's say I put player health, right? And I put the %s, right? So here we go. I want to show the health of the player here, right? Now, here's the part that I want you to understand is that when I press enter like this, this represents a new line. So if I now do this, this is another new line. So if I put player whatever, let's hit play and see what we get. Because now, let's put our stats maybe right there. That's where our panel should be. So let's hit play. And now, when I go to my stats, well, there it is. I'll probably have to move it a bit more. The player health is going to the new line, which should be right here. And then it's going to another new line right here. So just keep in mind, basically, what I'm trying to tell you is keep in mind that when you do this, depending on how many new lines you want, this may be more than what you're asking for. So in my case, I'm just going to have one new line in the sense of I'm going to press enter and go like this. But now I'm going to say player attack is going to be equal to %. So let me actually just copy all this. I'll go to the new line here. Like so. There we go. Okay, so this one we want to be the player defense. And then this one we want to be the player level. And then this one I want to be the player XP. Okay, now the player XP and level, obviously we don't have that yet, but that's okay because we're going to add that eventually. Okay, so we're going to put %s for now. And now, lastly, we can imagine that we're going to need to fill in this information by putting % and then in the array of things. Now the first one is going to be the player health, which we'll have to go to game and add because, or no, we have the player health, but in our game here, we're going to start needing to add some new things, right, to make this work. So in here, we will implement the level stuff later, but for now, let's just add our player damage to implement this. Int as 0. Actually, we'll say 0 for now, and then we'll say player defense is 0. And then lastly, or not lastly, but there's a few more, we'll say current XP is an int equal to 0. And make sure that error goes away. Then we're going to have XP to next level. It's going to be an int, and this cannot be 0. Otherwise, I mean, how are we going to get to the next level? So I'll say 100. So 0 to 100 should be the first level. Next, we can set our level by saying player level equal to 1. And this is an int as well. All right. Okay, so these are kind of our stats. Now, the reason I have player damage and player defense here, which you will implement later as well, is because the equipment needs to add on to our base. And this will be something that we do when we start equipping things. Now, we haven't 100% done that yet, I believe. So we'll have to make sure that we implement this. All right. But let's head back to our profile and complete this. So here we have the player health. We have the player. So for the player damage or attack, now, of course, we have two options. Either we can print the actual damage that we just added, or we can print the right hand. Let's see, let's go to our game, this guy right here. So the right hand equipped dot item damage, right? And then we can also say game dot right hand equipped. Now, in this case, for the defense, you would want to find the defense. In my case, I'm just going to say, let's actually use the body equipped. So we can say the body equipped dot defense. All right, item defense. Make sure that's right. And then we're going to also pass through the game player level. I believe that's right. So let's make sure that's right. Might have to just copy paste all these. There we go. Okay, so we're at the level, and now we have the XP finally. Now for the XP, I'm going to pass through two of them, right? So the first one is the XP, and the second one is the XP to next level. So this one is going to be the last one right here. And then this one is going to be the current XP. Okay, let me just make sure I spelled that right. Current XP, there we go. All right, so let's hit save and close our game. And I'm going to move my profile here. Oh, there it is. So I'm going to reset it to 0, 0 on the position. And let's hit play. All right, and here we go. Now, if I go to my profile, this is my profile. So I have player health 2, attack 2, defense 0, level 1, and XP 0 out of 100. Okay, now by default, you might have noticed that the profile we will want to hide, right? Otherwise, it'll show on this, right? So I don't want that. Now, we can obviously do this in various different places. One place I will do it is just in the GUI, as it kind of helps me keep everything organized. So now I can just take my profile here and say .hide. I'm going to use the getNode function instead here, though, because I just want to use a consistent way to get nodes properly. All right, so now we are able to hide the actual profile inside of the container, as well as the container making that invisible. All right, okay, so that's pretty much it for the profile. In the next part, we're going to implement our level function, because why not? We added our level stuff, but we didn't implement any of it. So we'll add a few new functions that will allow us to level up and gain XP. So I'll see you all in the next part. All right, welcome back to this part. In this part, we'll be implementing our level up system. Okay, so to get started, we will create a new function called gain exp. This will pass through some sort of exp amount. We can say exp amount, and this will be an int usually. So let's now implement this. Now this is not too difficult, as all we need to do is add current XP to the amount that we're adding. But now we need to check if, we'll say if for now, if the current XP is greater than or equal to the XP to level up next. Now, there's many ways to level up. There's linear ways, there's exponential ways, et cetera, right? There's many, many different ways to kind of increase the amount of XP to the next level. And we're going to use an exponential way. So to do this, the actual level up here, we will say player level up, of course, is plus equals 1. That's the first thing we need to do. And then we're going to say current XP is minus equal EXP to next level to reduce the amount that we need to set it, basically. We need to reset the current XP to 0, essentially, right? And once we hit the max, which usually it should right here, it will just reduce it back to 0, and that's kind of it. Now, it doesn't actually reduce it down to 0, but there is a more specific reason we're doing this, which you will hopefully see in just a second. Now, the next thing, of course, is we need to go to the next level. How much XP do I now need? Well, what I'm going to do first is I'm going to round the EXP to the next level times 1.3. This is essentially an exponential growth. Now what we'll do is we'll say EXP to next level is equal to EXP to next level. And then we're going to multiply the power of 1.2 with the player level. So this will be based on the player level, but here I need to make sure I'm doing -1 because I already just added 1, right? So I need to basically use the level that I just was, right? So my previous level essentially. So in the beginning, this will be 0, right? So this will be 1 - 1 and 0, right? Okay, now the reason we're doing this instead of just setting it to 0 is because what if I add more than 100 or more XP than I need? Well, an if statement won't work then because it'll just happen once and that's it, right? So we're going to change this to a while loop. So this hopefully never should get stuck because we're always going to be reducing the total XP, unless of course this is 0, I guess. But then that would be a weird bug, so definitely don't try to set this to 0. But as long as this is not 0 and this is some number, we will always be able to level up properly. Okay? So that is pretty much it for level up system. So you can go ahead and test it. You can create a ready function here, gain EXP, let's say 1000, close the game, hit play, go into our profile, and here we go. I'm level 4 with a certain amount of XP out of whatever. All right, cool. That is our level up system. So in the next part, we're going to look over the player damage and the player defense as we need to override this basically, right? So we need to basically have a way to total our damage and defense from all our items, as right now we only have one item affecting one stat, right? Which isn't technically good because what if I have several armors that I want to stack onto my player defense, as well as I need the default defense. All right, so we'll look into that in just a sec. Okay, so to implement this and have our player damage and our player defense to be totaled, there's a few ways we can do this. Now, one thing that we're going to do is what we need to do now is we actually need to create a new resource or a new folder here. And I'm going to say this is the default stats. Now, essentially what we need to do is get our default sword, and we're going to duplicate this and say default body armor. And now the default body armor needs to have the default stats. In my case, I'm just going to say 0. This is totally fine. And then the default armor, I'm going to say armor, and I'm going to change the type to armor. Of course, the type doesn't actually matter, or body, sorry, but you'll kind of see why in a minute as to why we're doing this. Now, what we need to do is in our, right here in our inventory slot where we're matching this, we need to actually change the path. So let's actually make sure that we get both of these right, because the default sword has changed its path, as I have now changed the default sword path. But now what we want to do is I can actually hit Control-Shift-F and find any instance where it says default sword. And now I want to change that path of the default sword in all of these paths. So here we have this one. So we're going to change this right here. And you can see it's giving me an error. We have this one, which I believe is the one we just changed. There's no error here. And then there's this one, which we're going to actually take out in just a second anyways, because we want the body equipped to be something else. So we're going to load in the body equipment now. Right here, we'll say body equipment, and there we go. All right. Now there's many places we can do the stat check, right? We can actually do it anywhere, realistically, but we'll do it in the game. So in the game, we'll create a function process, which I don't recommend doing it here, but that's okay. We'll kind of ignore the, we'll ignore like flexibility here for now. So here we can say player damage is equal to, and at this point now you would stack all the items that you might have damage on. So in my case, I can just say right-hand damage, item damage, and then plus the body equipped dot item damage. Now, of course, I can do this similarly for the player, the item defense. We'll do the same thing for the item defense. And now this should work perfectly. So let's hit play and see what we get first. So we'll go into our profile here. We'll put our, let's actually not equip anything yet. Let's go to our remote and see in our game that we should have, the default armor and the default sword. Now our stats look good. So we have 0, 0. This is not technically good actually because the default sword should be 2, but we'll check that in just a second. All right, so now let's equip this weapon and take a look. Okay, so I have the longsword equipped, but the damage is still 0. So let's take a look at what happens if I equip the armor. Okay, so the armor is equipped, but the stats are still 0. All right, so let's take a look at what's going on. Okay, so here I'm saying player damage. That's probably why. Let's change that to defense. Hit play one more time. Go to remote. Go to our game. Okay, cool. So now we should have the proper stats. So that was a pretty small bug. But now if I equip things, I should change my stats. Of course, my armor, I don't actually know what that gives. Okay, so it should give 5 defense and 2 damage. And let's equip the sword. Go to our game. And okay, so here we have 2 damage and 0 defense, so that's not right. Let's take a look at what's going on. Okay, so here we have the item defense being used and the body equipped item defense, so that should be right. And here we have the player defense. So we'll find any other instances where we're using this, and it seems like that's it. So let me take a look at what's going on, and I'll be right back. All right, so funnily enough, we ran into a very small problem, which is that the game node is not process mode always. So here in the ready function, I've just added this ready function here where we can just say self.processMode is equal to process mode always. Right? So this will allow us to actually process the game script at all times, even if the game is paused. And so that was our problem, was that the game was paused and we couldn't update the script. So now we should be able to update our stats here, go to the remote and check out the game, the updated stats. All right, so now let's actually implement this into our profile here, where here, instead of using the right hand equipped, I will put the player damage. And then instead of the item defense here, I will say player defense. All right. All right, so let's test it out. So let's hit play. Go into here, put all these in, go to profile, and now we have the updated stats. All right, and now we want to actually implement our damage because we shouldn't actually, I don't believe we're doing enough damage. So in our Control F, we'll just find where we're using this damage. So, okay, it looks like we're not actually using it. So let's head over to our player and we'll have to take a look at where we're doing the damage. So in our player script, we'll pop this out. We'll have to try to recall where we're using that damage, where it should be in the damage detector. So here I have 3, which is not right. I want to put game.playerDamage. Now, of course, if you want to add some sort of like stat check with the monster, maybe the monster has some defense, you can do that here as well. Now, we actually might do that here in the damage. So let's do that right now, where in the player, essentially what we want to do is we want to use our defense to, well, reduce the damage, right? Or reduce the amount of damage we're doing. So what we can do is we can say if we want to check to see if the damage minus the game.player defense is greater than 0. Now, if it's greater than 0, that means I can do damage, or I can reduce it. So we'll say damage done. We'll create a new variable called damage done is equal to damage minus game.player defense. Of course, we can actually make this easier on ourselves and just do this and then do this and replace this here. Now we have the damage done. Now what we want to do is, instead of doing this, we're going to create a new function called game.damage player. And we're going to pass through the amount here. All right. Now, otherwise, but here, now what we want to do is we want to take this out, and we want to eventually create this function, right? Now, what is this function for? Why am I doing this? Well, I'm actually adding this function for a few reasons. The main reason is actually because I want to update the GUI. So in our, let's just close play. When I get hit, the GUI on the top left, the health bar, doesn't get updated. Okay, so we have an error, of course, where here we will need to create this function called damage player, and we can say amount, and for now we'll pass. But yeah, so that is the general idea, right? We want to update our HP bar. So we'll take a look at that in the next part. All right, so in this part, we'll be implementing our player damage, and amazingly enough, we'll be also implementing our heal player. Now the reason is, well, kind of reason is, because what we're going to do here is we're also going to be using something called signals. Now, in order to create a signal through code, we need to go to the top somewhere, and we'll create a signal called health change. And we're going to pass through a damage amount. Now, the cool part about this is, let's say I put this actually in my profile for an example. I'm not going to put it here, but I just want to show you what this does. In our profile now, if I head over to the node, you can now see this new signal that I've created. So this is a new signal that you can create custom made to, well, you. Now, of course, I'm not going to put it here. I'm going to put it in the game. Now, there's more than one way to connect a signal from one node to another, which is using code. So let's figure out how we can do that and how we can emit that signal as well. Now, we can emit a signal pretty easily by saying self, or just emit signal, and we're going to emit the actual signal, that is health changed, and we're going to pass through the damage. Now, this will allow us to, well, actually pass through the damage through this function. Now, we'll say player health minus equal amount, because, well, here we're damaging the player, right? We want to damage the player. Now, okay, so the amount is here, not damage, sorry. Okay, so here we go. Now, of course, we also want to actually do this for the heal player. So let's do that for the heal player as well. And now, what we want to do is we want to go into our GUI. Now, in our GUI, this is where we will be editing or changing our HP status. Now, in here, what we can say is get onReady variable HP bar equals get node HP bar. So I can just get access to it a little easier. Let's pop this out so it's a little easier to see. Okay, so now what we can do to connect this signal is we can say game node dot health changed dot connect callable. Now there's many ways to actually connect a signal, by the way, but this is one way that I'm kind of used to, saying callable, and then we'll pass through the node or the name of the function I want to use. So in this case, I will say on node health changed. All right. So now the question is, well, what the heck is game node? Well, game node, we need to create it. So game node, it needs to be a path, right? So it needs to be a way to access the game script, which you'd think we can just say game dot, but in this case, we can't because this does not access the node the same way. So now what we can say is get node, and we'll pass through the game dot get path. So in this case, we're just getting the path of the game script, and then we're going to get the node. So now we can say game node dot health change, blah, 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 blah. Okay, so now we can connect this signal on the bottom by creating this function that we just created. Now, if you recall, this function passes through a damage amount. And this is a variant, spelled it wrong. And now this is where we can change the HP bar. Now there's many ways to do this, but the way we'll do it is using Tween. Tween is very cool and it has many animation effects. So let's create a tween called create tween, and we'll say tween dot tween property. There we go. And we'll pass through the HP bar. And we want to take its current value to the new value, which is going to be HP bar dot value minus the damage. Right? So the new value will be the current value minus the damage. Now we'll do this over a time of 0.2 because we want it to be relatively quick and update the health bar, quickly. Okay, so now there's an issue though, which is the max value of that HP bar is still 100 because by default, we look in the HP bar, you can see here the max value is 100. So we want to change that by going into our ready function. We can say HP bar dot max value is equal to game dot player player max health. All right, so now let's hit play and test this out. So now I should be able to go up to the monster and he should be able to just hit me. And I just died in one hit, but you saw the HP did go down. So that was good. All right, so now let's test the defense because I recall that we actually implemented the defense. And now here, we'll have to reset the HP later, but let's take a look at if this works. Okay, so it should have worked technically because we did not lose HP. The reason it didn't work is because our player HP is set to -2 here. So when we game over, this is kind of a common thing that we need to do, is when we retry the game, we need to reset our health bar. So we can say player health is equal to game.player max health. All right, so now let's test one more time and take a look at if we can test our game. So here we go. I'll die. And I replay here. I should have 2 health again. But if I equip this, I should take no damage. So let's try it. Okay, cool. I'm basically invulnerable. I can never die now because my player health is 5. And he, I believe, does like 2 or 3 damage. So we will never die against him. And of course, we can equip a weapon and just kill him in one hit. Awesome. Okay, so we have created a pretty cool system here. We've implemented a lot of things, including our profile, our inventory, our item stats, etc., etc. We have so many cool things. Now it is finally time to, not just yet, we're not going to move on to the juice part of the game, but we're going to now move on to the monster dying. So in our monster effect, when he dies, we want to now create some objects, some items, right? So let's take a look at how we can do that. All right, welcome back everyone to this part. In this next parts, hopefully we'll try to finish all in one. But essentially what we want to do is 2 things. We want to create the item objects when our monster dies, and I want to actually create a cool tweening effect with the randomizing the position kind of the item spawning. So first, let's head over to our warrior skeleton. Let's actually close everything so that way we have our scripts a bit more organized again. We'll open our skeleton here, and then we'll open our item object. We'll open the actual scene here, so because why not? And let's head into our script and open this up and take a look here. All right, so now we ask, where is the death? Well, the death is right here, but we don't want to create that there, obviously. We want to create it right here. Okay, so right here is where we can actually create the death or the items, right? So let's head over to the top because we're going to need to, load the items. So let's say onReady variable item object scene is equal to preload item object. There we go. That's our scene. So we can take this scene here for this variable, and I lost it. There we go. Here it is. Here we can say item object temp is equal to object item object whatever blah 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 instantiate, and now we can start doing things to this, right? So now the question is, well, what do we want to do? The first part we want to do is let's close our script, as we're going to need to go into here and find the items node that we added. So this we need access to, right? We need to access that through our monster. So, okay, now that we've accessed this, we need to add it to that variable, right? So let's do that. And here we can just say .add child. Oops, there we go. And add the temp. Now, what else do we need to do though? Well, technically we are kind of done, but let's actually just change this to get node. But this is kind of messy. I'm going to change this and put a function def instead. And now at the bottom, I can just call a new function def here and say, and copy paste what I just put. Okay, now there's more things we want to do in here, right? Now, if you recall, well, just 2 seconds ago, hopefully for you at least, we created the gain XP. Now in here, I can gain, let's say 100. That's, I think, pretty reasonable. Now, what else do we want to do? Well, I don't want to just create one object. I want to create several. Let's create a variable called RNG is equal to randy range from 2 to 4. Now what we can say is for I in RNG, and then we will do these this thing in here. So we will create several objects. Now, the last thing we need to do, though, is take our item object temp and say global position is equal to self dot global position. So let's copy that. All right, there we go. And this is technically it. But if I hit play and we try this, this should work. So let's give it a try. Let me equip a weapon so I just one-shot him. Okay, so we can see here that it does work, but it's hard to see, but there might be more than one object, but I can't tell. The reason I can't tell is because they're all on top of each other. So in our item object, in our ready function, we're going to change the logic here a little bit and essentially randomize the position. So here we have the RNG, but we're not going to use that. So we'll kind of push all this down. But what we'll do is we'll create a tween and say create tween. And I want you to actually try this on your own because we've created a few tweens by now. And essentially what I want you to do, try this on your own, is we want to tween to a random position. So we want to take our current position and tween to a random position. Okay, hopefully you tried this. Now to do this, what I'm going to do is I'm going to create a new variable called RNG position. This will kind of just make this a little easier to do. And I'll just say vector 3. I'm going to pass through a randy range. Now the range is actually kind of small. All we need is -1 to 1. Now for the y, we're going to put 0, 1, as I want this to kind of be on the floor, right? If I put 0, it might be in the floor. Okay, now I'm going to do this for the z as well. And here we go. This is our randomized position. Now what I can do is I can say tween dot tween property. We will tween self. We want to tween the position. And whoops, the final position is going to be position plus vector, not vector 3, the RNG position that we just made. We just add RNG. There we go. And we will do this over a period of, let's say, 0.3. All right. And that's it. Now, if I hit play, I can hit play. You can test this out. Let me equip my stuff here. Oh, he didn't die. Okay, that is an interesting bug. We'll have to take a look at that. But yeah, there we go. So there's our items. They are all created, and I can pick them up. And you can see that I got them in our inventory. All right, that's pretty good. So that is our item creation. Now, one thing I'm going to do, of course, you can kind of, this doesn't really have to do with anything, is in the level up, I'm going to actually increase our HP a little bit because there's no way to increase our current HP. I'm going to say plus equals player level maybe times 10. And then I'll say player health is equal to player health max. So this will heal us basically. I should probably want to level up first actually. So let's put this after the level up. All right, there we go. So now I can increase my HP. This is more of a gameplay thing than anything. But here, if I hit him, he'll die, and I should have increased my HP. There we go. All right, so that's it for this part. In the next part, I'm not 100% sure what we'll do, but I believe it's time to work on our juice, on our actual scene environment here and stuff like that. So I will see you all in the next section or part. Okay, welcome everyone to this part. In this part, we will be going into our shop. So we're going to be implementing a kind of NPC guide where we will be able to interact with him and buy things from the shop. So the first thing we'll probably want to do is add gold to our game. So somewhere in our global script here, we can add gold. So we can say variable gold It's an int, and we can set it to 100 by default. So that way I just have some gold, so I can, test this out a little later. Okay, now we will want to create a new scene, and this is going to be a canvas layer. And this will be our shop. So we can rename this to shop, hit save. We'll save this in our scenes, our GUI, and we'll save it here. We'll add a script to this, as this is where all our things will happen, right? So let's add it into our scripts. Open, great. And we'll close that for now, or we'll, let's do that. And we'll close other tabs, go back to our 2D, and we want to set up, the shop itself. So to set this up, it's not too difficult. We just need a few things. Now, one of the things we'll need is a panel. We'll use this as our background. So I'll set this, I'll turn the grid on, put it right there. And now we're going to need 2 buttons. One button is going to be the buy, and then one is going to be the close. To actually close the shop, right? Okay, so now we'll put this here, the buy, and we'll put the buy maybe right there. Okay, so in the buy, we'll say buy, and then here we'll say close. Move it a little bit more. Okay, next we're going to need a control node, or just some sort of node to contain the information we'll have. Now in the information, so here we'll call this item info, and I'm going to put some things. One is going to be a label, and 2 are going to be a label. One is going to be the name of the item, so item name, and one will be the description. You can say item this. And lastly, we'll add a sprite. In fact, actually for the sprite, what I'll do is I'll add a .png, one of these items as a test here. I'll put this in, and I'm going to scale this to be much bigger, because this is our shop, so we want to be able to see the item. So I think here we'll set it to 16. Okay, that's a pretty good size. I'll put that right there. And now for actually, I think it's a little big, so maybe let's make it a little smaller. I'll move it up a tiny bit. So that way the description, I can move it right here. And maybe I'll move that right there, move the buy over here, and that down a little bit. Here I can just say, this is a item, blah, blah, right? And I'll move it like so, make it a little bigger, and I can center it. Of course, we can center it here as well. It's up to you. I'm going to leave it on the left-hand side. Now for the item name, we can say sword or something. And this one I'm going to center in both of them. So I'm going to put this up over here like so, and I'll make it a little bigger. And what I'm going to do is I'm going to go to theme override, font size, and make it a tiny little bigger. So maybe 30. And there we go. So that's our name, that's our description, and this is our item. Move it a little bit to the left. Okay, so now what we want to do is we want to actually create the items, or the shop items, that I can buy in here. And we'll do that using a grid. A grid map, but a grid container, sorry. So here we'll say shop items. And I can put this up here. I'll move the bottoms to the bottom. And it doesn't really matter in this case, as long as the panel is in the very back, right? So this is our background, so it needs to be the first node, essentially. Okay, so now we'll connect our buy button. We'll connect our closed button. And now we can add some functionality. Now, we'll also need a few variables. So the first variable we'll need is a current item. And this is going to be a item data. Now, this is essentially going to keep track of which item we're currently looking at in the shop. Okay, so once I start clicking around in items, I will create those items. Now, another thing I'm going to need is a slot item. So the slots that go into the shop. Now, this is going to be a custom-made thing that we're going to make. So what we'll do is we'll create a new scene, and we'll create a panel as the base, and we'll zoom in here. And it looks like our panel is actually not perfect, so let's actually go into our default theme here and make sure we fix this. Go to panel, subregion, here we go. And I will just do that a little bit. Okay, let's do this. I think I will need to move this guy like so. Okay, there we go. I think that looks a little nicer, so let's close. All right, that's our panel. Now for the minimum size, I need to change the minimum size to be 64. So let's select our panel here. go to layout, and go to minimum size. There we go. Now in here, we will need an image. So we'll say .png and find some sort of image, drop it in, and this will be our sprite image. All right, now what we'll do is we're going to cheat a tiny little bit, and we're going to create a button as the actual button for this, because I'm too lazy to actually implement the panel to be a click. But of course you should do that. So what I'm going to do though, I'm going to head into my scale, layout, transform, scale. I'm going to disconnect this and set the X to 0.56, or maybe a little more here, maybe 0.75, yeah. And I'm going to go to the visibility, self-modulate, and turn that to 0. But the cool part about this is if I rename this to shop item, and I add a script here, we'll add this into our scripts GUI, sure. We'll create. Now the cool part about this is if I connect this, just say pressed, is that the button should still work. So we can print shop. And we can test this out. We'll save this in our GUI scenes, save, and we'll hit play. Whoops, it's not the right one. I want to play current scene. Okay, so okay, we'll actually implement the shop first, and then we'll test it out. So let's move our grid here. Let's go back to our shop. Now, what we can do is in here, we'll reload our new scene that we just created. So we'll say on ready variable shop item scene, and this is a packed scene. And we'll say preload to shop item that we just created. All right. Now back in our shop item, we need to implement some, code here. Now, what do we need in here? Well, we need a variable item info. This is going to be an item data. It's going to be the resource, basically. It's going to inherit the information, right? Now, the reason we're doing this is because I want to set from the shop item. So if I create this shop item, and I put this in here, we want to be able to edit this information. So in our press button, I can go to item name and get the node like so. Now I can say get node, and here we go. We now have access to the item name. Right? So now we can change it by saying .text is equal to item info dot item name. Right? Another thing we can do here, of course, is the item info. We want to change the description. Of course, that's also text, so we can just say text. And now for the actual thing, what we'll do is we will find the stats. So let's close this and find what we just found. Here we go. This guy right here. Go into the script, and I'm just going to copy this stats, this thing right here. So I'm going to copy all the way from stats, and after, yeah. So let's copy all this, go into shop item here, and I'll load this in instead. And let's hit play, or bring that out a little bit, because now I need to make sure this is a proper string. So we have the stats, the damage, the defense, and the health. Now, of course, we don't need the item name. We do need the description. We have the item damage, etc. So here we'll put another S here. We'll put a %S and then a new line as well. So this will show the description first and then the stats. Okay, so now what we want, okay, so the data, sorry, is item info here, yeah. So we have to change that to item info instead of data. There we go. Okay, so now we have all that information right. Now for the last one, we want to change the sprite, right? So here in our shop, we want to change that item. So let's rename this to item sprite. We'll go back to our script, and in our item shop, we want to change the item sprite. And of course, the text, we're not going to change the text, we're going to change the texture. Now the texture is going to be equal to the item info dot item texture. And that's it. Now the only other thing we need to do is actually show this node. So I'll just say get item info dot show. All right. Okay, now that's not actually all that's what we need to do, because we also need to set the current item in our shop script to the item info. So we're going to get node. In this case, I'm going to just get node parent. I'm going to delete this and say get node like so, and say current item is equal to item info. So that's the shop item finished. And now what we can do is in our shop script here, we can now start loading in our items, right? The items that we actually want. Okay, so here in our function ready that we don't have, I will create, say function ready, say for I in game dot items, and we will say if I is not equal to default, right? So we have in our game, our items, we have the default longsword or the sword. I might actually want to create the default sword as well, but it doesn't really matter right now. In this case, actually, we don't need this here, but we'll leave it here anyways. All right, so back to our shop. We will go into here and say if it's not default, then we'll add the item. So to add the item, we'll say variable shop item temp is equal to shop item scene dot instantiate. And now we can edit the item temp by saying dot info item is equal to game dot items at position I. Now the cool part about the dictionary is that when I for loop I in the game items like this, the I will always be the key. Right? So here in our game, we have different keys and the strings, right? So the cool part is that it doesn't care. I will always be the key, so I can reference whatever's in the key by doing that. All right, so now that we've loaded in the item info, we also want to load the item sprite of the shop, right? So here we can say get node image, which we might have to change in just a second, to the item game item texture. Now this one right here, we'll have to change that. So let's go back into our item shop and make sure that this says image. Right, so back in our shop here, we'll click here and let's pop this out again. Okay, so it's saying blah, blah, blah. Here we have to set the texture. That's why. All right, there we go. And now lastly, what we can do is say get node shop items, which is the grid, and then we will add the child there. We'll say add child shop item temp. All right, that's it. And now what we can do is in our ready function, I'm going to get the item info. There we go. Item info and hide that. I don't want that showing by default. Okay, next, what we'll do is on the closed pressed, we'll just say self.hide, and we can say get tree.pause is equal to true, or false in this case, because we want to resume the game. And there we go. Okay, on the by pressed, we want to add the item. So that's not hard because we already know how to do that. We can just say get node, which is one up. I kind of already know this one, so it's container, or actually, do I know it? Let's find out. In our GUI here, let's add our shop. So we just added, then in our script, we will get the container right here, or the inventory. Here we go, that's our path. We'll copy that, and we'll say add item. Now the item we want to add isn't just is a name. It has to be a name, right? So what we'll do is we'll pass the string, and we'll say current item dot text. Not text, item name. And that should work. So let's hit, what is this? Get item. Right here, we need another thing here. There we go. All right, there we go. So that is our shop. Now what we need to do, which is what we'll do in the next part, is actually implement a way for our shop to show up. Because right now, if I hit play, our shop might show up. But, okay, so here we have an error, it says invalid, blah, blah. Okay, we can't set the invalid set index with, so the item info. Okay, info item, I set it wrong, so this has to be item info. Let's try one more time. There we go. So here's our shop. But now you can see that I can't play with anything. But our items do add, which is good. So I'll just close this. And there we go. Now, the one thing we have to keep track of is that here in the shop, the default didn't work. So we'll take a look at how we can do that in just a sec. But in the next part, we will also be adding our actual NPC to make sure our shop can be interacted with. Okay, so just real quick before we get started on the next part, the reason why we had a duplicate was because I have a duplicate right here, so I'm going to delete that. And one thing I want to do is, well, I already did it, is I deleted the default as we no longer need it. The only reason we needed it at first was because if you remember, in the inventory ready, we were adding it using this, but we already removed that, and now we're just adding items using this, right? So, and hopefully, and you never should, add the default sword into your inventory anyways, which of course makes no sense because it's that item, that default sword is meant there to be the default stats of the player and not to be an actual item. So that's, yeah, we'll just delete it from the global items, right? So any global items that you add in the future, all you need to do is just add it here. And of course, if you have any functionality, you'll have to add it in the equipment as well. So those are the only two places I believe you should keep in mind, which I think is pretty good, as a lot of equipment systems and inventory systems have many different places when you add a new item. So I think in this case, we don't have too many places, which is very good. All right, so let's get started with our shop. Let's go into a new scene here. And this scene will be, I want you to actually guess what this scene is going to be. This scene is going to be a Area 3D. Hopefully you got that right. Now, the reason it's going to be an Area 3D is because we only need this NPC to interact with the player as an NPC. Now, of course, you could make it a character body 3D. That's totally fine too. But in the end of the day, you will 100% need an Area 3D or some sort of way to detect the player, right? So what we'll do is we'll rename this to NPC Mage. Just say NPC Mage. And I'm going to hit save. I'll put this in maybe I'll make a new folder here, NPCs, save it, hit save. And now we'll add a collision shape. And we will also need the mage. So let's find the mage, the characters. All right, here we go. Here's our mage. Now I'm going to reset this guy to make local. I'm going to reset his position to 0, 0. And I'm going to play the idle by default. So here, I'm just going to play this idle, because that's all I want him to do. I'm also going to go into the rig, and I'm going to delete or kind of hide some of the items he has, because some of them are stacking, and that's not what we want, obviously. So here, I think I'll hide the one-handed staff. And yeah, I think that's good. Of course, you can hide or show whatever else you'd like, but I think this is good. So now we'll give him a collision shape. We'll give maybe a sphere, and we'll make this a little taller here. Maybe I can just do like this. And I think that's a good size. Now we'll create a script for the mage. Pop it in here. We can create a new folder, NPCs, pop it in, create. All right, now we will create a new body entered signal, and we'll close all this, as the only thing we need to do is we want to just check to see if the body is the player. So we can do that by saying if body dot is in group player, then we can say get node, and I'm going to do this. I'm going to say go up to parents, and we'll get the GUI, then we'll get the shop. Okay, and then we'll say dot show. Now another thing we'll do is we'll say input mouse mode is equal to input mouse visible. All right, one other thing we're going to do is a little trick. It's not, I don't know what it's called, but what we're going to do is say game.stopping equal true. Now, let me show you, maybe I'll show you why we do this real quick. Actually, I think I can actually just show you right now. Let's say our shop is open, right? This is our shop, it's open. Now, what happens if I hit escape? Well, you may imagine there's a problem. I may not want to access my inventory while I'm shopping, right? So in this case, we now have a variable to keep track of if I'm shopping or not. Now in my GUI here, I can go into this condition. Let's just pop out the code. right here and say and not game.shopping. Now, of course, we're going to need to add this to our game here. So we'll say variable shopping. By default, we'll say is false. All right. So now, when we close the shop, though, we're going to need to set this back to false. So back in our shop here, we'll set the shopping equal to false. And you can see here that I'm pausing the scene. So in my Mage here, we will also need to set this to true. Now you may imagine we will also need one last thing, which is to one thing I'm going to do actually is I'm going to set the signal to animation finished here. And what we'll do is we will get access to the animation player and just say .play idle, because I actually can't loop the idle inside of this guy, because if I try looping it, oh, I guess it does loop. Okay, interesting. Okay, so either way could work. When I was doing this on my own, it didn't work for some reason. So I guess recorder's luck, I suppose, as they say. So, okay, our mage should now loop. So let's go back to our level. Let's add our mage. So let's find the mage that we just added, pop him in for a scene. And what we'll need to do now is create a new node. I'll create a node 3D, and I'll rename this to objects. And not to be mean to my mage, but I'm going to call my mage an object and pop him in one more time because I think he disappeared. There we go. And I will put him right next to the player. Why not? Now, by default, I also want to hide the shop, right? Because that kind of makes sense. I don't want to show my shop when I play the game. That doesn't make sense. We'll say get node shop.hide. Okay, so let's hit, before we hit play, in our shop, we need to make sure that the process is on always. And now let's hit play. Let's test this out together. Okay, so let's go to our shop. Okay, I can hopefully interact with things. Cool. I should be able to now buy things. Okay, we have a problem here. It says small potion on base dictionary. Okay, so the item name is not the same. So what we need to now do is in our shop item. Okay, so what we need to do is essentially make sure that the name, here we go. The name of the actual item is the same. Now, of course, we could just convert it to small or big or whatever. But in this case, I'm going to make sure that it's always the same capital. So both are lowercase in this case. So I'm going to hit play. One more time. We'll hit play. Go to this guy, try to buy it. See if this one, okay, same thing. So this one, I need to make sure I name it the same. So it's trying to buy the thing called body armor, which doesn't exist. So body armor, I need to change this to body armor because the item name is not the same. And now one more time, that's our inventory. And now I should be able to buy these things. This one might error as well. So let's take a look. Okay, yeah, long sword, be lowercase. All right, there we go. And one last try. All right, let's take a look. We can buy each one. And let's open our inventory, and here we go. Now you can also see that when we go into our shop, I can't click escape unless I close it and I leave the shop. Now there is one more problem. You can see when I close my shop, the mouse is still there, right? So we want to go to our shop and close right here. And we want to do the opposite of, let's just pop this out so it's easier to see. We want to do the opposite of this, which is right here. We will say input mouse. Actually, we'll put this at the bottom. Mouse mode captured. All right. So now we can test one more time. Go into shop, close it, and our mouse is captured again. All right. This is a pretty cool system. We have our shop right here next to the guy. We can interact with him, and go to the monster, kill it, or I die. So I died. I'll retry. And the scene restarts. And yeah, so that's pretty good. We can now also use items. I can heal. Okay, my thing is going down, which is not right. So let's take a look at what's going on there. We'll go into our game. Okay, so I'll take a look at what's going on, and we'll fix this in the next part. So I'll see you all in the next part. Okay, so the problem here actually is in the emit signal, we need to make sure that this is negative amount, because when we tween it, we want to go in the opposite direction. Because it was technically working, it was healing our player, but the emit signal specifically in the tweening was going in the wrong direction. So here we need to make sure this is negative the amount. All right, welcome back everyone to this video or this part. In these next few parts, we'll be starting some new things. Now we're gonna kind of get a little messy because we want to make a mage monster, which is gonna kind of be an extension off of the monster we have here already. But the problem is we want to first create a fire effect. So as much as I want to leave all the effects to the end, we're gonna first dip our fingers into the fire effect to make a torch. So, okay, let's head into a new scene, and I'm actually gonna close everything to the right. And here we go. Now I'm going to find my torch first. So I'll just find the torch, and I'm gonna use, we can use the mounted. Yeah, let's use the mounted one. So we'll pop that in. We will transform, reset the position, make local, and we'll pop the mesh out. And now what we need is a GPU particle. So we're gonna search up a GPU particle. And this is going to be our fire effect. So in here, there's a lot of different things we can change to create a fire effect. So the first thing we'll do though is we'll create a fire. We'll just call this torch and save this in our scene. We can save it in a new folder called objects. Save it in that objects folder, save, and here we go. And we'll just pop this into the objects because why not? Because it is kind of an object. And I think for now, we'll just kind of put it wherever. It doesn't really matter. So let's take a look at the actual fire effect. So for the GPU particles, we're going to change a few settings. So the first one is in the time. In the lifetime, I'm going to change this to 0.3. The interp to end, I'm going to change to 1. And the randomness, I'm going to change to 1. Now the amount we're going to change to later, but I want to do some other things so we can actually see things happening a little later. Okay, next, what we're going to do is go into drawing and turn on the local coordinates and use view depth. Next, we're going to do draw pass. We're going to look at the draw pass and the process material. Let's look at the draw pass first, as that one's a little easier. So we will create a new process material, particle effect here. And now in here, what we'll create is, sorry, I just said we're going to do draw pass and we ended up doing the process material. Let's take a look at the draw pass first. Sorry about that. Okay, so let's go to the draw pass and we will add a new quad mesh. And now you can see our quad mesh. So this is the actual kind of particle that will show up, right? Now, obviously, this is not what we want. This is not fire. So let's try to change it to see if we can get it to be something a little closer. Okay, so the first thing we'll do is add a new material, a standard material here. And this will be the coloring, basically, the actual, color of the fire. So in here, there's a lot of things. Now, yeah, there's a lot. And if this is your first time looking at it, don't worry, don't be too overwhelmed. We're not going to do too much. The first thing we'll do is we'll go to the transparency and we will set this to alpha and add. This will make the fire transparent, right? Which kind of makes sense because fire generally is somewhat transparent. It's not just a full block of thing, right? So, okay, let's go to the shading now. And we're going to set this to unshaded. And that now gives us a little nice glow. Now we'll go to the vertex color and turn this on. We'll now also go to the albedo. And this is the actual color of the fire. So here we can kind of choose whatever fire we'd like. And you can kind of pick whatever you'd like. I think this is actually not bad. So we'll pick that. So feel free to copy these values if you'd like. Or play around with the values, try like different things here and there. I think this is actually not bad, so I will keep this. Now, lastly, we'll go to the billboard. Now the billboard, we're going to set this to particle billboard. Now this essentially shows the particle wherever I am. So no matter where the camera is, the particles will always face me. And I'm going to keep scaled on true. All right, so that's it for the process material or the material of the pass. So let's close the draw pass and let's head now into the process material. This is where all the magic happens. So in here, we're going to change quite a bit. So let's take a look at some of the settings that we're going to change. Now, the first thing we'll take a look at is in the spawn, there's quite a few things that we're going to need to change. And in here, the first thing that we can take a look at is the velocity. So we'll turn off the position, or we'll kind of close the position, and we'll take a look at the velocity. So in the velocity, I want to change the spread to just to 0, and then the initial velocity to 0.1, and the initial velocity max to 3. Now this will kind of give it that random effect. Obviously, it's not completely random yet, and we do have some other issues, which is that the particles are going downwards, which we will change in just a second. But one last thing we want to do is I want to give the angle max to 360. That way the particles are now more randomized in a particle effect, right? It kind of fire randomized angle, right? So each particle is its own little fire, and this gives it that little fire effect. Okay, now we will go to the animated velocity, the angular velocity, and we're going to set this to 40. All right, so let's close these. And now we will go into the gravity, which is in the acceleration. So gravity, and we want to turn this off. And by turning it off, I mean just set it to 0. All right, so there we go. We set it to 0, but obviously this is not fire yet. There's still a few other things to do. So let's go to the linear acceleration, set this to 1, and set this to 5. Now we will go to the display, and that is where the magic will happen. So the display, we're going to go to the scale, and we're going to set this to -0.2, and this to 0.2. And the scale curve, I'm going to create a scale curve. And in here, this is basic. I'm going to go into the curve again. This is basically going to allow us to kind of curve the scaling. Here, I'm going to add another point here, and then drag this down, like so, into kind of the middle. All right, so next, I will go into the, take a look, the hue variation, which is right here. We're going to go into this, set point -0.2, like so, and then set 0.2, and then we'll give this a variation curve. We will go into the curve, and in this curve, we're going to do the same thing. We're going to set this lower, set this up, and set this lower again. All right, so that is our hue variation. Now let's take a look at turbulence. Now the turbulence is kind of like a wind effect. So here we go. Now in the turbulence, the default values are pretty good. I'm going to change the noise to 0.05 to be a little less, because I don't want it completely going to the side. I want it to go upwards a bit. Okay, so now we want to obviously make this a little better. Now to make this better, there's actually not much we need. We just need to change the amount. So now we change the amount to 500, and here we go. There's our fire effect. So now obviously you can see that we can just drop the fire into the thing here. But obviously if you want it bigger or smaller, we can change that using the scale. So here, I think this should be -0.2. There we go. Scale min. We take a look here. Okay, so in the position, sorry, not the position, in the velocity, the problem was right here in the direction. We're setting it to 1, 0, 0. I want to set it to 0, 1, 0, right? So upwards, obviously. Now, of course, you can adjust this slightly, give it a little angle, kind of do whatever you'd like. And another thing that we can do is turn on turbulence again once more, even though I just turned it off. And we'll reduce this again, just a tiny bit, whatever you'd like. And lastly, we're going to go to the color curve, I believe. Yeah, so the color curve, and we're going to go to initial ramp, initial ramp. We'll give it a new gradient. And in here, I'm going to give it the gradients that I like, right? So at this point, you can kind of give it whatever you'd like as a fire effect. Here, I'm going to give it kind of a darkish red, maybe kind of like that, like so. And then in the middle, I'll give it kind of black. And then on the very right, I'm going to give it a orange color again. So just like that. And there we go. We have a nice, decent looking fire effect. Okay, so that is it for the fire. Now in our scene, or actually that's not it, we need to add a light now. So let's add a Omni Light 3D, and there's our light. So let's now look at our scene. Let's make sure we save this. Look at our scene here. Okay, so now we have our torch here. We can hop into the objects and just start moving it. So we can start, we want to move it to the right. We can kind of start organizing this to be however I like. No, I want this to be against the wall like so. Put it right there. And then I can just duplicate this, but turn on the snap. I'm just going to snap it like a few times to the right, duplicate it a few more times like so, and just distance them all from each other. Right, and there we go. There is our torches. Now what I'll do is I'll duplicate all of these, and I will simply rotate it 180 like so, and just move it to the other side of the wall. Now, of course, this might not be exactly on the wall, so turn off the snap and move it along a little bit more. Okay, that looks decent. So, okay, let's hit play and see what we get. Okay, so here's our fire effect with our torches. It looks pretty decent. Now, of course, each fire looks pretty similar in the sense that they all kind of go in the same direction. Now, I'll leave that kind of up to you to randomize a little bit more with whether it's the turbulence or the randomness. Sometimes it might also help to create a timer to start emitting them at different times. That's another cool kind of trick that sometimes is used. But yeah, so this is pretty good. We can now move around our level, attack, and kill the guy. So we even have a working inventory system so far. We have our shop, buy things, clothes, buy our potion. And of course, we have our level system, which is very cool. And yeah, so that's pretty good for this part. So in the next part, we will be taking a look at our mage to, be able to shoot projectiles at us because we haven't done that yet. So we'll be able to do that in the next part. I'll see you all in the next part. All right, welcome back to this part, everyone. In this part, we'll be starting our mage, our actual mage or monster mage. So what we'll do is, because a lot of the stuff is actually very similar, we're going to make sure that we don't do any bugs here. So let's go to the monsters, and in the AI melee, we're going to basically take all this, Control-C or copy, and we don't know if we can paste it. So yeah, what we'll have to do is duplicate it, move and duplicate it, and we will go into the AI range and copy file and copy. And here we go. Now we have everything, but we need to change this guy to Mage Skelly. I think I misspelled it, so let's try that again. But now what we need to do is in each of these states, we need to now adjust it, right? So we need to make sure that these are all adjusted for the mage because they are almost the same, but they're slightly different. But one last thing we'll do is in the warrior skeleton, we will again duplicate this guy, duplicate, and honestly, we can just Control D and say Mage Skelly and hit duplicate. Now in the mage skeleton, we'll open this guy up and we're going to delete the skeleton warrior. As now what we need is the skeleton mage, right? So we're going to pop this guy in. Here we go. Make it local and adjust this to be over here. Now for the rotation, of course, we can always set this to 180, but in a certain case, it doesn't actually matter. Well, it does matter because the direction, but for the attack detection, or sorry, this one right here, we're going to actually change this. And I'm also going to reset this over here to be a sphere or a capsule, realistically anything. But I'm going to do a sphere as it's kind of more visually appealing. So this is to chase the player. So this is going to have to be a relatively wide area. Oops. And then the attack detection, I'm going to reset that as well, has to be smaller than that, but also a relatively wide area. Because this is going to be, well, where I can shoot, right? So our mage is going to need to be able to shoot some sort of thing, right? Now, for the hand, I want to give this guy a hand, or a staff. So what we'll do is we'll create a new child here, and we'll add, I want you to actually guess what we're going to add. And because we did do this before, we need to add a bone adjustment. Attachment, here we go. And attach this to the right hand slot. Now in here, I'll just rename it to right hand. And I'm going to add our staff. So I'm going to search up staff here. And I'm going to take in the skeleton staff. That would probably make more sense. pop this into the right hand. I'm going to make it local and just drag out the mesh. All right, so let's take the transform and reset everything. And now it should follow the actual animation of the skeleton. Now in the animation tree, we will assign the animation player. But now we might have a problem, right? Is that the attack obviously is melee, and I don't want that. So we'll change this animation to the casting, which we'll have to find. So we have two-handed range. Here we go. We have two-handed range aiming and everything. So here's the shoot. So this is the attack. So now let's play this and play the attack. Okay, so two-handed ranged. Let me just check what I have. Okay, so I have the spellcast. Look, search up S. All the way at the bottom, we have spellcast shoot. There we go. And then the idle combat, I'm going to change that to spellcast raise. Maybe spellcasting. Yeah, sure, spellcasting. It'll kind of sit there idly. All right, so there we go. So there's our idle. We have the same idea, right? He awakens. We can run towards the player and then attack. And then, of course, the kind of idle combat. All right, so now what we can do is start adjusting some things. Now, one of the things that we're going to kind of need is we want to add a timer. So let's close all this. And we want to add a timer. And this timer is the shoot timer. We'll call this shoot. Now, I'm going to attach this to my script. But first, we actually want to do a few things, which first we'll rename the mage skeleton to mage skelly. And the script, we actually need to change this. So I'm going to remove this script. And I'm going to find my other mage script that I just made. So I'm going to search up mage. At the bottom, we have this new mage skelly script. I'll attach this. And this is our new script for this, right? So in here, what we can now do is we can also go into the state machine and make sure here that we change this to range. So this is not too hard because the path is just slightly different. It's just AI range instead of AI melee, right? Okay, so that's the states. The state is pretty much the same, right? Because we have the idle, run, attack, death. It's almost the same. We just have to adjust the attack. Right? So the attack, that is where we will create the projectile, which we don't have yet, but we'll set it up so that we can eventually do this. Now, one thing I'm going to do is I'm going to, actually, I already know the position, so I'm going to just tell you. Now, one thing we want is a way to aim. Now, the way we usually aim or have a certain position is using a marker 3D. This is a very good way, it's kind of reading it, generic 3D position hint for editing. In our case, we're not editing, but we're going to use this position to be able to know where I'm going to add the fireball. So my position is going to be 1 point that, 1 point that, and 0.25. Now this is where the attack will be for our attack spell. You can see here, that is where he will hit, and it will spawn right there. Okay, so that's where we want to spawn the fireball, right? Now, I kind of know this because I did this beforehand, so that's this exact position. Of course, if you want to figure this out yourself, what I would do is go into the animation player and pause it on the very specific frame and do that, right? So then you would be able to adjust the marker wherever you'd like. But of course, you'd have to turn off the animation tree and do all that stuff. Okay, let's now connect the timeout for our shoot. And for this signal, I'm going to actually change the timer to be 2 seconds. And then in the shoot function at the bottom, we're going to now implement the shoot functionality. Now the shoot functionality for the monster is going to be a little different because on the timeout, there's a few things we want to kind of check for before we actually shoot. So what I'm going to do is I'm going to create a shoot function that is separate to this. Now, in this shoot function, I'm going to say get node animation tree. Or actually, I believe we can just travel. What was the way we traveled? Let's see. Travel. Oh, okay, we didn't travel. So we're going to want to travel ourselves in here. So we can say get animation dot get parameters slash playback. And then we can say dot travel to the attack. Now this way we can actually travel to the attack state. Okay, now what we want to do is we want to await the animation a little bit. We don't want to wait for the entire animation, but we want to wait 0.3 seconds for basically the monster to show his thing right here downwards. So it takes 0.3 seconds. So what we'll do is we'll say await get tree dot create timer 0.3 dot timeout. All right, so now we actually want to get the position of the player. So we can say target position is equal to the player dot direct global position minus the self dot global position. There we go. And we're going to normalize this. So we'll say dot normalized. Now we want to actually create the fireball, which we don't have yet. So we'll just say create fireball. And then we'll continue for now. So now what we can do is we can say await the timer, the tree. So we can say get the animation tree, and we will wait for the animation finished. Once the animation is finished, then we're going to travel to the idle stand, which is in our case, the idle combat. So let's make sure we travel to that at the very end, right here. So at the end of our attack, we'll travel back to the idle combat. And now we can finally just say get node, or sorry, not get node. We can check to see if the player is still in our current attack range. And we can do that by getting access to our area 3D, which is this one. We can get node. We'll just say get node, attack detection. And the basic idea of what we're going to do is we're going to check to see if the player, the object player, is still in the area. And we can do this by calling a function called get overlapping bodies. All right. And now this will check for us to see if the player is still in there. And if it is, then what we can do is say get node, shoot the timer, and then start it again. Okay. All right. Now in this case, now what we need to do is actually create the fireball, right? Because we don't have that yet. So let's take a look at how we can do that. All right. So in this part, we need to now set up the fireball. So to do this, what we're actually going to do is we're going to find our torch, and we're going to actually duplicate this guy. We will duplicate. Here we go. And we'll call this fireball. And we're going to drag this into our monsters. And we're going to take our, oh, didn't drag in properly. There we go. And one more time. We'll open this up. And all we need to do is delete the thing. And I will delete the light as well. And then I'll take the particles. And I'm going to reset the position. And lastly, I'm going to decrease the velocity. So basically, I want to make it a little smaller. Let's go into the process material, go to this, and we will set the spread a little higher. Yeah, so that's not bad. And then we can set this to maybe 2. Yeah, that's pretty good. Even 1 is fine as well. So 1 or 2, and we can set the spread a little higher. And there we go. There's our fireball. Let's actually open it one more time, rename this to fireball. And let's save, head into our mage here. I'm going to go into our script at the very top. I'm going to copy this guy right here. Go to the next line, and I'm going to preload these fireballs. So let's make sure we take this out and say fireball and pop that in. Now, obviously here, I'm going to have to rename this to fireball. And now what we want to do is we want to shoot the fireball. Now, okay, the fireball, though, is going to need some functionality and a script of its own. Right? Now, the question is, what do we need in that fireball? So, okay, in our fireball, we're going to need a script. So let's add a script. And the fireball, we will create it to be, let's actually just add the script first. Actually, no, let's not add the script because I want to change this base to be an area 3D. Because I need it to be able to detect, well, if a player hits it, right? Okay, so now what we can do is in our fireball, we can add a collision shape 3D. We'll add a sphere and make it relatively small, like so. I can just Okay, I'm just going to adjust it like this. We'll say 0.024. Okay, good enough. Like that. And now I can make my script. We'll add this into the scripts. I can add it in a new folder. Actually, we'll add it into the monsters. We'll add it here. Yay. And here we go. Okay, so now we'll connect the body entered. And if it does enter, what we want to do is check to see if body is in group layer. If it is, then we want to hit it, right? Now the question is, how do we hit it? Well, we can hit it, right? It's easy. We already have the function. But what do we put in here, right? What number? Well, I'm going to put in a damage number, but we don't have access to the damage from the skeleton from here. So what we can do is create a variable damage int, and we'll set it to 1 by default. Now there's a few other things we'll need. One is going to be the direction, which is going to be, well, the direction the fireball goes in. So it's going to be a vector 3. We'll also need a speed, and I'll set this to default 1. We're also going to need a owner name, or we can kind of just duplicate the owner name, as if you ever want to implement this to be kind of if the mate or the player shoots a fireball as well, this will also help with that, right? So now we can say owner name is player by default. And then lastly, no, actually that's it for now. Okay, so what we'll now do is in our body hit, we also want to check to see if the monster is in owner name.name. Actually, owner name. We don't need the name part. All right, and now that's kind of it. Now, the only other thing we need to do is we want to pass through all these things and actually add functionality. Now, to create or to make this move, it's not that hard. We'll just create a physics process function. Let me close all here and save. I'll open up my fireball one more time and open up the mage, so that way I have access to these two scripts. All right, so now in the physics process, all I need to do is say self.position plus equals direction times speed times delta, and that's it. Now for the hit though, of course, I'm going to also need to self queue free. What I'll do though is I don't care what I hit, so I'm going to destroy, actually no, I do care. So we'll destroy it only if I hit the player for now. Okay, what else do we want to do? Well, in our mage, we can now create our fireball at the very bottom, where we go over here and say fireball scene dot is equal to, actually fireball temp is equal to fireball scene dot instantiate. Once we instantiate it, what we want to do is change all the variables we just added, right? So we'll say fireball.temp is equal to direction equal to target position, right? Because we already have that. That's easy. We're going to have an error there. We need a space. Now what we can do is edit the speed. We can say speed is equal to 3. We can say the owner name is equal to monster. We can say the damage is equal to self.damage. Right? We're going to pass through the damage of our skeleton. And then finally, we're also going to say the global position is equal to get node marker. What was it called? Take a look. Marker 3D. We can rename this to aim. And let's head back to our script here. Say aim dot global position. So this will put the fireball at the aim position. Okay. All right. And then lastly, what we can also do. Now this is kind of more for arrows. In our case, the ball is literally a ball. But one thing I will usually do for projectiles, I'll just kind of put it in here for you, is to say look at direction or target position, I suppose in this case, target position. Okay. And now what we want to do though is add the fireball. So we want to say all this. We don't want to do that. We want to say add child fireball, right? But okay, now where do we add the fireball? Well, in our level 1, I want to add a new node in here that will hold all the projectiles. So it'll be a node 3D. I'll say projectiles. And in the skeleton, I'm going to go all the way down. And this is the wrong skeleton. So let's actually make sure we add the mage skeleton in their scene. Mage skeleton, here we go. Oh, I accidentally moved it, it seems. Okay, let's make sure that it's in the right place. Okay, so I moved it in this scene. All right, there we go. Sometimes it gets a little laggy and can bug out a little bit, so make sure that we have everything properly. Here we go. Drag it out, right back to the script, and we'll pop in the projectiles node. We'll say get node, projectiles, and we'll add the child there. All right, there we go. So now we can add the child to the projectiles node, right? And yeah, so let's take a look if we can get this working. So what we'll do is we will take our skeleton and we'll move him over here, and our mage is over there. So let's take a look if we can try this. Let's see what will happen. All right, so let's get closer. He should get up and run towards us, and he's not. And we even have an error. Let's take a look at what the error is. It's saying node origin and blah, blah, blah are in the same lookout. It is saying the position failed. All right, so it seems that we didn't give it access to the player properly, so we might have to do that. That would make sense. So in here, we'll say, we'll connect the player. There we go. Try one more time. All right, so let's get closer. He should get up, and then he should chase us, and he should shoot, but he doesn't shoot. Why? That probably makes sense. Well, because in our animation or in our script here, we never actually called this function, which we want to do right here. But before we do that, we want to say if is instance valid, this one, player, then we will shoot. But another thing we want to check for is same thing right here. We want to check to see if I'm in the player overlapping bodies. Because if I get into the attack and I leave, then I don't want to start shooting right away. I want to chase him again. Okay, let's take a look. Okay, so let's try. Here we go. He should chase us and attack, and no fireball is shot. Okay, so let's take a look at what's happening. Let's go to the projectiles and see if we can find the projectile being shot. Okay, so no projectile is being shot. So let's take a look at if we can debug this. All right, so what we'll do here is we'll say else print not in range. So if this is the case, then that's a whole other problem. So let's take a look at if that is the issue. Okay, so let's take a look here. Okay, so it did not print anything. So it should have worked, but it did not. So the problem is not here in the shooting. The shooting function is being called, but something here is happening. So let's take a look at our script here and see if we can figure out what's going on. Okay, so the problem was actually a very small thing, which is in the attack state of our monster here, we need to make sure that we say AI controller.getNodeStart and shoot or actually start the shooting to the node. So we actually want to start the node that shoots. Now, if we close this and hit play, yeah, we can try shooting, because the problem was that the shoot would only happen if the timer ran out, which never started in the first place. So here we can see that he will shoot again, and I die. All right, now the problem, of course, is that you saw it doesn't shoot the first time. So here we can also just call the shoot function the first time around. And yeah, so we can actually take this out, I believe. So we can try this first, give this a try. And we should be able to just go in, and he should be able to just shoot at us. And there we go, we just died. Now we can try one more time to see if he shoots more than once. If he doesn't, then I'll try. All right, there we go. Pretty good. And I'm dodging it like a pro. All right, so that's pretty good. It doesn't seem to be the smoothest, but it is a relatively good working AI. So I will encourage you to kind of adjust it to whatever you want, as this obviously isn't a perfect AI ranged. It's kind of a little bit slapped on top, basically, for what we already have, and just kind of slapping it all together. So in the next part, we will take a look at, I forget, but we are going to take a look at something cool. So I'll see you on the next part. Okay, welcome everyone to this part. In this part, we'll be creating our save and load files. So we're going to take a look first at something called file access. This will essentially be our file save. So this will be where we save things, stuff like that. Okay. So our main goal is to be able to save our inventory. Now, the other things like player position, stuff like that, I'm not going to worry about that. I'll kind of let you do that. I'll let you kind of figure that out on your own. But I'm going to hopefully assist you with the general gist of filing access. Okay, so to do this, we're going to create a new global variable or new global script, and I'm going to call this utils for utilities. I'm going to auto load this, so that way we have it global. Go to scripts, global, utils, and load it. And now I'm going to close all, open my util script, and pop this out. Now in here, we're going to have a few, just two variables. The first one is constant save path. This is going to be the path that we save in it. Now this is going to be a string path, string, and we're going to say equal to res colon slash save game or save game bin. Actually, sorry, dot bin. Yeah, there we go. And now we'll have a save pass, like so. This will also be a string, and this will be equal to some sort of password. I'm going to put password. That's fine as well. All right. Now, so I actually don't think we're going to use this one. So sorry, I'm going to delete that. Never mind. So we're not going to be using a password encrypting for this part. So let's create our save function. So we'll save game, and this will be a void function. So I'll return void, and I'm going to create a load game as well. That will also return void. Now, for now, I'm going to pass. And here in the save, let's get started. First, we want to create our file. To create our file, we can say file is equal to file access dot open save save path, and then we're going to path through file. So we have a few options now. We have file access dot either they showed up just a second ago. Read write, and write read. Now in this case, we just want to write over our script or our file here because we're saving the game, right? So we're going to save, meaning we're going to write. Okay, now we want to make the dictionary full of data. So we'll create a data, which will be a dictionary. And this is just going to be an empty dictionary, like so. Now what we'll do is we're going to find our inventory and essentially take all the information and load the name into the data. So what we'll do is we'll say equal to get node. We're going to find it this way. So we're going to say root. So root will start at the very beginning. So if you want to find out how you get yours, if in the remote, it looks like I have to actually get rid of that error. So let's go to the script here, and let's just delete all this for now, and we'll close. I copy X'd it. I'm just going to show you how to get the inventory from the remote. So here, the root is how we get access to the root by saying /root. Now what we're going to do is we're going to get access to the inventory by going to level 1, GUI, and then inventory. Well, container and then inventory. Okay, so let's copy paste that again. Now what I'm going to do is I'm going to put this right here. So let me bring this out. Let's make sure that we have the colon there. So here, we're going to get the root, level 1, GUI, container, and then inventory. And then if we get any errors, it'll tell us if it's wrong. Now, another thing that you could do is, I don't like to do this, but you should do this in an actual game, is there is something called has node. So I'll show you what it is. So what you can do is say has node. Then if it does, then we can do all this stuff. But I'm just going to remove this. I don't really want my code to be messy in that sense. All right. So now what we can say is for I in the inventory dot get child 0 dot get child count. This is the grid essentially that we want to check, right? We want to get how many children are in the grid. So we need to make sure that the first inventory or the first thing is the grid. So let's make sure we go into our inventory here. Sorry, that's our profile. We'll search up our inventory. There we go. So the grid is the first one. So make sure that grid is the first child. Okay. So now let's head back to the script. Pop this out. Utils. All right. Now in here, what we'll do is we will now for loop through the inventory, and we want to basically check to see, or not check, but we want to basically add all the items from our inventory into the save file. So we're going to check to see if the inventory, inventory.getChild 0 .getChild I get child count is, you probably guessed it, is greater than 0. Because this essentially means there is an item inside of the slot. So we're going to loop essentially through the slots, right? This is kind of going through each slot and finding out if there is an item in it. Now, if there is, we can say the slot has an item. And if it does, we'll say variable item data is equal to inventory.getChild 0. We will get child I, and then we will say dot data. Okay, so that's the data of the inventory slot, right? Now what we want to do though is we want to say data item data dot item name is equal to item data dot count. Now the reason we're doing this is because the data here, the dictionary, is we're going to fill in this key. So this is a new key that we're going to add into our inventory. So this is essentially how we add into our dictionary. All right. So this essentially takes all our inventory and fills it into this data. All right. So now we can finish this save file by saying gstr is equal to json.stringify. And we're going to stringify the data. And lastly, we will say file.store line, and we'll store the JSTR that we just created. Okay, this is it. This is our save file. It's pretty easy. It's a little more hard than you would imagine just because we actually have to go through the inventory here. But this is specifically for the inventory, okay? So you might actually even want to rename this to inventory save game, but I'm not going to go through the whole other stuff. So I'm just going to be doing the inventory. I'll let you kind of figure out like other things that you may want to save. Okay, so now the loading, it's not too hard as we're going to load the file, but this time we're going to read. So we're going to read the file. And now what we can say is if file access file exists, then we'll look for the save path. If it's true, then we can actually fill in our data, right, our information that we want, right? So if it is true, not true, then we'll say if not EOF, so end of file, or file.eof reach, there we go, then we can start filling it in. Now what this will do is essentially kind of loop. It doesn't really loop, but it goes through each line, each file of the line, and we'll be able to access each line. Now how do we access each line? We can say variable current line is equal to json.parse string, and then we'll say file.getLine. All right, so there we go. We have access to the lines inside of our JString that we created. And now what we need to do is, for I in current line. So, and then we will say for item count in current line at position I. Then we will say inventory dot add item at string of I. So the string I is essentially the item name that we stored over here. And we're going to loop through the item count to make sure that we get the right amount of counts in our inventory. Now the problem is we need to access the inventory, so we can just copy the inventory path right here, and we'll put this right here. Okay, now another thing we want to do though is say if current line, then we will do all this. Because otherwise I don't want to be doing this. Now another thing we'll do is right before the file, we'll check to see if file, not file, then we'll just return. Another if condition that I like to put is if file is null, then we'll also return. This just allows us to double check that the file is not empty. I usually put this one because sometimes I've had cases where this does not pick it up, but this does for some reason. It's just kind of a weird Godot thing, I suppose. Okay, this is pretty much it. Now to save and load, it's not too hard. All we need to do is find a place to save it. Now I'm going to do this. Let's close this. I'm going to do this in our, let's go to our script here. Control-Shift-F to find in files. I'm going to find the place where I pause. It's right here in our GUI. And right here, every time I pause the game, I'm going to save it by saying utils.savegame. Now, load the game, of course, we're going to need to figure out where do I load it, right? Well, usually you would do this in the beginning of some sort of ready function. So we can do this realistically anywhere. I'm going to do it in the main. So here, in the level 1, I'm going to add a new script. Scripts. We'll add this to just our regular file, I suppose. Create. And here we can call utils.loadGame. And now if I hit play, it might error the first time. Okay, it doesn't. Very cool. Okay, so if I hit pause, it is telling me that the data, I can't save it. So it's probably telling me that the path is wrong. It's going to tell me invalid get index on data on the inventory slot. Okay, so it's telling me the data is wrong. So the inventory is probably correct. So let's make sure that the inventory path is correct by going in here. Okay, so we can double check the path is correct by going root, level 1, that's right, GUI, it's all capital, container, lowercase, and inventory, there we go. Okay, so the inventory is correct. Let's take a look at the item data. Okay, so the item data is get child. Okay, I see. So right here, we should be getting child one more time, getting child 0. So we'll copy this right here, and I'll put this right there. So we want to get child 0 dot get data. Okay, so now let's try this. All right, that should have saved the game. So let's actually kill something and see if we can pick it up. Okay, so we have some new items here. Let's close the game, hit play, and see if it loads. All right, so the potion is saved, but it seems the swords and stuff did not save. So let's take a look if we can figure out what's going on. All right, so what we'll do is inside of our res files here, we can actually find the bin, and we can find that the body armor, longsword, and potion are right there. Now the issue is that the count is at 0. So if we change this to 1, we should actually be able to hit play, and we can now load in our items properly, as you can see. Now, there's obviously that little bug there that I'll kind of let you fix, but the other issue is the actual count. Now the count, you may imagine by now, is that we need to set it to 1, even if it's not stackable. So for the body armor, we'll set that to 1. For this, we'll set that to 1, and this is already set to 1, so that's good. All right, so that is pretty much it for our save and load file. That should work for most cases in the inventory. Do keep in mind that the item name does have to be the same, otherwise it won't work, specifically when it comes to the global variable. So when we have our game, this right here, it has to be the same name, right? Because this is what we're using to access the items. So this needs to be the same name as this, all right? Okay, that is our save and load files complete. I will see you all in the next part. All right, one of the last parts that we're going to do before we start heading into the juice part of the game is we want to now spawn monsters. We want to start spawning the monsters in the ready function inside of the level. So we're going to head into this script here, and we're going to load both of the monsters. So first, we're going to say on ready variable warrior scene, and we'll preload the warrior skeleton. And now we could copy just, I'll just say packed scene here. There we go. And I'll just copy paste this like so, and I'll change this to mage. And of course, I will also change this scene to mage skelly, mage skelly. There we go. It's the first one that pops up. And now we're going to create a while loop to load these in. How are we going to do this? Okay, so what we're going to do is we're going to create a we're actually going to create a new node, and we're going to get a few errors here. I'm going to put the monsters in here, and I'm going to pop this in, pop these in, and why don't we fix these errors first, so that way we can, yeah, there we go, there's one. Okay, so this one will need to go up one more, And I believe the rest should be good. Now, if we hit play, here we go. We can now shoot again, and it should be working. Okay, now back to the level script. What we're going to do is we're also going to get access to our grid map. So we'll load that and say onReady variable, grid map, and say equal to get node, grid map. Okay, and the reason we're going to do this is because we're going to do two things. First, we're going to say while the monsters, well, we have to get this node, so get node monsters dot get child count is greater than, or sorry, less than 10, then we're going to add monsters. We're going to keep adding them until the child count is less, at least 10, right? So, okay, now what we can do is we can say variable x position, x position. Here we go. And we're going to randomize this position. So we're going to say randy range between -40. Actually, let's find out what the range will be because it might be a little different. Okay, I lied. We don't actually need to know because of what we're going to do. So we're going to create the random position between -40 and 40. We'll do the same for the z-axis. And now what we'll do is we're going to create our monster temp as a variable, but not give it anything yet. We're going to also now randomize the spawning between the two. We're going to pick between the warrior or the skeleton, right? So here I'll say between 0 and 1, and I'll just check to see if it's 1. If it is, we will say monster temp is equal to warrior scene dot instantiate. Otherwise, I'll do the same thing, but instead I will load the mage for this one. So this way it's like a 50-50 of which one we're going to spawn. Okay, now the question is, how do I know I'm dropping my monster on top of, well, a scene, right? Like, what if I drop it in a wall? Well, I don't want that, obviously, right? What's another case? Well, what if I drop it not on anything, right? I could drop it outside of the world. So there's a way that we can actually do this, which is we'll access the grid map. So we can say if the grid map dot get cell, it's called get cell item, then we can pass through the position. So the position is vector 3, we'll use 3i, and we'll pass through the x position that we created. We'll pass through 3, and then the z position that we just passed. Now, if the cell item is equal to 3, then we will spawn the player. Now, the reason we're looking for 3, I might actually be wrong on this one, so let's double check together. We will look at the grid map, and the reason is because if we look at the cell, or sorry, in the library, number 3 should be the floor, which it's not. So in our case, it's going to be 0. So in our case, we'll have to look at number 0. So if it's 0, then that means it's on the floor. So in that case, I will add it to my world, right? So essentially, I'm going to check to see if I'm on a tile, a floor tile or not, right? So this allows me to check if I'm on a tile, and if we are, well, what do? We just say monster temp dot position is equal to vector 3 x position 3 and z position. And lastly, we can, of course, we need to actually assign the player variable, right? Because that player needs to be assigned. Of course, I exported it, but I can also just assign it through code by saying, get node player. Okay, and lastly, we can now say get node monsters, add child, and we will add the monster temp. Okay, so this should work. So let's close this, hit play, and hopefully it doesn't cycle, and it looks like it's cycling. So we might have a problem. So let's have out here, let's go into our remote. Okay, so it seems like nothing's being added. So something's going on, something not good is going on. So let's take a look at our code. Okay, so if the child count is less than 10, that's right. Then we'll do all this, randomize it. If it's 1, here for now, what we'll do is we will just say it's equal to the mage scene. So we're not going to randomize which monster it is. And then the get cell. Oh, this one should be 0. I don't know why I put 3. Okay, so actually let's remove that and try 0 again right there. This will be 3 because I want to just put it above the ground to fall. Okay, now let's try one more time. All right, there we go. We ran the game, and we can now see a bunch of monsters in our game. And we can see if we run around our world here, or our little dungeon, we have a bunch of monsters. And we have different monsters too, which is very cool. So, yeah. Now, of course, you can also randomize other things. Okay, so the AI controller seems to not be working here, actually. Okay, so what was happening? The player might not have been assigned properly. So let's go back to our scene here. Get player. No, that should be right. Player. Okay, we'll take a look at that in a second. But one other thing I wanted to note is you can, of course, also randomize other things, like, for example, the rotation, right? This could also be randomized if you'd like. So you can say randy range between 0 and 360. That can also randomize the rotation. But now let's take a look at the bug that we had with the player. So let's take a look. Monster temp.rotation. Okay, yeah, we'll remove this for now because I don't want to figure that out. But it is something that you can do, so I'll let you just kind of explore that on your own. That you can, randomize the rotation. All right, so let's debug the mage. Let's see what was going on in the player. Okay, let's see if these monsters have a bug first. Okay, so the AI controller doesn't seem to have. Oh, okay, so I see what I did. Okay, so the shoot is in the wrong attack state, so I need to cut this, and I'm going to go to attack and make sure in here that is where this is, and in here there's not that. And I need to make sure that I need to go into the. Okay, I remember what happened. Okay, so in the warrior, let's open the warrior and open the mage. I'll kind of go over what the problem may be. Okay, so the problem was, and is, I'm assuming, is here the state controller is using the wrong one. So the mage, technically, this is right, but this is the wrong one in the sense that over here in the AI mage, I did not assign it the proper state machine. So here, I can drag this in to the state machine, right? And this script over here uses the melee, which is the right one for the melee one. So here, I'll actually copy this, put this into this state machine, and cut this, and put this in here. So now we have to make sure that the state machine inside of the mage uses the ranged one, and the warrior skeleton is using the melee one. Okay, so now let's give this one more try. Let's hit play. And let's take a look at what we got. All right, let's see if you can shoot. Okay, the shooting is good. Okay, I died. Let's see if we can get a warrior skeleton to hit me now. That's a mage. That's also a mage. And okay, here's a skeleton. Here we go. Let's see if he attacks. Okay, he does, and he killed me. All right, cool. This is a relatively cool game. Now we can finally start moving into a bit of the juice inside of our game, which will include many different things. So we'll have a surprise for you in just a minute, but we'll also have, some sound, some cool particle effects, and stuff like that. So we'll also be going into shaders inside of Godot, and I will see you all later. All right, welcome everyone to this part. In this next part and section, we're going to finally be working on juice. So to juice our game up, we're going to basically add a few things, effects, stuff like that. And the first thing we'll add is sound, because sound does actually, help with the ambiance of our game a little bit. So let's head into our player and item object, and let's take a look if we can find our mini fantasy dungeon SFX packs and see if we can find anything useful. So here we have human attack, so that could probably be useful. We have a few sound effects for these swords. Now, I would definitely recommend you just look through them and see which one you want. So the first thing we'll do is in our player, we can add a new sprite here. And the sprite we're going to add, or the node that we're going to add is an audio streamer. Now, there's a few different ones. The main difference between most of these is that the 3D is the positional. The 2D is also positional, but obviously in 2D space. And then we also have audio listener. Now, we're not going to go too in depth for the audio listener, but you should definitely look into audio listening for a more complicated game. Adding really not complex sound, but more fun sound can definitely be helpful. Now, audio listener essentially overrides the location that sounds are heard from. So if you're in a certain position or on a certain side of a sound, you can hear it from one side of the headset. So we're going to add an audio stream player. And just to kind of emphasize my example, if you had your listener, let's say over here, and your sound is coming from over here, then you would hear it in your right side, right? Your right headset. So that's kind of the cool part about the listener. Okay, so we have here the stream, and now we can find whichever one we want and just drag it in. And that's pretty much it. This is how we set it up. So now we can if we want, we can start playing these sounds. And yeah, that's pretty much it. Now, one other thing I'm going to do is I'm going to add a sword and a hit effect. So the first two effects we're going to have are literally just one called damage. I'll duplicate this and call this one hit. Now, this one I'm going to call the sword hit, or not call it, but I'm going to bring in this one in, and that's it. Now what we can do is in our script, we can find where we're actually playing the, or where we want to play this stuff, right? So the first part we want to play is probably the hit. So this one will start the player hit. So here we can say get node hit dot play, and that's it. So now all we need to do is now do this again for the sword attack, right? So either we have two options. Either we can hit or add this sound effect to when I actually collide with something, so that would be here, or I can do it when I actually attack, which would be right here. So it's up to you. I'm going to put it when I actually hit something. No, actually, I lied. I'm going to put it when I actually just use the attack. So I'll put it right here, right before that. And then here I can say damage. All right. So now if I close my script, I'm going to turn my sound on so you can hear this. Now I can hit play. And we should be able to now hear sound. So every time I attack, there is a sound. And every time I get hit, so let's take a look if we can get hit here. Okay, there we go. So obviously that was a sword effect. So maybe you might want to differentiate between if I'm getting hit by a sword or getting hit by a mage thing, right? So it's up to you. I'll let you kind of figure that out on your own time. But yeah, so that is kind of it for our sound, as we don't really have anything else that will help us too much. We have some cool effects here that maybe we can add to the item object. So might as well actually add it. So we can do this, and I would suggest you actually pause the video and try this on your own, because at this point, you should have enough experience to be able to do this on our own. So here we're going to rename this to pickup. I'm going to go into my script, and whenever I body entered here, before I self queue free, I will say get node pickup dot play. But of course, we'll need to give the pickup a audio. So let's go in here and we can give it whatever you'd like. Of course, if you have your own audio that might be better than this, go for it. The stack open obviously probably doesn't fit this too well, as that doesn't really sound like a pickup sound, but it works pretty nicely. So we should be able to go into our game, and let's take a look if we can kill something. So, okay, okay, we have one problem here already. So I believe the death warrior here, the objects is one up now, so we have to go one more up. So in our error, where is it? We have to go one more parent up. So there we go. And one more thing that we actually want to do is, and then what I want to show is in the pickup node, there is going to be a problem, which is that this sound won't actually play. Now, the reason is because we're self-queuing free right away, right? So we don't want to do that. We want to wait for this to finish playing. So there's two ways to do this, of course. We can either use an await function, or what I can do is I can connect the node, finished, like so, and then I can just self-queue free. Now here, what I'll do though, is I will hide all of these, all the meshes. So whichever mesh that I am using, it won't matter. I'll just hide all of them. And here we go. Actually, this is silly of me. Why would I do this when I can just hide self? That makes more sense. So now here we'll just say self hide, and then we'll play the sound, right? We'll play the sound, and then when that sound is finished, then we will self queue free. So okay, now let's test this to make sure that everything's working. Because the item pickup also erred. So let's take a look if we can kill some things. Let's go over here. I'm going to equip a weapon so it's a little faster. All right, there we go. We killed him. And yeah, there we go. So now we have our items being picked up. I can use some. I can equip some items here. And vice versa. Yeah, so there we go. And I can kill that guy. And I will have to fix that there too. So do that. And that's it. All right, so that is the sound effects tutorial or section. Now, in the next part, we are going to be introducing someone new. So let me just introduce him. All right, so now we have Lelu to introduce us to shaders and cool effects. So Lelu is a really cool other YouTuber who creates and is kind of more specialized in shaders and such. And you should definitely go check him out. Check out his channel. He has a lot of really cool effects already. So he has some cool trail effects that you can add to your game, some portal effects, some cool weapon effects here. You can see it over there. Right, so definitely check out his channel. He's really, really good. Has a lot of much better effects than ours. As you can see, the fire might actually look a little better than mine, the one that we made, as ours is much more simple. But yeah, definitely check his channel out. And now, without further ado, Lelu will now introduce you to the rest of the effects that we'll be adding. So, yeah.
Hello guys, I am Lelu, and today we are going to see how to create two important effects that you can see in almost every RPG games: level up effects and buff effects. These effects will improve a lot the atmosphere in this game and helps the player to really feel a progress in the game, rather by leveling up or killing monsters. We will use the Godot's particle system and some visual shaders to create these effects. So let's start with the level up effect. This tutorial will be divided into three parts. First, let's create a basic aura effect using particles and a visual shader. Then, let's improve this effect adding an expansive wave. And finally, let's add some extra details and coordinate all the effects. Okay, let's go ahead and start creating the basic aura effect. So for the level up effect, we first need to create a very simple mesh. So let's go to Blender and let's delete this and Shift A to create a new cylinder mesh. I want this cylinder to be on field, so set this option to nothing. So let's go to edit mode by pressing tab, move this cylinder up and stretch it a little bit. And finally press W and select Shade Smooth. Okay, so this is the cylinder. It's a simple long cylinder. The only difference is that the pivot point is at the bottom of the cylinder. So let's export this, File, Export, OBJ, and let's name this cylinder long. Okay, so we are back in Godot. Let's import our cylinder mesh. And I want to go ahead and create a new particle system, a GPU particle system. And in order for these particles to work, we first need to create a new particle process material and also in raw passes assign a mesh to be used for the particle system. In this case, I will use the cylinder. And as you can see, we have a lot of cylinder meshes falling down. This is because of the gravity. So let's go to the particle system, into accelerations and set the gravity to 0. Also, I only need one cylinder, so set the amount to 1. And let's change the size. So let's go to display, scale, and set a scale of 4. Cool, this will be the area effect for the level up effect. Oh, by the way, I don't want this cylinder to cast shadows, so let's close this and let's go to geometry and set cast shadow to off. Also, we need a material for the cylinder, so let's create a new shader material here in material override, and let's create a new shader. I want this shader to be a visual shader. Let's name it shader cylinder aura. So let's open the shader, and I want to do some changes. For example, I want this shader to be the cool mode to be disabled, so we can see both sides of the cylinder. Also, I want this material to be unshaded and disable shadows. Cool. So let's start creating the shader. For this shader, first I want to add a gradient. So right click and create a new texture 2D, set it to color, and select gradient texture 2D. So let's edit this gradient. I will pick these little points because I want this gradient to be vertical. And yeah, let's now connect the gradient into the alpha channel, and we can see this little line up here. So in order to fix this, let's modify the gradient a little bit, like so. Yeah, this is perfect. Cool, so we now have this gradient connected to the alpha channel. We also need a color, so right click and create a new color fragment. Let's connect the color, and also let's connect the alpha from the color. Oh, we cannot connect it here, so let's multiply the alpha channel from the color with the gradient. Cool, so now if we go to the particle system, we go to display in color curves, we can pick any color we want for the gradient. Let's pick, for example, a yellow with a raw value of 2.5, 2, and 0.5. A very strong yellow. Also, I want this cylinder to disappear over the time. So let's go to alpha curve. Let's create a new curve. And I want this cylinder to be transparent at the beginning and at the end, like this. Or maybe something like this. It goes from transparent to full opaque to transparent again at the end of the cylinder. Cool, so we have this interesting effect, but we can make it look even more cool by adding some special textures. So for example, here I have a lot of textures. You can use any texture you want. The important part is that the texture needs to be repetitive. So let's pick, for example, this noise texture. And I want to add this texture to the gradient. So in order to do that, let's pick the texture. This is a black and white texture, so we don't need to pick a full color, just one channel. And multiply this texture with the gradient, like this. So now we have this special texture attached to the gradient. We can also move this texture over the time. So in order to do that, we need to create a UV panning node. With this, we can move the texture. And we also need to create a time node. And if we connect the time node into the offset, see how the texture is moving. Very simple. I also want to control the speed of this texture. So let's create a new vector2 parameter. Let's name it, for example, speed. And let's multiply the speed parameter with the time node. And nothing changes, and this is because we created a new parameter. So let's go to the particle system, let's go to the material. Now we have these shader parameters, and here we have the speed option. Let's put a speed, for example, of 1.5 into the x-axis and 3 into the y-axis. Let's do one more change. Let's say instead of using this noise texture, we want to use any texture we want. So let's delete this noise texture, and instead of that, let's create a new texture 2D parameter. Let's name it aura texture. Set it to color. And in order to use this texture, we need to sample it. So let's sample this and connect this texture. So now if we go to the material, we have the aura texture property, and here we can set any texture we want. Let's see, for example, this noise texture, or maybe this one. So feel free to try using different textures, any texture you want, just to make sure that the texture is repetitive. I will also upload these textures here in the description in case you want to use them. But anyways, the shader is completed. So let's go back to the particle system and let's do one last change here. Let's go to scale and create a new curve XYZ. And I want this cylinder to grow slowly up. So let's go to the curve of the y-axis of the scale. And I want this cylinder to slowly grow from 0 to 1. So we have this interesting effect. Cool. The aura effect is completed. Now let's create the expansive wave. Okay, so let's name this particle system, for example, aura cylinder 1. And I want to duplicate this cylinder, so Ctrl D. Now we have the aura cylinder 2. And I want to do some changes to this new cylinder. So let's go to the particle process material, and because this is a new particle system, we need to right click and make unique, and do the same for the material, right click, make unique, so we can change only this new cylinder. Let's go to display, scale, and I want this cylinder to be even bigger than the last one, so let's set a scale of 8. Also, we can go to the material, into shader parameters, and change the texture for this cylinder. For example, let's use maybe this texture, and set a speed of 1 and 3. Also, let's go to scale, and I don't want this cylinder to grow up. Instead, I want it to grow into from the center and go small. So let's change the scale, and because we want to change this new cylinder scale, we need to right click and make unique. Do the same for all the properties of these particles. Make unique, make unique. Now we can edit the properties. So for example, I want this cylinder to grow in all the directions. But instead of growing up in the y-axis, I want it to go to shrink down. So let's change this curve so the cylinder goes from big to small into the y-axis. Something like this, I guess is okay. Excellent. We have done the aura effect with a nice expansive wave. Now we only need to add some extra details and coordinate everything together. Cool, so finally let's go to Photoshop or any painting program you want. In this case I will use Photoshop. And let's create a new image and put a text here. Level up. Let's move it to the center of the image. And I want this text to be white. Also, maybe we can give it some effects. So let me see. Let's go to blending options. Maybe we can give it a glow, or maybe a contour or something like that. Let's try with a bevel effect. Okay, save it as a PNG. So let's go back to Godot, and I want to create a new particle system. Let's create this time a CPU particle system and name it, for example, level up text. So in order for these particles to work, we need to assign a mesh. So let's go to drawing and let's select a quad mesh. So now we have a lot of quad meshes falling down. Let's also go to geometry and create a new standard material. Let's set the shading to be unshaded. Let's go to albedo, and here we can assign the level up text we just created in Photoshop. So let's pick the text over here. Now we can see. Oh, by the way, because this is a transparent texture, we need to go to transparency and set the transparency to be alpha. Let's also go to billboard and set the billboard to be particle billboard. So now these particles are always facing the camera, as you can see, which is really cool. Finally, for the material, let's go to vertex color and enable these options. So with these options we can now edit the color in the particle system. Cool. Let's close the material and go back to the particle system. Let's go to gravity and set it to 0. Set the amount to 1. Also, I want this to be, this is maybe too small, so let's go to scale and set a scale of 4. And maybe we can make this like go from small to big to small again. So let's go to the scale option and create a new scale curve. I want this particle to be very small at the beginning and then grow up and then go small again. Cool. Also, I want this particle to go up. So let's go to direction and set the direction into the y-axis 0, 1, 0. And let's go to velocity and set a velocity of 2.5. Set the speed to 0. Let's go to color and we can give it any color we want here. In my case, I want to use a raw value of 2.5, 2, and 0.5. Excellent. Also, I want this level up to disappear over the time. So let's go to color ramp, create a new gradient, and delete this. I want it to be transparent at the beginning, like so, and transparent at the end. Finally, let's go to damping, and let's set a value of 0.8 and 1. Now, in order to keep everything organized, I will create a new node 3D and put everything inside the node 3D. And we can name it, for example, VFX Level Up. And right click and create a new branch scene. Let's open the scene and create a new animation player so we can coordinate all the timing for the effects using the animation player. Let's create a new animation, name it default. Let's put a time of 2 seconds. And let's go to the cylinder 1, set it to 1 shot, and key the emitting option. Let's do the same for every particle. Let's go to the cylinder 2, enable 1 shot, and key do the same for this, 1 shot, key. Cool, so for this effect, let's say we want to emit all the effects at the beginning of the animation. Let's play. So as you can see, now everything is coordinated. Maybe we can put the level up effect a little bit later, like this. Let's see, let's play the effect. Okay, so let's see how this final effect looks with the character. So let's go to the level 1 and let's make this VFX editable children so we can play the animation. And let's play. Excellent. As you can see, I added these little particles. It's just some quad meshes similar to the text up. But yeah, this adds a special touch to the effect. Cool. Our level up effect is completed. Remember, you can download all of these files for free in case you want to use them or study up close. Now, let's go ahead and let's create the puff effects. This tutorial is divided into 3 parts. Let's start creating some nice particles using a simple sphere. Then, let's convert those spheres into some nice animated clouds using a visual shader. And finally, let's customize the effect so we can use it in our game. So let's start with the particle system. So let's create the puff effect. For this effect, I want to go ahead and create a new GPU particle system. And in order for this particle to work, we need to create a new particle process material and also assign a mesh. This time I will select the sphere mesh. And as you can see, now we have a lot of spheres falling down. So let's go to accelerations and set the gravity to 0. Instead of using gravity, I want to use radial velocity. So let's go to radial velocity and set a velocity between 1 and 2. Cool. Now let's create a material for the spheres. So let's go to geometry, material override. Let's create a new shader material, new shader, select visual shader. Maybe we can name it, for example, shader puff. Now let's open the puff shader and let's create some stuff here. First, we need to add a color. So let's right click and create a new color fragment. Connect the color and the transparency. Also, there is one more thing. If I move the spheres, you can see how it gets this hard edge when it intercepts with the floor. I don't want that, so in order to fix this, we can create a proximity fade node. And let's multiply this node with the alpha channel. So now, as you can see, if we get closer to the floor, the spheres disappear. It fades. We can also control the value here. Maybe we can create a float parameter. Let's name it distance fade and give it a default value of 0.3. Cool. Excellent. Let's do some changes to the particle system. For example, let's go to the particle process material, and I want these particles to scale down. So let's go to scale and let's put a random scale between 1 and 3. And let's create a new curve. And I want these particles to start big and then go small, like this. Maybe too much, maybe something like this. Perfect. And I also want these particles to disappear over the time. So let's go to color curves and let's create a new alpha curve. So I want these particles to be full opaque at the beginning, and then I want them to disappear slowly. We can also give it any color we want, but for now I will leave them white. Okay, so the particle system is already prepared. Now let's make these spheres look like clouds using a visual shader. Okay, so here's the interesting part. Let's convert this sphere into a cloud. We can do that using a shader. Let me show you. Let's go to the shader and let's go to the vertex option. Here we can control the vertices or the vertex of this sphere. This can be quite confusing, so I will quickly open my drawing board presentation. So as we know, a 3D sphere is composed by many little points or vertices, and let's say all of these points has a perpendicular vector like this. So the idea is to being able to take a black and white texture and put that texture into a sphere and tell all these points to move depending of if the point is covered by white. For example, if it's white, that's equal to 1. If it's black, equals to 0. Gray, 0.5. So we can move the point depending on the texture over the sphere. Okay, so with that being said, let's go back to Godot. Let's go back to the shader, to the vertex section, and let's do some stuff. First, right click and create the vertex. Here we have all the vertices of the sphere, and to these vertices I want to add a normal vector. Right click and look for normal. So look what happened when I connect this node here. Now, as you can see, all the vertices or all the points of the sphere move in the normal direction of the vector. We can also control the vector of the normal and reduce the size. So we can, for example, multiply this normal vector for a value. Let's create a float constant, for example 0.3. So now we reduce the size of the normal vector 0.3 units, and as you can see we get a small sphere. Excellent. But now let's do something interesting. I will take a texture. Let's pick, for example, this texture. Set it to color. And we don't need a full color because this is a black and white texture. We only need to use one channel. So I will pick this and I want to multiply this texture with the normal vector. Excellent. Now we get this interesting shape. And this is the result of this texture controlling the vertices of the sphere. We can also change the intensity here using this node. Let's try with 1. So we get this crazy shape. But for the clouds, let's put a value of minus 0.6. So now this looks more like a cloud, right? Also, I want these clouds to be dynamic, to move. So we need to move the texture. And for moving the texture, I will create a UV panning node. Also, let's create a time node and multiply the time with a vector 2 constant, and let's give it a value, for example, of 0.1 and 1. Now you can see how the texture is moving. So the vertices of the sphere are moving with the texture, which is moving using these values. Cool. So I think this is cool. I think this looks really nice already. But there's one more thing I want to do. I would like these clouds to look more stylized, more toony. So I want to change the way the light interacts with the clouds. And for doing that, I want to once again modify this shader. And this time I want to go to the light section of the shader. In this section we can control like the way this sphere interacts with the light. In this case I want this to look more anime style, more toony style. So I want to make sure that the light hits like in the hard way the mesh, and also I want to give it a nice shadow contour to the clouds. For doing that, I am going to create a normal vector, and I want to dot product this multiply this normal vector with a dot product with the Fresnel node. Let's set this Fresnel to through, inverted, and connect to the diffuse channel. And I know this might look a bit confusing. I am planning to explain this quite better in the future. I want to do a video about anime style in 3D games. But for now, let's just follow these steps I am doing in the video. Create a smooth step node. And create a float constant. Another float constant that goes between 0 and 0.1. With this we can control the hardness of the edges. And now let's create a clamp node. And give it a value between 0.1 and 1. So with this we can control how dark are the shadows and how bright are this brightness. Cool. So yeah, this is the light node. So yeah, that was it. We have the shader with all done already. We can close the shader and let's do some final adjustments to this puff effect. Set the amount to 12 and the explosiveness to 0.85. Also, I want to give it a random angle between minus 180 and 180. Let's go to position. I want these clouds to spawn in a ring position with a value of 1 in the y-axis and a height of 0 and a radius of 1. Also, I want to set a velocity in the y-axis between 0.5 and 1. And finally, we can give it a nice color. This time I want to use a color ramp. Let's create a new gradient texture. Enable HDRI. And I want to start with a really intense, strong purple with a raw value of 0.4, 0.05, and 1.2. And I want it to go to a full black color at the end. Also, we can give it another color over here with a raw value of 0.2, 0.05, and 1. That's it. We get this really nice puff effect. Finally, if we want, we can set it to one shot. And when we need to use it, we can just emit the effect one time here by clicking here. I have also added some extra details to the puff effect, as you can see. I will not dive too much into details about this, since I have already done this in the past in my heat effect tutorial. If you haven't seen my tutorial, please check it out. Basically, here I have two particle systems. One is a big quad mesh with a texture that scales down with this curve. And I did another particle system which add a bunch of quad meshes with a simple billboard texture, and this simply helps to add some more impact to this puff effect. As for the step puff effect, it's almost the same. I just tweaked some parameters. For example, I have changed the color to a white color and changed the amount to 2 particles. Also, I have set a simple velocity into the x-axis only. The puff effect is completed, and now we can customize it as we want. And of course, the possibilities are a lot, but at least you have the basics done and you can work from there. So that's it for this tutorial, guys. I hope you have learned something new today, and if you want to learn more about visual effects in Godot, please check out my YouTube channel. Thank you for watching. Bye.
All right, now that we have all our effects, hopefully you have something similar to what we have set up here. So let's just go through what I have set up so that way you don't get lost at any point. And of course, if you do get lost, just keep in mind we have all the download files down below. You can download the VFX files and you will get exactly what I have right now. So here we have 4 scenes, right? We have the VPX whatever run, we have the big puff, we have the level up, and the hit. Okay, what we want to do is now we want to import some of these into the player. So most of them, except for the level up and the puff, we're going to put this in. So the level up, we'll put this in, and we're just going to reset both of these though to 0, 0 right here. And we can make these local, so why not? Especially the puff run, that's totally fine. But for this one, we want to position right behind the player or right under the player, so that's good. Now what we can do is in the animation player, we will find the actual animation that we use for the run, right? So it's kind of up to you, whichever one you want to use. So I'm going to only put this effect when I run. So it kind of gives that more of a feeling that I'm actually running. So this one is running A. So in my animation player, I'm going to make sure I select running A. Now what we can do is, I'm going to turn off the animation player so I can actually do this. In my animation, I'm going to find a frame that I actually kind of push back. So this is where my feet go backwards. So that is one place I can emit. So here I can just emit right there, and we don't have to create a reset track. So one more step, we'll emit right there. So again, and one more right there. So 3 times we keyed it. All right, and now if we scroll all the way to the bottom, you will see all these keys. Now, obviously, all of these are false, so I don't know why I did that. We want to make sure that all of these are true. And they should automatically stop, right? Or they should go back to false because this puff, or this emission thing, is on one shot, right? And it should only last like half a second or whatever amount of seconds, right? So now if I hit play, we should be able to move around, and we have to turn on the animation player again. So let's try that. All right, and now we should be able to run, and you can see the puff. There we go. So it's kind of a decent effect where the puff is showing. Now, do keep in mind, you're more than welcome to adjust the time of the puff, right? You may want to do that where the time maybe is less. So like this, like that, right? So it's a little faster. It's up to you. I would kind of let you figure that out. I might actually leave mine at 0.1, so it's a little quicker or something like that. Let's try that one more time and see what we get. All right, so it's a little better, but yeah, so I'll kind of let you play around with the puff effects, and yeah. All right, so now what we can do is head into our level up. Now the level up, if we make this local, we will find here that we just have an animation player. Now, okay, what we need to do for the level up is, I think you might imagine, is what we need to do is essentially find out when we level up. How can we do this? Well, in our script, let's close everything so it's a little more organized. In our game, if you recall, we created this signal, this custom-made signal. So what we can do is, well, add this in, right? So we can emit another signal called level up. And here we don't need to pass anything through. so it doesn't really matter. And on the bottom, this is how we emitted a signal, right? Now what we can do is do the exact same thing, but right here. So every time I level up, I will emit the signal. Level, I'll put it all lowercase, level up, right? So this is how we emit a signal. Not the question is, how do we connect a signal? Well, if we connect, we will find this is how we connected a signal the first time. So we can do the same thing, but of course we'll have to copy this as well. So let me pop this out so it's a bit easier. We'll copy this code. And now if we head into our player script, let's open the player script. And now what we can do is in the ready function, we'll copy paste this, and we can now get the game node. And now instead of the health changed, we want to get the level up. We'll connect the level up, and we'll connect it to on level up. So we'll create a new function at the very bottom. And now here we can say function level up, and we can now play the level up animation. And we can do that by just dragging in, open our script here, we'll open it up right here, and we will, pass through this animation player. That's the path. So now I can just copy this, get node, animation player dot play init. So the initialize is called init, and that will play the level up animation. Okay, so now let's give this a test. Now, one thing I do want to emphasize is that we cannot actually just gain XP here. We do have to actually go into our game and see if we can kill something. So let's go kill something and see if we can level up. Let me equip a weapon so that way I do much more damage. All right, let's kill this guy. Didn't work. All right, there we go. There's my level up. All right, now, obviously, one thing that you can do is add a level up sound. We're not going to do that in this series, obviously, but feel free. But this is cool. We have a level up effect, and we also have our puff run. So, of course, feel free to adjust them accordingly to your game. But yeah, so that's it for the level up. Now let's take a look at the hit and the puff big, because these are going to go into the monster. All right, now we want to open up our monster, one of them. I'm only going to do one, actually, so I'm going to show you how to implement one of the monsters. And then I'll kind of let you do the rest and, implement whatever you want, wherever you want. So let's find the monster scenes. I'll put it in the skeleton. All right, so the first thing we'll do is, of course, I'm going to import or bring in these effects. So at the bottom, we will bring in the puff effect and the hit effect. All right, so now both of these I will reset to 0. However, the hit effect, or the actual hit effect, here, let's make this one local, because this is the hit effect that we want to import. Oh, no, sorry, this is the puff effect. So this one right here is the hit effect that we'll use, right? This I want to use on the sword. So we're going to take this guy, and we're going to actually drag this up. We're going to drag it right here for now, and find the hand slot. And we'll pop that right in. And I'm going to move it to kind of the tip of the sword, like so. So that way, now, hit effect. Now I can use this effect at the sword, right? So wherever it hits it on the player, that's where the effect will show up. So now what I can do is in the skeleton, in the body right here, we can just do that. So it's really easy. We get the path, and I'll just say get node instead. Here we go. Then pop this out. Okay, here we go. We got the animation player, and then we play the hit effect. All right. Next, what we can do is, let's just make sure that's hit. Okay. Now for this one right here, this will be played for the death effect. So for the death effect, let's first find the death. Here we go. The death, we have a function for it. Now in here, instead of queuing free, right, what we'll do is we'll play this one is also called hit. So let me just make sure that this is the right one. Okay, so this is our effect that we'll want to play. Once it's finished, right, then we'll queue free. So we'll just get this. Very easy. We'll just copy paste the path. Say get node. Here we go. Play. Play hit. All right. Now what we can do, as always, is just await that function's animation player. So we will await the animation player for the animation finished signal. And then once it's finished, then we will self-queue free. All right, let's take a look and see if this works. Let's play. We will go into our game here. We'll full screen, and I'll show you actually how to make this better in just a second. So we'll go to our monsters here. Let's find a warrior for obvious reasons. That's the one we're testing. All right, so let's see if the hit effect works. Okay, it does, and it works pretty nicely. Okay, and if I kill it, it plays the death effect, and then it should disappear. Cool. We now have a very cool game. We have some nice effects. We have some cool hit effects. It should hit me here, right? So there's a cool hit effect. It shows up on the sword and kind of where I should be, right? Now, of course, feel free to add that hit effect to the player. I'm, not going to show you because, well, you should know by now. It's not too difficult. It's just a get node.play. And, at this point, we've been talking for about 7-8 hours. You should be relatively proficient in this now. So, okay, let's take a look at how to make this screen a little bigger. So in our project settings, we will find the Windows tab. In here, we will find the stretch, and we want to put this on canvas items. So if I close and hit play, it should now, when I full screen this, become bigger with my actual screen here. So now when I play, the UI is the same size, right? So I can go to the profile, the inventory, etc. And yeah, so that is pretty much it. I hope you guys enjoyed this course. So yeah.
Congratulations, you have completed this course. This course was not very easy. It was really long and it had a lot of stuff in it. I just wanted to say one more time, congratulations, you really deserve it. This was a almost 8-hour course, so really good job on completing this course. Now, what are the future steps? For your future steps, or for what to do next, you have a few options that I will hopefully give you. Now, a few of them are paid, so just forewarning. Now, I'll kind of start with the free stuff. So the free stuff, of course, is I have several free tutorials similar to this one, so you can check those out on my channel. I have some courses that are similar to this as well, that are paid as well, of course, so you can check those out. So the general idea is that you can continue to create and keep following along these tutorials where they're kind of code along videos where you would just follow me along and I will show you how to make a game where I pretty much have designed everything already for you, and I'll just kind of be showing you how to use the engine. We'll be going through many different features and stuff like that, right? So that's one option. Now, another option is, what if you want to make your own game? That's also a good option. So that's what a lot of people tend to opt for, and that's probably a better option, I would say, as it gets you out of this area that people like to call tutorial hell. So to get out of this tutorial hell, or to not go in there at all, you can start thinking of your own little game that you want to create and how you can do that. Now, to do that, a free option that I kind of have is, what you can do is start thinking of little features and try to do them. Now, on my channel, I do show you small little features similar to these. So for example, if you want to create a ladder, I have a ladder video. If you want to see how do you use a specific node, I have several videos on those, right? Like how to use a tile map, those kind of things. I also have some grid videos. Those are pretty popular. So some people like to do grid movement, like Pokemon. Those kind of things are very popular. So I have some videos on those. You can check them out on my channel on KwintenH. Again, I really do encourage you to check my channel out. Now the third option is a kind of similar choice. Now the third option is more a bit of practice, kind of weekly practice. This is something that I do and I've been doing for about the last 3-4 months. And it's been working pretty well. I think a lot of people enjoy it. Essentially what they are weekly challenges where I will be sending out a weekly challenge on my email list or on my Patreon, well, both. So you can definitely check one of the two out. The email list is free. The Patreon is paid for, I think the minimum is $5 a month. So definitely check that out. And yeah, so that's essentially what I'll do. So essentially I will be sending you a challenge. So what these challenges will look like is a kind of detailed description of a specific thing. So in my case, the latter one was actually a weekly challenge. So for example, I will send you a weekly challenge or a weekly description to create a ladder inside of Godot. So after that, about a week later, And exactly a week later on Sundays, I will be sending out the solution and the new challenge. So every week I'll be sending out a new challenge and the solution to the previous challenge. So this is a good way to keep, keep learning every week and keep doing these small little things that will hopefully help you to learn and eventually create your own game. So, that's the end goal, is for you to hopefully become an indie developer, to create your own game. So hopefully I can help you get there. And definitely check out my channel, Coding Quest, and my website. I will see you all in the future. All right.